So as mentioned, we are working on the math grade 12, May, June 2019, paper 2 exam memo. So to start off, what do we have here? We have question 1. Now with statistics, you just have to be calm. You know, you also have to use your calculator as best as you can, literally all the time. Just have your calculator at hand. So with this question here, let's see, it says each child in a group of 4-year-old children was given the same puzzle. So you have a group of children, right? It says that each child in a group of 4-year-old children. Let me add Yefron Wabi so you saw. So thus we can carry on. Go back there. It says that each child in a group of 4-year-old children was given the same puzzle to complete. The time taken in minutes by each child to complete the puzzle is shown in the table below. So they took like a group of children, right? A group of 4-year-olds, and then they gave them a puzzle to complete. And then they timed how long each child took to complete a puzzle. So this is how you interpret this table. This says here, time taken in minutes, and then this says number of children. So the number of children that took between 2 to 6 minutes to complete the puzzle is just 2 children, which kind of makes sense because I mean, like, this is showing the number of children that like completed the puzzle in the least amount of time. So that's why there are so few. And then between 6 minutes and 10, we have 10 children. So we can clearly see that this is something that we refer to as the modal class. Modal class. The modal class is between 6 and 10. You see, that's the modal class. The modal class is between 6 and 10 because that's the class where you have the highest number of children. So moving on, with this table, right, they then said how many children completed the puzzle. I mean, like, this one is a straightforward question. We have 2 plus 10, which is 12, plus, I might as well just use the calculator because mental math is not the most reliable thing. Like, you know, this whole thing of doing mental math, trust me, it's do it at your own risk. So 2 plus 10 plus 9 plus 7 plus 8 plus 7 again plus 2. So we have here 45, and you know, I'm just gonna let me just double check the numbers again because you can never double check enough, you know. 1, 2, 3, 4, 5, 6, 7. Yeah, everything looks all good in the calculator. So we have a total of 45 children. You see, 45. That's gonna give you 1 mark. Nothing crazy, nothing major. Now, the next question here. For 2 marks, calculate the estimated mean time taken to complete the puzzle. So when you're going to calculate the mean, I mean, like, I would have at least almost wanted them to at least be giving us like 3 marks for this question, maybe even like 4. Because when you calculate the mean for data that is in this way, this is what you need to do. Firstly, you need to get the midpoint of each model class first. That's step number 1. So the midpoint of each of these between 6 and 2, right? I mean, all you're going to do is you're going to say 2 plus 6 and then divide by 2. So between 2 and 6, the middle there is a 4. There you go. And then here, 6 plus 10 divided by 2, you're going to have 8. And then 10 plus 14 divided by 2. Let me just add these. So whoever these, just do that, carry on. So here, 10 plus 14 divided by 2, that's going to give us a 12. And then 14 plus 18 divided by 2, that's going to give us like a 16. 18 plus 22 divided by 2, that's a 20. There, I think we're going to have like a 24. And then here, I think we're going to have... I'm going, let me or just be nice. Oh, there we go. Muted. Ha 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 ha. Read my mind. But anyway, so since now we have all the midpoints of all these classes, right? All you now do is you take each midpoint and you multiply it by the number of children that you have. You see, that's step number 2. So step number 1 was this. Let me actually just maybe, you know, put it nicely so that everyone will be able to like see, you know. So this is step 1 there, which was us getting the midpoints. And then step 2 is us taking the midpoints and then multiplying it with the number of children, right? Which is giving us this answer. So here 2 times what is this? 4 times 2 is 8. This is 80. Let me just put all this. So the funny thing is, right, I mean, I'm doing this manually, but then as I'm doing it manually, I'm remembering to myself, but wait, bro, there's like there's what? There's a way you can do it in the calculator. But then for classes, I think it's gonna be less of a mess if you just do it manually. Let's see here. 12 times 9. What does 12 times 9 give us? 12 times 9 gives us 108. 16 times 7. I think we'll do the calculator one just now, you know. I think I'll remember it. 20 times 8 is like 160. 7 times 24 is like 168. And then 2 times 28 is like 56, you see. So this is obviously step 3. Step 3 is getting all these answers, you see. And then, so the next step, which is more or less almost like the final step. So all you're going to do now is you're going to take all these numbers, right? And then you're going to add them together, you see. So that's going to be step number 4. Let me just write here step 4. So step 4, you're going to take all these and you add them up in your calculator. So that's like 8 plus 80 plus 108 plus 112 plus 160 plus 168 plus 56. That's going to give us a total of 692, you see. So the 692, you're going to divide it by the number of children, you see. That's like 45 children. So that's step number 4, right? And then obviously step number 5 is just, I mean, like, I don't think we need to add a step 5 here. We just have to get an answer here. 692 divided by 45. So the mean time is just going to be 15.38, you see. So, I mean, like, when they say estimated, it means that we can just round this up or round it down. I think it should be fine. So because, I mean, like, it's 15.38, we can just approximate this to 15 minutes. You see, this is the what you may call the estimated mean time. So this estimated mean time, as mentioned already, right? This is something that we can actually get using using the calculator. You see, so using the calculator, I'm just going to show you how to do that. And then because you have seen how to do it manually, you will most probably then appreciate the calculator method better, you see, because the calculator method just requires you to like put in your data in a certain way in your calculator. And then once you've put in your data in your calculator, I mean, like, you are good to go. So let me just showcase the calculator method now. And in terms of me referring to the calculator method, you will be able to use this method if you are using the Casio calculator, like, you know, the normal generic Casio calculator, just in case you're wondering. So let me try and remember here. Let me put here calculator. Let me do this. Calculator. But before I carry on, if there are any questions on what we have written down so far, now is your time to shine, because I mean, like, once we move on, I mean, even if we do move on, you'll still be able to ask whatever question you want to ask. But then I just want to make it clear that you can always ask a question if you feel as though you need to ask it, you know, without feeling like, I don't know, without feeling like you would be interrupting someone or whatever. If you have any question, like, you can always ask whenever it is that you want to ask. So anyways, let me also go back here, see if there are any questions that were like typed out. Nope, no questions, no nothing. So I think we shall carry on with whatever it is that we are doing. So if you're going to use your calculator for this method, right, it's actually quite simple, you see. So this is the first thing that you need to do. In your calculator, you're gonna press the mode button, you see. So you're gonna press mode. Do you really just press mode only? No, man. No. I think it's shift mode. Let me just try and see here. If I don't remember it now, then I'll just talk about it some other day. Because obviously right now, if I'm going to use whatever method I'm going to use now, I need to remember it. If I don't remember it, then I suggest we should just move on. But let me just see here if I'm gonna remember it now. Shift clear, everything all. Yes. If you're hearing me talk now, I'm just busy on the calculator. So I'm not writing down anything at the moment. I'm just trying to see if I can get that other. Yes. I get it now. I think I know. I remember. Okay, yeah. So the first thing that you're gonna do is you're gonna press shift actually. So you're gonna press shift on your calculator. After pressing shift, you're going to then press mode. You see. So if you press shift and mode, what you then need to do is you need to scroll down. Scroll down. You see, when you scroll down, you need to choose option 3. Option 3 says stat. You see, so if you choose that option 3 after scrolling down, it's going to ask you to switch on the frequency. It's going to pop up a question mark which says frequency, and then all you have to do is to switch on the frequency. Frequency has to be on, you see, because frequency being on is taking into account this data here, you see. So once that frequency is on, you're going to press mode and then stat again. So you get, after this is on, right, you're going to click on mode, and then you're going to click on stat, and then you're going to click on where it says var. You see, the moment you click on where it says var, you're going to see that a table comes out. A table comes out which shows you something like this. It shows X here and it shows frequency over here. You see, which is what you want. So inside the column where it says X, right, you will be subbing in your midpoints. You see, the column where it says X, you will be subbing in your midpoints. You see, let me just try and get this color going. So in this column here, you're going to put in your midpoints, right? So our midpoints, as you can see, it's like 4, 8, 12, blah, 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 blah. So let's do that. 4, and then equal to 4, 8, equal to 12, equal to 16. And then it's like what? 20. And then you have 24. And then you have 28. I feel like, yeah, 7 numbers. 1, 2, 3, 4, 5, 6, 7. And then you're just going to go back up in the frequency column. And then you're going to put in the 2 first, and then the 10. And then what we have? 9. And then we have 7. And then we have 8. And then we have 7 again. And then you have 2. Perfect. So after you've subbed in all your data, right, now you're home free. Because as long as you've subbed in all your data, let me just carry on from here. So as long as all your data is subbed in, right, you're going to click the on button. You see, you're going to click on here. So let's just show that you have subbed in all your data here. All your data. And then the frequency part, you're also just going to put that in there. So all your data, blah, blah, blah. And then you're just going to click on, right? And then after clicking on, you're going to press shift and then the number 1. So you're going to press shift and then button number 1 on your calculator. And then obviously you're going to now go to var. Is it var? Yep, you're going to go to var. And then from there, you're going to click on the option that says number 2, because that's the option that gives you the mean. So if you click on 2, your answer there is going to pop out as 15.38 as well. You see, and then you can approximate it to 15 minutes. You see, so this symbol, remember, means approximately. So this is the calculator version of this manual version. You see, because the calculator will just need you to have your midpoints and it will need you to have the frequency. You see, that's why the calculator gives you 2 columns. It gives you 1 column and then another column. If you sub in that data, your calculator just gives you whatever else you will need from it. So I think that is good. It's good. It's good that we have showed both methods, so that now you can just decide what it is that you want to do. If there are any questions, feel free. You can always switch on your mic whenever and then just ask, and then I will answer your question. For now, let us move on to, yeah, I hear Mike. Let's hear it.
What numbers do you apply for the frequency column? I didn't get that part.
Oh yeah, so the frequency column is these numbers, the 2, 10, 9, 7, 8, 7, and 2. Because remember, this is telling you so for the 4 minutes, how many children? For the 8 minutes, how many children? For the 12, how many children? You see, that's the frequency. The frequency is this column here.
Oh, okay.
Yeah. And then
and the X?
And then the first column here is the midpoint of each of these in our model, in our classes, you see. So from 2 to 6, the midpoint there is a 4. From 6 to 10, you have to get the midpoint. From 10 to 14, you have to get the midpoint. For all of these, you have to get the midpoint. And to do that, you just add the two numbers together, and then you divide by 2, you see. So 2 plus 6 here, divide by 2 is the 4, going on and on and on. So this is your first column, and then this is your second column. And then your calculator just does the rest for you. Because you see, your calculator multiplies them together, your calculator adds these together, and then your calculator also divides by the 45. All that it does for you. But then you are also able to do it manually if you want to.
Okay, thank you.
Cool stuff. Let me actually not remove that thing. But anyway, so for the next question, it says complete the cumulative frequency column in the table given in the answer book. So the cumulative frequency column, it's all coming from the frequency column. So what that means is, in your frequency column, right, you have the numbers here, 1, 2, 3, 4, 5, 6, 7, right? The numbers you have here in your cumulative frequency column, it's numbers like 2, 10, 9, and then you have 7, 8, 7, 2. 7, 8, 7, 2. So this is the frequency column. You see, this column here. Let me just do this, and then on top here, let me put frequency. Frequency. This is the frequency column. So from the frequency column, you're always able to generate the cumulative frequency column. So the cumulative frequency column is just referring to you telling up these numbers, like adding them up one by one. So in this cumulative frequency column, cumulative frequency, how many marks are they going to give us? They're going to give us 2 marks. Fine. In this cumulative frequency column, all you're going to have to do is you're going to start with the number at the top, and you're going to add these down here one by one. So from 2, you have not added anything yet. So you still just have 2. You see? So you're just going to say 2 plus 10 gives you 12. 12 plus 9 gives you 21. Plus 7 gives you 28. And then plus 8, what does it give us? Calculator, do your thing. Gives us 36. And then plus 7, it gives us 43. And then plus 2, it gives us 45. You see, which kind of makes sense because in the beginning we added up and showed that everything adds up to 45. So the cumulative frequency column just tallies up the items bit by bit, you know, one after the other. That's what these 2 marks, that's where these 2 marks are going to come from. And these kinds of questions, they should highlight that, you know what, now with paper 2, the first 2 questions, you should just be blazing through them, you know, just be getting these marks because there is really no reason not to get them. You see, it's just a matter of understanding what the questions are asking. So that's that for 2 marks. For 3 marks, what do they want? They say to draw a cumulative frequency graph, which is an ogive, to represent the data on the grid provided in the answer book. So drawing your ogive, what you need to keep in mind is that to draw your ogive, right, you always need this in your x-axis, and then your cumulative frequency part, this will be in your y-axis. It will make sense just now. So when you draw your ogive, right, you're always going to have a y-axis, and you're always going to have an x-axis. So in the x-axis, you always put in your different classes, you see. So you can see here, you're going to have to go from somewhere like 2 to 30. So in here, you just want to have a scale. So when I say you just want to have a scale, we can see here, this is just going up in 4s, you see. From 2 to 6, that's a 4. 6 to 10, that's 4, 4, 4, 4, 4, 4. So what you may want to do for yourself is you may want to think to yourself, okay, fine. I mean, like from here to there, we should take into account about 30. Let me actually extend this a bit, you know, because like, why am I making it so small? Like, good Lord. Yep, I wonder who's joining now because, hey, now we're just going to keep cruising. Like, yeah, it's just like that. But anyways, so let me just extend this here so that we have like quite a lot of space, because there's no need for us to like, you know, play like we don't have space here. So with all this, let me actually make this a bit higher. Yeah, what just happened? Oh my goodness. There we go. So let's just do this. There we go. Make this like this. There we go. So what we're going to do is always on the x-axis, you're going to put your different classes. On the y-axis, you always put in your cumulative frequency numbers. So you're always going to have a scale for these numbers here. So from 2 to 45, it looks like you can go up in 5s here. Going up in 5s here, it looks like it's fine. Let's see, 5, 10, 15, 20, 25, 30, 35. Yeah, 5s seem like they're going to be fine. So let's put like a 5 here, 10, 15, 20, 25, 30, 35, 40, and let's put up the 45. So 5, 10, 15, 20, 25, 30, 35, 40, and then he saw 45. So that's on the y-axis, right? On the y-axis here, we have our different classes, you see. So the y-axis, we basically just have time. Whoa, time. On the x-axis, we will have our cumulative frequency, you see, of which this is just representing the number of children, you see. So let's put here, even if you wrote cumulative frequency here, I don't think it's a big deal, really. So you can put here number of children. Number of children. And we said our cumulative frequency section here, right? We already drew up a scale, fine. And then for our different classes here, our scale, yeah, if we put like a 2 here, let's put a 2 somewhere here, right? Well, let's see here. If this is from, let's say from 0, you always want to make sure your graph starts from 0. If this is 0 to like 30, what we can already see is like in the middle here, we're going to have like 15, right? And then it looks as though, let's see, 5, 10, 15. So we might as well put like a 5 over here, might as well put like a 10 over there. 15, 20 here, and then 25 over there. I mean, not 20, and then 25, you see. So already the way this data is set up, I mean, here you can now be a bit creative, obviously. So you want to, you see here, it's from 2 to 6, 6 to 10, going on and on and on. It's moving up in 4s. So, I mean, like, let's say here, this could be easily be like 6 would be like somewhere. Hey, I feel like if I had grid paper, this was not going to be too much of an issue. But then what I'm trying to say is you just want your scale to like work with you. So let's see, you have numbers like 10, 14, 18, 22, 26, and 30. So let's just get an idea of where those numbers would generally be. So 6 would be somewhere over here, and then 10 is there, fine. 18, let's see here, 16, 17, 18 would be like somewhere over there. 21, 22 would be like somewhere over there. And then let's see what else we have there. 26 and 30. So let's see here. 26 would roughly be like somewhere over there, you see, because you want to just get an idea of like where your classes would fall under. So if this is like 1, 2 would be like somewhere there, you see. So from 2 to 6, 6 to 10, and then what we have 10 to 14. So 14 would obviously be before the 15 over there. So 14 would like fall somewhere over there. 14 to 18, 18 to 22, 22 to 26. Okay, perfect. So don't worry about me writing all this here. I mean, like, you will have a grid paper, so you'll be able to like even do one by one, like 1, 2, 3, 4, 5, all the way to 30. So all this has done is we now have what you may call our x and y axis, right? Now, in terms of you plotting points on this x and y axis, always make use of, let me get this data here. Always make use of two things. Let me actually copy these numbers because we need these numbers. Copy. So in terms of plotting stuff on your what you may call, on your archive, right? Always make use of your different classes and your cumulative frequency data. Let me remove this here for now. So remember, these numbers here were from our cumulative frequency table, you see. So in terms of what you're going to plot on your what? On your Cartesian plane, you're always going to look at it this way. This will be the x value, this will be the y value. This will be the x value, y value, x value, y value, x value, y value, going on and on and on until you're done plotting everything. That's literally what you're going to do when you plot stuff on your archive. Always take these values here as the x values, and then always take this from the cumulative frequency. Let's put here q cumulative frequency. Always take these as the y values, always take these as the x values. Let me actually just copy these and then throw them somewhere down there, and then obviously swap them around so that we're not confusing ourselves here. So let me just find somewhere where I can paste our numbers here. I might as well just do it here. And then obviously, since these are the x values, we might as well write them first, you know, just for the vibes. Because why not? You see, so these are our coordinates here. 6 coordinate 2 going on and on and on and on and on. That's what you're going to plot on your archive or on your what you call on your x and y axis here. So what we can already see here is x value is a 6 and then y value is a 2. So that will be somewhere there. And then here we need 10 and 12. So that's like 10 and 12 is like somewhere over there. And then here we need 14 and 21. 14 and 21. I should have actually just used grid paper, but hey, somebody thought they were creative, but nope. I should have just gotten grid paper. But anyways, 18 and 28. So it's like 18. 28 is just before the 30. So it's like somewhere there. 22 and 36. 22, 36 is like after the 35. So somewhere over there. 26 and 46. 22. Wait, no, I did 22. So we need 26 and 46. No, 43. 43 is like also. And then we need 30 and 45. So 30 is somewhere there. 45 is like right at the tippy top there. So this should be fine. Your archive, always make sure you like ground it to 0 here. So you're just gonna draw your line, and you don't have to do it all in one go. You can even do some, you know, some funny shandies where you're like sketching your line and stuff. I always do that myself, you see. So you can always see here, this is gonna go like that, and then it's gonna go up, and then it's gonna go like that. So don't mind how this is not gonna look very nice. I mean, like if you have grid paper, this is gonna come out like super nice, you see. So this is what our archive would look like. You see, this is more like a curve over there, and then towards the top, it like, you know, starts to like bail out over there. So yeah, that is that. I do wish I'd used grid paper. I wish I also had given myself more space here. But then yeah, that's how you're going to draw your archive. The sad thing is that they're only giving you 3 marks here. But remember, the scale and everything, you'll normally have it if you are using grid paper, and if you're not like if you're not doing what I just did here, where you just have a blank page and it's like, you know, yeah. But anyways, let us move on with whatever it is that we need to move on with. So it says here, use the graph to determine the median time to complete the puzzle. So I think with this question in particular, what you can pay attention to is like, you know, the method we're using, because I mean, like our graph is not very to scale over there, so it might not be the nicest. Wait, questions. Oh goodness, there's questions everywhere. Can I show a quicker way? Oh, I don't know if was that for the For the what? I think that was for the what? I don't know if that was the question we ended up using a calculator. It says here for the calculator, what do I use for? Oh, I think we answered this question, and then it's can we go through the steps again? Okay, okay. So since I'm looking at these questions, yeah, I think as I said, right, the easiest thing to do is to just switch on your mic and like ask a question. Because literally, I'm looking at these, I'm like, wait a minute, when were these even asked? So if you still have these questions in your head, you can ask them now, and then I will answer them. But then if you don't have any of those questions anymore, then we're gonna carry on. So again, don't mind me. You can always switch on your mic. Don't be scared. Nobody is going to, yeah, nothing. So anyways, it says here, use the graph to determine the median time. So the key word here is median time, right? Median time. Use the graph to determine the median time taken to complete the puzzle. So the median time will always come from what you may call, what's the easiest way to put this without doing anything crazy or fancy or whatever. So what's the easiest way to put this without like using any, what question is this? This is like this is what, 5, this question 1 point what you may call 0.5. So because they want us to, they said use the graph. So if you're going to use your graph, right, to get the median time, then what you need to do is you need to be very careful. Now the strange thing with wait a minute, what did I do here? Oh yeah, cumulative frequency, perfect, and then number of children. I'm actually looking at this graph again and I'm thinking to myself, wait, dude, like what is going on? Draw a cumulative frequency graph to represent the data on the grid. Oh, dang it. No. This is not number of children. This is the time. I think I just labeled this incorrectly. I think that's why my brain was a bit buzzing out. Because remember, this here is the number of minutes. I wrote number of children. But then, yeah, I think I swapped these. I swapped them in labels, but then in terms of the numbers, everything is fine. So let me just put this here, number of children, dot, and then this is the time. Yeah, I think my brain was a bit, yeah, it was not working properly, but it's working properly now because this is fixed. Because when I was looking at the median time here, I was thinking to myself, wait a minute, for the median time, we need to use the x-axis. But then the x-axis was written number of children here. So I think that's what was confusing me a bit. But everything is fine now. I had just mislabeled these two. So remember from here, 0 to 30, this is definitely time, according to our data here, you see. From time, it goes up to 30, and then on the children's side, they go up to 45. So everything is fine now. So it's going to be easier to answer this median question. So since they're asking us to get the median time, right? They said use the graph to determine the median time taken to complete the puzzle. So to be honest, this is more like a really dumb question, in my opinion. I mean the reason why it's a bit of a dumb question is, okay, no, it's not a dumb question. Let me not be that guy. So what you're gonna do for this kind of a question, right? Let me also just double check if there are any questions. Okay, no questions. I can just carry on as well. So what you're going to do for this kind of a question, you have to be a bit careful. You see, because if you're not careful when answering these kinds of questions, yeah, you end up messing up a bit. So whenever you need to work out the median, remember the median is technically quartile number 2. You see, I'll repeat, the median comes from quartile 2. So the median, let me write it out in words. Median comes from Q2, you see. So before you can work out the median time, right, you need to work out what Q2 is. So Q2 is going to tell you where the middle is if you're going to be looking at, let me put it this way. So if you look at these children, right, from like the very first one to like the 45th one, you see, your median is going to be right in the middle. of which for us to find the median, we're always just going to use a formula. And then from the formula, we can use our graph. So I'll repeat. What we need to do is we need to get the median from 0 to 45. You see, between 0 kids to 45, we have to get the median here first. And then once we get the median here, we need to trace it to our graph, and then we need to trace it down to the time. You see, let's say that in small, in like what you may call, let's say that's slower. For us to get the median time, we have to get the median of the children first. The median of the children is just Q2. We have to get the middle of this data. Once we get the middle of this data, we have to trace that value to our graph, and then we have to trace it down to our time. That's the median time. So for us to get the middle here between 0 to 45, right, you have to be careful. You have to get Q2. Q2, you always use this formula, 2 over 4, and then n plus 1, like this. This will always give you the middle of your data. So n will always represent everything in total, of which everything in total is like 45. So this number here is 20, hey, calculator please, is 23. So what this is telling us is between 0 and 45, right? We have to go to where 23 is. 23, we're going to find it like somewhere over there. You see, that's where Q2 is. That's where the median is, right? However, they want the median time. So we have gotten the median here. What you then need to do is you need to trace this number to your graph like this. And then after tracing that number to your graph, you then need to like trace it down to the time. So this is like freaky, but your median time here is 15 minutes, you see. So you just have to be careful. It's a coincidence that the 15 part is between the 0 and the 30. It's purely a coincidence, you see. So to recap the steps, they wanted the median time. So what you do is you get the median of your cumulative frequency. You see, to get the median of your cumulative frequency, you just use this formula, 2 over 4, and then bracket n plus 1, which is giving us 23. So what this is telling us is between 0 and 45, right? In the middle is like a 23. So you're going to go to where 23 is, trace it to your graph, trace it down to your time. So here we can say, therefore, median time is 15 minutes, 15 minutes. There you go. And then that will be that for this question. Anyways, question number two. So question number two is probably going to be like the grade 12 statistics, you know, like the what do they call it? The regression line, blah, 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 that stuff. So with the stats section, I mean, in total, we have 10 here. And then the first question was out of 10 as well. So that's like 20 out of 150. 20 out of 150. How many marks is that? I mean, as a percentage, let's see, 20 over 150 times 100. 20 over 150 times 100. It's a good 13.3%. You see, of which 13.3% divided by 2, that's almost like 7% of your entire math mark. So you can see how these statistics questions, they're simple, yes, but I mean, like they contribute, They contribute a lot. So anyways, it says here, learners who scored a mark below 50 in math, in a mathematics test, were selected to use a computer-based program as part of an intervention strategy. And then it says here, on completing the program, these learners wrote a second test to determine the effectiveness of the intervention strategy. Yeah, this question, it's like they repeat, like, yeah, Simon. And then it says here, the mark as a percentage scored by 15 of these learners in both tests is given in the table below. Okay, fine. So we have learner number 1, 2, 3, 4, until 15. So test number 1, there we go. And then after the program, these are the new marks. So before we even answer any questions, I mean, like, just by looking at the data, it looks as though the program really helped because the marks are increasing here. You see, the marks clearly are increasing. Computer-based program, online courses. Okay, yeah, probably not, but that's my best bet, man. Like, I mean, it's a computer-based program, so it is what it is. Those things work. But anyways, oh yeah, if you're not enrolled onto the courses, I mean, like, you can just find them on this website. Dart is dart. Don't say I never plugged you. Let's see. So 2.1 here says determine the equation of the least squares regression line. So questions like these, I mean, like, yeah, it's just calculator work. You know, the equation of the least squares regression line, you just get it from your calculator, because in your calculator, you need to get a value for a and b. The equation in itself is y is equal to a plus bx. This is the equation of the least squares regression line. A and B, you get it from your calculator. You see, it's usually actually written out as capital letters, which is just weird. But hey, we don't make the rules, so we'll just follow them for now until we don't have to follow them anymore. But anyway, so putting all this into your calculator, what do you do? So obviously, because of the first question, you have to clear your calculator first. So to clear your calculator, you're just gonna press Shift and then the number 9. So let's just write here clear calculator. So to clear a calculator, just gonna press Shift and then the number 9. You see, and then obviously you're just gonna click on all, so that you can clear everything, so that it's like spotless. But anyways, after you have cleared your calculator, to get your A and the B value, you need to put your data into your calculator first. So that's the part that's like obviously a bit boring, but hey, just gotta do what you gotta do for those marks. So in your calculator, you're gonna press mode and then stat. So let me put your mode. Where is this thing now? Mode. And then you're gonna click on stat. What else are you gonna click? You're gonna click on the number 2 option, which says A plus BX. And then it's gonna give you this table. Ka-ching, ka-ching, ka-ching. So with this table given, what you are going to do now? Oh yeah, you're going to put your data. So the first one you can just make it X. The second one you can just make it Y. Yo, the part I've been dreading. Now I have to put all this in the calculator. 10, what? 18. So while I'm putting all this into the calculator, the one thing I can say about all this data being put into the calculator is that, yeah, don't play yourself, you know, in the sense that just make sure you don't like miss a number or put numbers incorrectly or whatever, because I mean, like, putting the wrong thing in your calculator now is gonna mess everything up. So you shouldn't be anxious about it. I'm just saying it should be something that you need to like be conscious of. And as I'm like putting all those numbers into this calculator, I'm literally thinking to myself, I kinda need to be talking the whole time. I don't need to, but I feel like I want to. Let's see, 33, 21, 32, 20, 58. What else is there? 43. Because I'm putting these and I'm thinking to myself, I should not make the mistake I'm referring to right now. 55, 50, 45. Okay, this is not that bad. Like, we're kind of done now already. So everything is in the calculator now. Kablamo. Perfecto. Nice. So with all this data in the calculator, right? You're gonna press the on button, on, and then you're gonna press again Shift, and then you're gonna press the number 1 button, because why not? And then what now? So Shift, number 1, and then you're gonna go to reg now. You see, remember the previous time we pressed bar, but now you're gonna click reg for least squares regression line. And then after that, it's gonna give you an option to choose A. Your A value according to your calculator is just gonna be 12.44. So you're gonna repeat the process, right? And then you're gonna choose B. Repeating the process from here. You say Shift 1, reg, and then you choose B afterwards. So on, Shift, number 1, reg, and then B. Your B there is just gonna be 0.98. So you see here your formula is then just gonna be Y is equal to 12.44 plus 0.98x. There you go. So this is going to make your life so much easier. Like, is going to have a party. So with statistics, I mean, like, it's literally there for the taking. 7% of your whole math mark is gonna come from statistics. So you better just get that, because that's like what? The difference between 63 and 70, the difference between 53 and a 60. It's a big deal. It's a big deal. So for 1 mark here, they said a learner's mark in the first test was 15 out of 50. So they have like 30%. You see, because 15 out of 50 times 100 is this. Then they said write down the learner's mark as a percentage. Wow. Okay, that's awkward. Maybe my subconscious saw the question, but weird. 15 over 50 times 100 is equal to 30. So that's the question. Yeah, weird. But that's for 1 mark. So nothing crazy, nothing major. Let me keep on moving forward, because why not, right? So we have a 2 mark question here. And what are they asking us? In this 2 mark question, they said predict the learner's mark for the second test. Give your answer to the nearest integer. So if you're going to predict the mark for the second test, it's basically a question that's like asking you to make use of the equation that you have like worked out. Because remember, the equation that you have worked out, it is basically an equation that is going to be used to predict marks. You're going to basically use it to predict data depending on what you give it. Because remember, in this equation, you can put in an x value or you can put in a y value, of which, remember here, the x value will be you putting data for like the first test. So if you're going to put, let's say, a specific mark here, right, it will give you a prediction of what a person could potentially get for the second test based on the equation. So that's what we're going to do here. For 2.2.2, predict the learner's mark in the second test. Give your answer to the nearest integer. So I mean, like, we know that in the first test, this person got 30. So here you have to be careful to use the 30. You see, that's why here I think this was a nice question for them to ask. Because remember, our data here is in percentages. You see, they told us here it's in percentages. So here, according to our equation, we just have to throw in the value of x as 30, and then we just use our equation and then get 2 marks. So these are some of the easiest 2 marks you will always ever be able to get. So let's see here. Y 12. Oh no, what is this now? 12.44, 0.98, x is a 30. All this in the calculator. Let's see what we are getting. So let's see. We is getting 42. What they say to the nearest integer, but then the calculator is giving us 41.84. But to the nearest integer, it means that your answer has to be a complete value. You see, your answer has to be a whole number. Anyways, that's for 2 marks. You've got 2 marks there, and you get the rest, because why not? Why not? You should always ask yourself that question. Why not? Why not? So anyways, it says here, for the 15 learners above, the mean mark of the second test is 45.67. That's the mean. The mean is the average, remember. So that being said, they said it is the mean mark and the standard deviation is 13.88. The teacher discovered that he forgot to add the marks of the last question to the total mark of each of these learners. Let's read that again. The teacher discovered that he forgot to add the marks of the last question of the total mark. No, he forgot to add the marks of the last question to the total mark of each of the learners' mark. Okay, so what that means is the test is out of 50, right? So maybe question number 8 was, let's say, out of 10. But then this whole thing was completely forgotten. So meaning, technically speaking, everyone's paper was like out of 40. And then that's the mark that was being used. No. Let me say this easier. The last question was not marked, you see. So every person was supposed to be graded out of 40. But instead of doing that, every person was still graded out of 50, you see. So every person being graded out of 50, whereas their last mark was not taken into account. When all that was done, this was the average and this was the standard deviation. They then said here, all the learners scored full marks in the last question. So every learner scored full marks in the last question. And then it says here, when the marks of the last question are added, the new mean is 50.67. So what they then did was, they went back to each question paper. They marked everyone's paper, and then everyone got the last question 100% correct. And then once they added up those new marks, they have a new average now. With all that being said, they say here, what is the standard deviation after the marks for the last question are added to each learner's total? And this is a 2-mark question. So I would say in our entire statistics questions, like all these questions that we've been doing, I think we can all safely say that this is more like the first question that's like, kind of, I don't know. I think it's the first question that's like low-key gonna make us think. But then this kind of a question is purely just based on data. And it's also purely based on your knowledge of what standard deviation is. Now, standard deviation, as a small definition, standard deviation gives you an idea of how far each piece of data is away from the mean. Let me say that in words, actually. Let me also maybe write it down. Because I remember in the statistics course, let me actually also bring that up so that we can also give an idea of like why it is why a person would want to like enroll onto like the what you may call the courses. Because in, for example, things like the statistics course, right? I mean, you can imagine you're going to bump through questions that work on standard deviation quite often. And in terms of a definition, I may write whatever I'm going to write now, but I do believe that the definition that I wrote out in the stats course is a bit shorter, and it's a bit more direct, and it's a bit more straight to the point. So I'm just going to scroll down to that definition now, because I know I'm going to be able to find it definitely. I think I wrote it out in purple or something. So I will definitely be able to find it. Let's see here, standard deviation, blah, blah, blah. Let's see here. There we go. Wait, no. Oh yeah, there it is. There's the definition. It's not in purple. So standard deviation, right, tells you on average how far each piece of data lies from the mean. I'll repeat. The standard deviation tells you on average how far each piece of data lies from the mean. So what that means is each piece of data here, where is this? Let's use the second column. Each piece of data here, right? Or let's use the first column since we have the average for the first column. For the first column, they told us that the average is 45.67. So if your mean is 45.67, the standard deviation is literally the following. What they'll do is they'll take the distance between 10 and this number, right? Which is like 35.67. And then they'll take the difference between 18 and this value, and they'll put that there. Then the distance between 23 and this value, they'll put that there. The distance between 24 and this value, they'll put that there. Between 27 and this value, going on and on and on until they've added everything, you see. They'll take all these, add them up, and then divide by the number of data you have. This is what standard deviation is, you see. Standard deviation just tells you on average how far each piece of data is away from the mean. So that being said, right, what has happened here in our description, what has happened is that they said everyone's mark increased by the same number, because that's what this is saying. When the marks of the last question are added, the new mean is this, right? But then here they said all the learners scored the same in the last question, or all the learners scored full marks. So what that means is, if you think of it nicely, let me explain this nicely, because if you can get this, then you're good to go. So if you think of it nicely, right, what has happened is this was the new standard deviation. Okay, this was the original standard deviation, 13.88, right? Yeah, let me just put 88 over there. 13.88 is the original standard deviation. Now what happened was each piece of data here increased by the same number. So you have to remember, if everything here increases by the same number, then it means that on average, the distance from the mean is not going to change. Because, I mean, you have to think to yourself, if everything increases by the same value, right? Everything here is increased by the exact same value. Everything has increased by the exact same value. We don't know what the exact same value is. It really doesn't matter right now. So if everything here increases by the exact same value, it means that on average, the distance from the mean, when you work it out, it's not going to change. You see, I'll repeat. If everything increases by the same number here, it means that on average, your distance from the mean is not going to change either. You see, because everything increased by the same number. So even though your mean itself is going to increase, the distance between each number and the mean is not going to increase at all, because everything increased by the same value. It's almost like saying you have the number 10 and the number 15, right? And you have the number 12 and the number 15. You have the number 8 and the number 15. You see, so if you look at it nicely, the distance between 10 and 15 is like 5. The distance between 12 and 15 is like 3. The distance between 8 and 15, let's see, that's like, I think, 7. You see, fine. This is the original distances. However, if all of these numbers here increase by, let's say, 3, if each of these numbers, let's say each of these numbers increase by 1. So let's say you have 11 here. Hold on, 11 here. Here you'll have 13. Here you'll have 9. So from 11 to what you may call, from 11 to 15, right, the distance there is just 4. And then from 13 to 15, the distance here is just 2. From 9 to 15, the distance there is just 6. You can see here, I mean, like, this has decreased by 1, this has decreased by 1, this has decreased by 1. So since the distances are all increasing by 1, if these marks all increase by 1, it is not going to affect your standard deviation, because your standard deviation is affected by how far each piece of data is away from the mean. So if each piece of data moves towards the mean at the same distance or at the same value, it's not going to affect your standard deviation. So in terms of this explanation, it's a bit all broken up and bit up and all that. But for 2 marks here, right, your answer here is literally still just going to be 13.88. The reason why your answer is 13.88 is because everything increased by the same value. If everything increases by the same value, your distance between each piece of data and the mean is also still going to be the same as it was originally. You see, because everything moved up by the same value. So you're not going to necessarily alter the standard deviation, because the standard deviation, as we said, it's only going to give you an idea of how far each piece of data is away from the mean. So if everything moves up by the same value, your standard deviation is not going to change. So for 2 marks, these are the kinds of things that you need to know. So obviously, I think this is one way of saying that if you need to get like other instances and other ways of like knowing how to deal with standard deviation, I mean, your best bet is obviously going to be the what you may call the statistics course, because I mean, like, we could spend here trying to think of, we could spend time here trying to think of other variations that these kinds of questions can be asked, and that's going to take forever. But then instead of doing that, you already know that in the statistics course, you definitely are going to bump into a lot of questions that are going to talk about standard deviation, like something like this. You see, whatever this question was, they were asking us here, we need to work out what has happened to the median. We gave a reason. Here they're asking what has happened to the standard deviation. We said here standard deviation decreases because more values in our data would be closer to the mean, going on and on and on. So this was a scenario where the different values were increased by what you may call by a specific value. differently. But then here, this is a scenario where all of them are increasing by the same value. So I could keep on blabbing forever here, but I choose to just do this last question and call it a day. But if there are any questions on what we spoke about here, you can always ask, because yeah, I do feel as though a lot of what was said for this specific question was just a bit like, huh, what? But it's one of those meh scenarios, just like meh, move on. Because for these kinds of questions, you do need your theory. It's not the kind of a question where if you know the answer, you automatically know what to do all the time, you see. So that's what I can say. But for now, let me just double check if there are any questions. Nope. So we can move on to the last question. With this last question for 2 marks, it says, what is the total of the last question? Okay, so this is obviously, I mean, it's really, it sounds like a weird question, but it really shouldn't bother you much, because look, from 45.67 to 50.67, I mean, like, if the original mean is 45.67 and the new mean is 50.67, this is clearly showing us that it's an increase of 5%. And this question is not so complicated, because remember, every person's mark increased by the same value, and we're seeing that the mean is increasing by 5%. And so we need to just think to ourselves, I mean, that's literally all we will have to do here. From 45.67, everyone increased by the same value, and this is the new mean. So if everyone increased by the same value, the mean is going to give us directly what that last question contributed. And that last question clearly just contributed 5%, because everyone's mark clearly went up by 5%. If everyone's mark went up by 5%, that's the only reason why the mean would go up by 5%.
Cool. Sorry, I have a question.
Yeah, bro.
So are they always gonna give us 13.88, or we have to sometimes like calculate it?
Oh yeah, we sometimes have to work out the 13.88. But then I think now you've asked the question, right? Something just popped in my head. Now, when I was saying that the standard deviation remains the same here, I think I have a better way of explaining it. So what you have to keep in mind is, right, everyone's mark was this number. And then everyone's mark clearly increased by 5%, right? 5%, 5%, 5%. So when everyone's mark increased by 5%, you have to remember that the mean also increased by 5%. So as the mark got closer to the, as each mark got 5% higher, the mean got 5% higher. So it means that the distance between each value and the mean for the original marks, and the distance between each value and the mean for the new marks is going to be exactly the same. Because when each value moved up by 5, the mean also moved up by 5. So it also then goes back to the fact that the standard deviation is going to stay the same. Because remember, we said our standard deviation is purely based on the distance between each piece of data and the mean. It says here, you see, standard deviation tells you on average how far each piece of data lies from the mean. So if each piece of data goes up by 5 and the mean also goes up by 5, it means that the distance between your data and your mean is going to stay the same anyways. Because as your data moved 5 units up, the mean also moved 5 units up. So the distance between the two is still exactly the same. That's why your standard deviation does not change if every piece of data moves up by 5. If every piece of data moves up by 5, the mean also moves up by 5, meaning that the distance between each piece of data and the mean is going to stay exactly the same. That's why your standard deviation stays the same for this question here. So I hope that makes better sense. Does everybody agree, or
Yeah,
are
it
there
does.
any
Thank
questions?
you.
In the diagram, A, where is A? So automatically, as long as you read something, just check where it is on the sketch. So A is this point, and then they said we have B here, and then we have C over there. And then they said we also have D. Remember, this is not a parallelogram. It looks like a trapezium because BC is not parallel to AD. So this is just a trapezium. but it doesn't matter. Oh, they said it here. They say that these are vertices of a trapezium with AB parallel to DC. Now, before we carry on, I mean, for some odd reason, I just think we should mention what the area of a trapezium is, in case you ever need it. You see, because that's like one formula that is hardly ever talked about. But in those very rare moments, you end up sometimes needing it. So let me just take a small detour and write out the area of a trapezium here. Area, so that you can just keep it somewhere so that you have it for whenever you need it. So let's write the area of a trapezium. How do you even spell trapezium now? Trapezium. Museum. So the area of a trapezium will always be half multiplied by it's always going to be the sum of the parallel lines, half multiplied by sum of parallel lines multiplied by the distance apart. This will always be the area of a trapezium. So if you have the length of one side and you have the length of the other side, if you're dealing with the sides that are parallel, so if you have this length here and you also have this length here, as long as you have those two, right, if you add up the lengths of those lines and you multiply it by the distance apart, which will be this distance here to that distance, and you multiply by half, that will always give you the area of the trapezium. So obviously with me saying this, I mean, like, it's always good to even like just double check it with Uncle Google, because the area of a trapezium, I mean, like, it's like super rare. So I'm just gonna double check for like 2 seconds, and then we'll just carry on with our question as though we have not even spoken about this. So what do I need to type here? Area of trapezium. So we can just double check if everything is right. So the formula, yeah, just this should give us an idea of what we wrote, to say that what we wrote is fine. Because here you can see it's going to be a half multiplied by a plus b. You see, a plus b is the sum of the parallel lines, you see, and then the h there is the distance between the parallel lines. So that's just the area of a trapezium, if you ever need it. I'm not saying we need it for this question. I just thought, because we're dealing with a trapezium, we might as well mention it, so that for some odd reason, whenever you ever need it, you know it, or you've written it out somewhere. So moving on, it then says here, right, we have the vertices of a trapezium with AB parallel to CD, fine. And then they said E is -2 coordinate 0. So E is a point here, which is the x-intercept. And then they said AB is the, E is the x-intercept of AB, right? So x-intercept of AB. And then it says here, the inclination of AB is alpha. So you have alpha there. So remember, your angle of inclination will always be the angle coming from the right. And you will always be going anti-clockwise, you see. So if you had, let's say, a line like this, your angle of inclination would be this one, you see, because it's always from the far right going anti-clockwise. But then anyways, moving on here, they said that we have alpha here, and then it says here K lies on the y-axis. There's point K over there, and then you have angle theta there. Okay, looks like we have enough information here. So with all this being said, they are asking for the midpoint EA. Oh, no, the midpoint of EC. So there's point E there, point C. The midpoint is really not an issue. So questions like this, you just blaze through them so that you don't find yourself wasting time. So this is just going to be -2 plus 2 over 2, according to the formula. And then 0 plus -3 over 2. So let's just quickly go through this question so that we go to like the more pressing matters. So this is going to give us a 0 over 2, which is just a 0. This is going to give us negative 3 over 2. So this being the midpoint, it's kind of believable because somewhere there, I mean, we can clearly see the x value is a 0, and then the y value there is just going to be negative 1.5. So that's not an issue. 3.1.2, they want the gradient of DC. That is also not an issue. So with all these simple questions, right, in your exam, obviously just clean them up. Just get what you need to get, and just get your marks. Don't make silly mistakes for these kinds of questions because you end up losing marks, you know, for the smallest of things. So the gradient of DC, we know that you can just say here negative 2, or y is at the start. So it's like negative 5 minus 3, so that's going to give us negative 5 minus 3, that's going to be a plus. And then negative 2 minus 2, that is going to give us a negative 4 at the bottom. At the top, we are going to have a negative 2, of which that's just a positive half, which makes sense because this line here is inclined going upwards. So we have the gradient of DC. We have the gradient of DC, and we have the midpoint of EC. Whatever they'll ask you, sometimes it's just random, but very rarely. The next question here, they're asking for the equation of AB in the form y is equal to mx plus c. So any equation of a straight line, it's always easy to start off with this format, because this format here reminds you that all you need is a gradient and a coordinate that the graph passes through. If you have that, you're good to go. So with DC, getting the equation of DC, we have a gradient already, and we already have a coordinate. We can just use the negative 2 and the negative 5 over there. So that's D, right? Negative 2. Oh, no, what am I doing? We need the equation of AB. I'm busy working with DC. I think what I was trying to say is, with DC and AB, the gradients are the same. So whatever gradient we worked out here, it's the gradient for AB. So we have the gradient, which is our M down here in our equation. Why is this thing stuck now? Oh, it's not stuck. So we have M. We just need a point that the graph passes through. We can choose E, which is negative 2 and 0. So Y is a 0, and then the X value is a negative 2. There we go. So I should have just put a plus there instead of adding an extra step, but it doesn't matter. So everything multiplied inside the bracket, we are getting here the equation of AB. Now, the one thing to take note of is that seeing that our y-intercept there is a positive 1, it means that this point here is a positive 1. So we automatically have B now. The x value is a 0, the y value is a positive 1, because this is just a y-intercept. Whether that's going to help us for something in the future, I mean, we don't know. Maybe, maybe not. So let's see here. The next question, I think hopefully we'll get to something interesting. But anyways, size of theta. Getting the size of theta, where's the sketch? So if we're going to get the size of theta, right, the last thing you want to do is to focus directly on theta. Because if you focus directly on theta, you might end up not getting your answer. So what you normally want to do is try and work with, you know, portions of the sketch that like form a triangle, and try to work with, you know, different properties of triangles. So I mean, like, just from looking at this, the one thing my brain is already thinking of is this is a straight line, and this is another straight line. Wait, hold on, if I can draw this better. And then lastly, this is also a straight line. So what we also know is that this is 90, you see. So we might as well make use of the fact that theta is just alpha plus 90, because theta here is just an exterior angle of a triangle. And that's how you want to look at most of these questions. Because if you just single out theta and you think that you're going to work it out, you know, using some fancy method or whatever, then you're going to have a problem. Most of the time, always lean into like basic theorems and basic laws of triangles and shapes and everything. So from the get-go here, whatever we know, I mean, I might as well write the question up here, because like scrolling up and down is just not going to work. So here, what we already know is that theta is equal to alpha plus 90. Like that we know. We don't even need to give a reason. If you want, you can, because just for the vibe. Exterior angle of a triangle. If you didn't, it's fine. But if you did, I mean, good for you, because it's analytical geometry anyway. So we have now gotten to a point where we can clearly see that our focus should just be to get alpha. You see, and to get alpha, we can just use this formula: 10 alpha is equal to the gradient. You see, because this is the angle of inclination. So our angle of inclination, we can get it from the gradient of line AB, and we have the gradient of line AB, just a half. So from here, we know that we can just get our alpha. You see, so from here we can get a reference angle, and then from the reference angle we can just by observation figure out what alpha is. So here we can see that our reference angle is going to be equal to shift 10 with a half. Let's see what we're going to get in the calculator here. So shift 10 with a half, that's giving us 26.57. 26.57. And as we can see with our own eyes, I mean, this is what the 26.57 is. You see, so here, therefore, alpha is just 26.57. You see, because remember, all this is to just help us figure out what angle this could possibly be. So we have alpha, which is just 26.57. So our value of theta there is just going to be 26.57 plus 90, which is just 100. What? No, I think it's 116.57. And that's our answer. So nothing crazy, nothing major. It just means we can carry on. So if there are any questions based on whatever it is that we have looked at so far, feel free to ask before we move on. If you have other, let's say if you feel maybe these questions are a bit simple, which they are, if you have something, a bit more advanced that you want to ask, please feel free to do that also. Because remember, what we're basically going through here is going through these past paper questions. But I think going through these past paper questions, it also highlights that in an exam, right, not everything is like up against you, there to just rob you of marks or whatever. No. You do have these kinds of questions that are there to just keep you reminded that, you know what, if you know certain things, you're going to at least walk away with some marks, which is why I think also it's important to always like go through full past papers as often as you can. Because when you go through full past papers as often as you can, your brain also stays reminded that, okay, wait a minute, these are some things that I also know. These are some things that I also know. And then it's going to help you stay a bit more calm. So if there are any questions, you can ask. If there are not, we can move on to question 3.2. They're talking about AB being parallel to BC. I mean, being perpendicular to BC. So, I mean, like, this one is simple. We just have to show that the gradient of the one line multiplied by the gradient of the other line is just equal to -1. So we have to tell them we know what B is. B is just 0 coordinate 1. See, so B, 0 coordinate 1. Our point C we were given. C is 2 coordinate -3. And then, I mean, we don't need A, because all we need is the gradient of BC and the gradient of AB. So all we now need to do here is the gradient of AB multiplied by the gradient of BC. We just have to show it's equal to -1. So getting the gradient of BC here is our only task, of which that's easy again. -3 minus 1, 2 minus 0, and then here -4/2, and then you have -2. So as I'm doing all this, right, I genuinely do feel like, these questions, they're just like way too simple. And it's even a bit annoying going through them, but not in a way like, oh snap, I don't want to be going through this. It's just one of those things where I'm like, you know what, man, yeah, it's a bit awkward because these questions are like, they're like a bit basic. But anyways, let me not be condescending. So with BC, it's a -2. With AB, the gradient there was a +1/2. So these two multiplied by each other is definitely giving you a -1/2. So this balances out. So you can say therefore AB is perpendicular to BC. Nothing crazy, nothing major. So for 1 mark now, they said the points E, B, and C lie on the circumference of a circle. So E, B, and C. Let's see where E, B, and C is. E, B, and C, they lie on the circumference of a circle. Okay, that's a coincidence, I guess. So if this is E, B, and C, let's actually just draw a triangle there because it looks like we're probably gonna need to. This is E, B, and then point C over there, right? So they told us that they lie on the circumference of a circle. Determine the center of the circle. So for 1 mark, I mean, this question is quite, it's not that crazy, but it looks like the center is gonna be this point here, you see, because remember, all math is linked. So if they're talking about point B here, point E there, and point C, and they're saying this is going to be on the circumference of a circle, then I mean, like, if it's going to be on a circumference, if these points are going to be on a circle, the center is obviously going to be the center of like EC. Let me just put C there. The center of EC is going to be where the center of the circle is, because the angle subtended by the diameter is a 90-degree angle, of which angle B here we've proven that it's a 90-degree angle. So the center here is just 0 coordinate negative 3/2, which we already worked out in the beginning. 0, -3/2. So this is also to highlight that if it's a 1 mark question, there really isn't too much thinking that has to go on there. So let us move on to the last question at question 3. It says, for 4 marks, the equation, we should determine the equation of the circle in this form. So they're talking about this circle here that we have just also spoken about. They're asking us to get the equation of this circle. So let me just cut everything and put it down here. So they're asking us for the equation of this circle. So obviously getting the equation of this circle, it's really not going to be a chore. It's straightforward, easy marks. And this is also to highlight that with analytical geometry, always get full marks for that section. Like if you can get 90s and, you know, upper 90s for the analytical geometry section, then that's fine. It should be like your duty. Okay, your duty. Oh, that's weird. You should just make it like a priority. So here, the center is going to give us is what A and B is. We just need the radius, which is just the distance between is just the distance between the center and any of our coordinates. So we'll just use C as well. So the center here is 0, coordinate -3/2. So we have A and B. But then for the radius, we need the distance from, let's just label this M. We need the distance MC here. So MC is going to be square root of 0 minus 2 squared -3/2. You're going to subtract the 3, right? So that would be a plus, and then we square it. And then, I mean, might as well just put everything here in the calculator. So square root of 0 minus 2 squared, and then -3/2 plus 3 squared. Everything here is 5/2. Wait, yeah, that's the final answer. 5/2. So the 5/2 here, this is the radius. You see, R is 5/2. So we have to be careful now. For our equation, we can say therefore x, and then the y value of the center is just a 0. So you can even put -0 there, because why not, you know? And then here, the -3/2, we have to write the opposite here. So -3/2 over there. If you put a plus here, minus, I mean, like, it really doesn't matter, because I mean, like, we're dealing with a 0. And then here, R is 5/2, so this is like 5/2, but then you have to be careful. to square that, because we got r. R is this, but then your equation of your circle is in this format. We have A, we have B, we have R, we drop them in there, and then we have our answer. Okay, so question 4, looking at question 4, right? It says here, in the diagram, the circle is centered at M. So where is M? There's M over here. And then what? And then it says K, radius KM, okay, is produced to L. Okay, so there's KM, it goes all the way to L over there. It then says here, the following. What else does it say here? It then says here, produced to L a point outside the circle, such that KML is parallel to the y-axis. So this is parallel to the y-axis. Okay, so that's quite interesting. And the funny thing is, just by looking at these parallel lines here and seeing this triangle there, I mean, I wouldn't put it past them to like do some strange similarity proportionality stuff here, but they probably won't. It says here, LTP, which is this long line here, is a tangent to the circle. So that's quite special. So let us acknowledge it. This line here is a tangent. So we should think of, I mean, we don't have the tan chord theorem anyway, but as long as that's a tangent and this is a radius, it means that this is a 90-degree angle. So we should not forget that. It then says here, T is this coordinate, S is that coordinate over there, and then these two lines are that line there is being cut in half. Okay, that's quite interesting. It seems like everything is what you call is in its place. So for 4 marks, they want us to, they say here, given that the radius of the circle is 5 units, show that B is equal to 4. Okay, for 4 marks, this does not look like a bad question. Now, to be honest, right, if there's any topic in paper 2 that you should always try and maximize on, it's analytical geometry. Like legit, one of the best topics to get marks in is analytical geometry. So here, they said if the radius is a 5, so this length here is a 5. We should show that the coordinate of B is 4. So with these kinds of questions, you have to be strategic, you know, of which, I mean, here we don't need to strategize very much. We just have a distance here, which is 5. So you might also use the distance formula to get B, you see. So in our distance formula, we already know that the distance Tm is going to be equal to square root of, it doesn't matter as long as they match. So here you can say -2 minus 2, -2 minus 2, and then you square it, plus B minus 1, and then you square it. And then from here, we have Tm. Tm is a 5, so I might as well put a 5 over here. Or rather, let's just carry on. So this is going to be a 5. Let's see here, -2 minus 2. -2 minus 2, that just gives you a -4. And then this, you may not want to FOIL this just yet. Let's maybe wait until things are a bit neater, you see. Or rather, since we're trying to isolate B, don't try to do too many things unnecessarily that will like just make you do a lot of work. So what I mean is, here we can leave this like this, right? So that we can just like square this side and also square this side, so that the square roots cancel. The square root here cancels, and then this is like 25 equal to 16 plus B minus 1 squared. Now here you may want to take the 16 over. 25 minus 16, that's going to give you a 9. And then from here, we're going to show something very important to help you whenever you work with square roots. Because normally when people see a bracket squared, right, the first thing that is normally done is just expanding and then foiling and then using the quadratic formula. However, you can also do the following. For a question like this one, right, here you can actually just square root the right, square root the left. You just have to give your answer as plus or minus 3 equal to b minus 1. Because this plus or minus 3 here is what's going to allow you to eventually get 2 answers for b, just like how the quadratic equation would have done. You see, so from here, you just have to say 3 is equal to b minus 1, or minus 3 is equal to b minus 1. So that here the 1 is going to go over. Actually need to be careful here. 4 is supposed to be a, b is supposed to be a 4, yeah. So here if the 1 goes over, b is a 4. For this one, if the 1 goes over, b is negative 3 plus 1, that's like a negative 2. So this one you can just disregard it. It does not qualify for your answer. So what you'd have done up here would be your final answer, and then you'll get your 4 marks over there. But then if you wanted to have, let's say, like made 2 brackets and then FOIL and then all that, it's still 100% fine. You are still eventually going to get your B as 4 over there. So I think from here, I will just try and carry on so that we can maybe get on to like something that's a bit more difficult. For 2 marks here, they said we should get the coordinates of K. So, I mean, since now we've just gotten B, right, your best bet is to put that coordinate clearly so that you can see it. Yeah. Oh, okay, that fit in nicely. So this is 4, and then now what are they asking? They said we should get the coordinates of K for only 2 marks. So me saying only 2 marks, I mean, yeah, you just want to be a bit open-minded here, because if you look at where K is, right, the reason why it's a 2-mark question is because the X value of M is going to be exactly the same as the X value of K, because it's along the same line. You see, this is a straight line going downwards. We know it's a straight line going downwards because it's parallel to the y-axis. You see, so this is a 90-degree angle there, right? Meaning this line is going straight downwards. As long as this line is going straight downwards, we know that the x value here is a 2, the x value here is also a 2. Now for the y value, you can see the distance from here downwards is just 5 units. So you can see from positive 1, 5 units downwards, you're going to end up at like negative 4, you see. So that's just going to be your answer over there. So that's for K, right? We worked out K to be 2, coordinate negative 4. That's for 2 marks. The next one, for 4 marks, they said we should get the equation of tangent LTP in the form y is equal to mx plus c. Let's see where LTP is. LTP. So anytime you need to get the equation of a straight line, I mean, these days I like using this formula. Y minus y1 is equal to m x minus x1. Because with this formula, I'm like, all you need is just a coordinate that the line passes through, and you just need the gradient. And then you just make y the subject of the formula. So from our sketch, I mean, anytime you want to get an equation of a straight line, never overthink it. What I mean is, according to our sketch here, your tangent, you can already see, using the gradient formula, you're not going to get anything, because a gradient formula needs you to have 2 coordinates that this specific line passes through. However, this is where this comes in, right? You remembering that a tangent is perpendicular to a radius. You can just use the gradient of the radius to get the gradient of the tangent. Reason being, the gradient of the tangent, if you multiply it with the gradient of the radius, you should get negative 1. Because that, yeah.
I have a question on number 4.2. How did you get the negative 4 on the coordinate?
Okay. So with the negative 4, what we did was, the radius is 5, right? So what we know is this, let me just get a bright color. The y value of m here is a 1, you see. So what we know is the distance from here until the y-axis is just 1 upwards. I mean, from the x-axis going up is just 1 unit, you see. So what we know is, if this distance is like 1 unit, right, and the whole distance going down is 5. Remember, the whole distance going down is 5 because the radius of the circle is 5. If this is 5, it means that this is also equal to 5. So what we know is if m has a y value of positive 1, if this dot is at positive 1, it means that if you go down 5 times, you're going to end up at negative 4, because you're going to go down once, you're at 0, and then you're going to go down for the second time, for the third time, for the fourth time, and then for the fifth time. You see, you have gone down 1, 2, 3, 4, 5 units, of which from 1, if you decrease it by 5, 1 minus 5, you're just going to get a negative 4. You see, that's where we got the negative 4 there. Does that make
Okay.
sense?
Yes, sir.
Away. Perfect. So if you have any questions, right? I mean, immediately if you have the question, like feel free to ask the question, so that you never get to a point where we maybe like get too far from the question and now you maybe feel like it's too late. You see, so you don't want to feel that way. If you have a question, like you can ask immediately. It's 100% okay. So what we were saying here is LT is perpendicular to MT. So that's how we're going to get the gradient of LP. You see, whenever you need a gradient of a line, which we do here, try not to always focus on the gradient equation only. You see, especially in grade 12. As long as you need a gradient, you have so many things to consider. Consider things like how parallel lines gradients are equal, and perpendicular lines gradients, if you multiply them, add up to -1, and a bunch of maybe other things that you may be able to use, maybe if it's like functions or whatever. So here, based on what we have here, right, if we're going to get the gradient here, the gradient of LP, we don't know what it is, so we can just leave it. However, the gradient of like TM, this we can work out, you see, because the gradient of TM, you can just say y2 minus y1 over x2 minus x1. You see, this is going to be equal to -1. And then this, you can just put it in your calculator. You see, MP or M, the gradient of LP here, multiplied by this number. This number in the calculator, what is it going to be now? Yo, this is like negative. This is like 3 at the top here over -4. So it's like -3 over 4 like that. This is equal to -1. Let me just remove this bottom part here because we don't need it. So this number here in your calculator at the top, it's going to be a 3. This is going to be -4. So this is your fraction. So automatically, you know that if you're going to get the gradient of LP, you have to divide by -3 over 4 on both sides. You see, so you dividing by -3 over 4 on both sides, it's something that you can just put in your calculator. -3 over 4, this cancels out, and then here -3 over 4. 1 divided by -3 over 4, or -1 divided by this, is going to give you 4 over 3 as a positive, you see. So now we have the gradient of LP, you see, of which that's what we needed. We needed the gradient of LP, and then us getting the gradient of LP, all we did was we used information from the radius, which is something very, very common and very, very normal with these analytical geometry questions. So now we have a gradient to put into our straight line formula. And at this point, we know we're already done because we have a gradient, we have a point that the line passes through. And that point is just -2 coordinate 4 over there. And as you saw, the 4 is something that, or the -4, rather, I put a positive. Negative. Yep, that's been there forever. But it's a -4 because down here, what did we get? Yeah, we got a -4. So it's -2 coordinate -4 that we are going to use to get as a point that we're going to put into our formula. So here we're going to use -2 and -4. That doesn't seem very correct. It doesn't make any sense. The positive 4.
T is positive, yeah.
Yeah, oh no, I was looking at this. I thought, like, you know, the weirdest thing, my brain is like going mad. It was like, dude, no, that's not a negative. But then I kept writing it, and then I kept writing it, and then I kept writing it. But then, thank you for helping. Because this is what was messing with my head. You know, I was looking at the K there. Because the K and these look, they're almost the same. But then anyways, yeah, so it's -2 and 4 that we are going to put into our formula. So here it's going to be y minus a y value, which is 4. Gradient, we worked it out to be 4/3, 4/3. And then the other x value is like -2. So we have to be careful here to put a +2. And then from here, we're home free. You see, y goes, this one goes off. So this is like this times this, right? 4/3x. This times this gives you 8/3. And then the 4, when it goes to the other side, it becomes a +4, the -4 there. And then from here, we know that we can just put this in the calculator. 8/3 plus 4. What is that now? I have to think now. I think it's 20/3, I think. Yeah, I hope so. 20/3. If someone has a calculator close by, you can just double check. I don't even know why I don't have a calculator. Where's the calculator? I think it's 20/3. Yeah, it is 20/3. Hopefully. Yeah, but it is. So from here, we're going to get 4 marks. And we will be able to move on to this 7-mark question. Yo, okay. I literally reacted the same way I always say, don't react like that, blah, blah, blah. But I think sometimes you just can't help it. I mean, like 7 marks, yo, that's a lot. So any 7-mark question, I mean, one of two things. When you will look at the question and maybe something is just like, it's not on, then it's best to move on and come back to it. But let's see, LPK, where is LPK? We need the area of L. Where is P? LPK. Okay. So it's our main triangle over there. We need the area of that main triangle. So for questions like these, I mean, this is a triangle, right? It's a triangle. And we know that with triangles, we usually always have dimensions that we can like work out and all that, because for getting an area we would want to think of one of two formulas, either half base times height or half a times b sine c, which is like the sine rule. One of two formulas. So what you do for yourself is you ask yourself nicely and you think, so for a question like this one, I mean, like the way everything is looking now, the half base times height formula, that one doesn't look like it is going to do us much because of the way the sketch is looking. So you may be thinking, what about the second one, the AB sine C? The whole AB sine C formula needs us to have two sides and an angle in between the two sides. So you can think to yourself, I mean, like here, can we even get two sides of this triangle? P and K we could if we got P, but then something like L and P, I mean, getting the coordinate of L is a bit rogue, like it's literally just in a strange place somewhere up there. So that one may not be very useful. So I think with this question for 7 marks, yeah, we need to be very, very creative. Otherwise, yeah, otherwise it's just not going to happen, because 7 marks is a lot, of which I think as I'm talking now, it goes back to what I said in the beginning. LPK, I mean, the way LPK is set up, yeah, it's not playing any games, like it's no joke. So let me just maybe take a screenshot of this and then let me crop this out, because normally if this is not like a Zoom session, you can imagine it's easy to, like, you know, just spend, I don't know, however long you need to spend trying to figure it out, or just look at the memo. But then normally if I'm like recording something, right, I usually try to just record the train of thought while trying to figure out the question, so that also it is clear that with questions, it's not a matter of just looking at them and already seeing the answer or already seeing what to do and all that. So in terms of like a train of thought, right, for this kind of a question, I'll just tell you what is in my head. So looking at the way this question is set up, I don't know, I think if I can just use this image for now. Looking at the way this sketch is set up, right, if you are going to use the half base times height approach, I mean, the way this shape is looking, you have this, and like that, right? So if you're going to work out the area using half base times height, you may want to consider, if you consider this as the base, it means that this would be your perpendicular height. You see, it looks weird, but then that's just how you want to look at these kinds of questions, or that's how you always want to look at a triangle. If you're going to consider LK as your base, it means that this distance here, literally from P here going straight down, this would be your perpendicular height. So the only issue now is thinking of the length of LK. Getting the length of LK, that's, I think, going to be a bit of a mess, because in all that we have done here, it doesn't look like us getting the coordinate of L is something that we would be able to do easily.
Sir?
Because, yeah. What's
Sir,
up?
can I have a suggestion, sir?
Yes, please.
Sir, since we calculated the equation of the tangent, I think the best thing would be to substitute your 2, because you know that L is going to be your 2 and your Y.
Oh.
And then from there, sir, we can get the distance from L to our K. And then, so we can also find P and Q, because S is going to be the midpoint. So we can say 4.5 plus 4.5, and to get the PQ length. Perfect.
Well, you mean the when you say PQ, what do you mean by PQ? Unless you're saying a different letter. Because where's Q here?
I'm sorry, PK. Sorry, PK.
PK.
Sir.
Oh, yes. PK. Okay. You know what? You totally cracked it wide open. Because from what you said, right, it looks as though because we have the yellow line, we can easily use that to eventually get L. Because for L, we know that the X value is a 2. Wait, before I carry on, who was talking? Like, I didn't notice. I just heard a voice. I don't know.
It's Buntle.
Okay.
Buntle.
Thank you, Afro Buntle. You saved the life, you know, like you saved the life. Anyways, so wait, are you in the group?
No, I'm not, sir.
Okay. Or you can just call me Levi, like, please. The whole thing really throws me off. So if anyone is not in the group and you need to be in the group, just like send me a message on this number, and then
Okay.
I shall add you to the group. Cause I mean, yeah, why not? Let me just try it. Yeah. So back to our question, right? The big idea with our question is we need the length of the base, which we now, I think we can definitely get. However, what we will also need is the distance between P going straight to this point here, because your perpendicular height has to be a line that is perpendicular to your base, you see. So instead of us eventually getting the length of PK, what we will need to get is the distance from here until there. Of which getting the distance from here until there, it's not going to be a hassle, because what we know is the X value here is a 2. All we will need is the X value of the P over there. Because if you compare the X value of the P here and this X value of 2, you will have the whole distance over there. So getting this distance is not going to be an issue, because getting P is also not going to be an issue. So let's get P first. Before we do anything, it looks like we need to get P first, and it looks like we need to get L first. This is where all these 7 marks are coming from. So getting L, the idea is we have the equation of the tangent. And what we know about L is that its X value is a 2. You know, as Bontle said, we need to use the 2 here in the equation of the tangent. Because if you can throw in an X value of 2 here, it's going to give you the Y value of our Y value over there. So with all that being said, let's go back to our straight line, the equation of our straight line. I know I'm getting distracted here. Our equation of our tangent, we worked it out to be this line over here. So from there, let's just do this. Copy. Let me paste this here. So I think this is definitely worth 7 because there's a lot of writing here. So y is going to be equal to 4 over 3 times the 2 here and the 20 over 3. This is going to give us 8 over 3 plus 20 over 3. 28 over 3 is our y value. So it means the y value here, 28 over 3. Yo, why am I not writing nicely? 28 over 3 is our y value for L. Perfect. So for K, remember K is down here, right? K is just 2 coordinate -4. 2 coordinate -4. So the distance of our base, it is literally just going to be the 28 here plus a 4. Because you see here, from here going all the way to the x-axis, the distance there is 28 over 3. And then from this x-axis going down, we know that the distance there is just a 4. So the distance from here going straight downwards is just these two added up. But then this one, you'll have to remember distance can never be a negative. So this is like 4 units plus 28 over 3 units. So that's our base. Let's just write that out. So for our base, let's put here base. It's going to be equal to 4 units plus 28 over 3. You see, of which 4 units plus 28 over 3, your answer there is going to be 40 over 3. So we have the length of the base now. Perfect. Now we need our perpendicular height. So to get the perpendicular height, which is going to be the distance of this red dotted line here. You see here, this red dotted line here. We need this as the perpendicular height. So remember, your perpendicular height just has to be a line from the point of a triangle. It has to be going perpendicular to wherever the base is. So you see the base here is going down like that. So the perpendicular height has to be going down like that. So this distance here, we said what we need to do is we need to get the coordinate of P, or rather, yeah, we have to get the coordinate of P, but our main focus will be the X value of P. So to do that, it looks like we can just use the midpoint formula in this line here, because in this line here, we have one side of the line, which is K, we have the middle of the line, which is S, and we have the other end of the line, which is P. So anytime you have a scenario like this, right, you can always use the midpoint. You can always use the equation of the midpoint to work out the other side. But to do that, this is all we have to keep in mind. We just have to keep in mind that here we technically just have x1 and y1. Here we technically have x2 and y2. Here you have the x value of the midpoint, and then here you have the y value of the midpoint. So in your midpoint equation, all you will have to do, let me actually maybe just paste that image again. Oh, no. Nope. I'm trying to not like scroll up and down the whole time, but I feel like I have no choice. So let me just write down the equation of the midpoint here. So the equation of the midpoint, you're always going to say x1 plus x2, right, over 2, y1 plus y2 over 2. But the big idea here is you can always look at these split up, meaning your x value of your midpoint, right, will be equal to 1 plus x over 2, like that. So your x value of your midpoint, we already know it is -4.5. So here we can make this equal to -4.5. For the y, it's the same thing. Your y value of your midpoint, which is like -6, you already know that -6 is equal to y1 plus y2. You see, that's how we're going to work out the value of P, because all we need to do in our formula is that where we see x1, we're going to leave it the way it is. But then where we see x2, we have to put the coordinate that we have, which is here. You see, we have an x2 and we have a y2 to use. So we can just use those in our formula. So here for x2, we say that's a +2 over there. And then this side for y2, we know that that was a -4, like that. So you can already see here, one side of the formula is going to get us the x value of P. The other side of the formula is going to get us the y value of p, you see. So you just have to be careful to put this properly in your calculator. Putting -4.5 in your calculator, you have to press the shift button first. And then after pressing the shift button, you press the fraction button. It's going to come out as a mixed fraction, you see. So just be careful. Or rather, you might as well just use it as an improper fraction, meaning you're going to say, how do you say it again? Yeah, I even forgot. I think it's like negative. I think it's the front multiplied by the bottom and then you add the top. Yeah. Yeah, I think so, right? Negative. Yeah, 4 times 2 is going to give you an 8. Plus 1 is like what? 9. Yeah, 9 over 2. 9 over 2 with a negative. I just changed it into an improper fraction. It looks correct, I think, I hope. Anyway, so moving on from here, you can see that both of them have bases, have like numerators of, denominators is a 2. So you can either just cross multiply or just multiply by 2 on this side, multiply by 2 on this side, and then the 2's go away at the bottom there. The 2 goes to the left, you have -11 over there, which is actually all we want to focus on. So us mentioning this is just extra information which you can use in the future if, let's say, for some odd reason we needed the full coordinate of p. But let's just show how it would work if you needed the full coordinate. On both sides, you can multiply by 2 here, and then your y value here is going to be -12 plus 4, which is going to give you -8. So your p is just -11, coordinate -8. But then we said our main focus is just the x value of p, because as long as we know the x value of p, we're good to go. We're definitely good to go. And look at me, I literally forgot what I wrote down there. -8. So as long as we have the x value of p, we're in a good spot. Like we are in a very, very good spot, because all we now know is the x value. If you're going to go straight down like this, right, until you meet this line at an angle of 90 degrees, what you know is the distance from here to there. All you need is the x value over here. The x value over here is a 2. The x value over here is -11. So you already know that your perpendicular height is just 2 units plus 11 units, which is just going to be 13, you see, because this is just going to be 11 units to the left and then 2 units to the right. So the whole distance is just an 11 there. So for our base there, we can just write, our height here, we know it's going to be 11 plus 2, which is a 13. And then now we can use our half base times height formula, which is what we know is just going to plainly give us the area. So here area is just going to give us a half multiplied by the base multiplied by the perpendicular height. And then our final answer, I don't know why I don't have my calculator, because it would have made life so much easier. But then I'm out here doing things in my head and I'm like, very bad idea. Like absolutely bad idea. Because this is going to give you the answer 520 over 6, of which that answer is like 86 something. Yeah. Yeah, 86 and
Sir, it's 86,65.
oh yeah, if it's rounded off. Yeah. So yeah, I think it's fine. 86.65. Whoo-wee. Yeah, for 7 marks. Yeah. Well, obviously, in an exam, you won't be doing any talking or anything. So yeah, it's a matter of if you see it, you see it. If you don't see it, move on. But then remember from what we were saying in the beginning, the one thing we immediately moved on to was the only 2 options we had. Secondly, we then moved on to saying that we need to just get a base and a perpendicular height, of which we did that. And then the one thing that helped us was also just realizing that with L and P, in as much as they were like just rogue angles, rogue coordinates, they were just random. There's a coordinate here, there's a coordinate there. There's something we could do to get them. So I think that should be that. I think maybe let's do this last question and then call it a day. Did I hear a question? Or did I hear
Yes, sir.
someone? Away, what's up?
You see, by like we kind of constructed our own perpendicular height. Do we have to indicate that like we created our own height, like construct perpendicular height, whatever, because we also gave the coordinates there.
Okay, so in terms of what we did, right, we actually did not necessarily construct anything. All we did was we made use of the properties of our triangle, because the only issue with our triangle here is the way it's aligned, you see. Because if you had an image, right, that looked like this, you know, like this, it's easy for us to see that, okay, wait, this is the base. And it's easy for us to say, okay, wait, this is the perpendicular height, you see. It's not a construction, it's just an observation for us to say, okay, from what we're seeing, we are seeing that this is the base, and then this is the perpendicular height. Because remember, the perpendicular height is always a line from the tip of your triangle going perpendicular to where your base is. So if this is your base, you would just need to observe that this base here would need to always, if it was, let's say, a random, whatever, the idea here is, as long as this is your base, right, your eyes should see that this would need to be perpendicular to that. It's not a construction. So for our sketch here, right, if you look at the way our triangle is, it's not aligned nicely, you know. So looking at it like this, the moment we decided to look at this as the base, all we had to do next was, just because of the way we were looking at it, right, as long as we decided to make this the base, going straight downwards, right, our perpendicular height would need to meet this line here at an angle of 90 degrees. It's just our eyes that helped us to see that. It's not necessarily a construction. It's just something that's already there because of the properties of our triangles. If this is the base, it means that this line here has to be the perpendicular height. So in terms of you communicating with your examiner, all you will need to do is literally just be getting this information, getting L, and then you saying LK is, because if you saw all we wrote here, we wrote base is equal to 4 plus this. This is good enough to supplement that we have made this the base. And then from there, all these other calculations that we did, if we ended up needing to get P, right, or the X value of P rather, that's going to be worth something. And then from there, we ended up saying that the height is 11 plus 2. This is also going to be worth something. And then from there, we chose a formula that's going to be worth something. We threw in values correctly, that's going to be worth something. And then we have a final answer that's definitely going to be worth something. You see, if you check, it's like 1, 2, 3, 4, 5, 6, 7. So that's where your marks come from. Your marks come from like the chain of events that follow one after the other. And fortunately, this is not Euclidean geometry like this section. So the whole idea of putting statements and reason, you know, it's not necessarily something to do there. Cool. Okay, so the last question of the day. So with this last question, what does it say for 4 marks now? It says another circle with equation this is drawn. Determine with an explanation. Determine with an explanation. Determine with an explanation the values of n for which the two circles will touch each other externally. Okay, so we need to what do we need to do? Oh, we need a clear image. Let me just try and get a clear image of what we have been working on here, because I think the one we are using now, yeah, it is definitely dirty. Okay, now what am I doing? I just do this, files, image, gallery, and we want this one. So with the image that we have here, right? If you're looking at the question, this question that they're talking about, or this question that we have now, it's literally all over the place. So we kind of have to like, draw stuff so that we can like see it better and all that. They said another circle with this equation. So this equation here, the two things to focus on is maybe things like the center, and then things like the radius, you see. So the radius is going to be square root of 25 over there, of which the radius of our new circle there is going to be 5. So this new circle, they said we should determine with an explanation the values of n for which the two circles will touch externally. So the two circles touching externally, what it means is, if you have a circle here, right? If a circle touches this circle externally, it means that it will only touch it once, you see. Because if you had, let's say, a scenario where your two circles touch each other twice, they'll need to say that explicitly. And then if they said the two circles touch each other internally, it means that the other circle is like inside, you see. So this is the scenario where our circles are touching each other externally, and then this would be a scenario where they're touching each other internally. So we want to visualize an image that looks like this, of which I don't think that should be too difficult, because firstly, what we also need to do here is we need to ask ourselves, where is this circle in the first place? So we know its radius, which is going to be square root of 25, which is just a 5. But then what's important is things like the center. So since we may not know what the y value of the center is, but then we clearly do know what the x value of the center is, of which, remember, the x value is always the opposite of this. So just by looking at this, we know that the x value is a positive 2. So automatically, just using our eyes, we already know that the center of our circle is somewhere along this dotted red line here. Now, as long as we know that our circle is somewhere along this dotted red line, and we know that they touch each other externally, I mean, automatically speaking, we know that there's only one of two images, or one of two images, or two images in total that can be our circle. So we have the original circle here, right? Let's say original, our circle here with center M, right? So if you're going to have a circle that has its center as the same as, like, if the x values of the centers here are aligning, it means that your circle could touch up here, or your circle could touch somewhere down there. Because according to our image and according to the information that we have gathered, the center of M is here, right? And the center, the x value of M there is a 2. We have also seen that whatever this line is, we don't know where the x value of the center is. We don't know where the y value of the center is, sorry. But we know where the x value of the center is. I'll repeat. We know where the x value of the center is. The x value of the center is somewhere where x is a positive 2. So that x value of the center could be somewhere down here, or it could be somewhere up there, you see, because our circles need to touch externally. So if our original circle touches the one at the top, it means that our value of n is a specific number. If our circle touches this circle at the bottom, it means that our value of n is a specific number, because we can see here n is just going to be representing the y value of the center. So for 4 marks, it doesn't look like this question is going to be too difficult. We just need to think without getting too flooded by like the numbers and the analogies and everything. Because if we are just going to be clear here without like beating around the bush, the first thing is, firstly, where M is, right? M is this point here. M, the x values are 2, the y values are 1. What we also need is the radius here is a 5. The radius of the new circle is also going to be a 5. So just having a clear head will show you that if this distance here is a 5, going downwards some more is also going to be a 5. You see, so if you have negative 2 over here, right, I mean positive 2. Positive 2 over here. Going straight down to the other center of your circle, this is like 10 units. You see, so 2 minus 10 gives you a y value of negative 8. You see, and then you want to do the same for the y value that would be up there, because going upwards, you're going to go up 5 units, and then you're also going to go up 5 units again to get to the new center here, of which 2 plus 10 units going upwards, that's going to give you a y value of, oh no, I have to start at, I think I missed, no, what did I just do? It's not negative 8, it's a 1, because the y value here is a 1. So since the y value here is a 1, going 10 downwards, 1 minus 10 gives you a negative 9. Yeah, because I think I swapped the x and the y. So if this is our center of our original circle, right, the one thing to focus on is the y value of the center. So if the y value of the center here is a positive 1, we know that going 10 units downwards gives you the y value of the new center. You see, so from positive 1 minus 10, you're going to end up at negative 9. We do the same going upwards. Positive 1, if you add 10, you're going to end up at positive 11 over there. So according to the question and according to the sketches that we have just drawn here, we know that the y value of the center of the new circle, we can say here n is equal to 11, or n is equal to negative 9. So with that being said, we need to give an explanation, as they said here. They say determine with an explanation the values of n for which the two circles will touch each other externally. So whatever analogies we used here, right, we just have to find a way to put it in like normal English words. So this is going to give us 1 mark, this is going to give us another mark, and then our explanation should probably give us the other 2 marks. So in terms of an explanation, don't think of anything fancy. Make it as blunt and as simple as it can be. So mention all the things that are very direct and very obvious. So the first thing you're going to say here is that circle M will have the same what? They have the same x value of the center. Will have the same, what am I trying to say? Let me try and think of the words. Circle M will have, no, let's just say, let's put it this way. If you're writing what I'm writing, I think maybe only write once we have written the whole thing, because we're probably going to be changing quite a few things. So let's say here circle M and the other 2 circles, circle M and the other 2 circles will have the same x coordinate as the center. You see, so let's just put a full stop here. So circle M and the other 2 circles will have the same x coordinate as the center. So the x coordinate here is a 2, and the one up there will also be a 2. That's the first statement. Secondly, what we're going to mention now is the distances between the 2 centers, you see. So here we're going to now say the distance between circle M and the circle at the top will be 10 units, because both circles have a radius of 5. And then lastly, you can say the same applies for the bottom circle. You see, and you can see, I mean, like from here, I mean, you've basically mentioned what you can mention. Your 9, your 11 here and your -9 is going to supplement everything, because if you read it nicely, based on what we wrote here, we say circle M and the other two circles will have the same x coordinate as the center. That's how we're able to align them like this. They will have the same coordinate as the center because they need to touch externally. So with that being said, we also know here they told us that we said here the distance between circle M and the circle at the top will be 10 units because both circles have a radius of 5. The same applies for the bottom circle, and then you're done. This should be good enough to get the 4 marks. And we said here the idea is to just make it blunt, make it simple, use simple words, try not to have sentences that are too long. Once you've said something and you feel like it's enough, try and put a full stop. Say something again, and then if needs be, put another full stop, and then say whatever you feel like you need to say, and then put another full stop. Because sometimes if you just try to say everything all in this one long sentence, that's when you like bump into small problems and it becomes an issue. Without using a calculator, I was literally about to look for my calculator, but it clearly says here, without using a calculator, write the following expressions in terms of sine 11. So anytime you need to write down expressions in terms of something, I mean, there's no need to overthink it, especially likely this is just like a 1-mark question. So in this 1-mark question, we already know that, I mean, writing this in terms of 11, I feel like this one is like a super, super duper easy question. There is like nothing much to it here. So in terms of writing this as 11, we know that it is just, wait, without using calculator, write the following expressions in terms of sine 11. Whew, okay, I mean, sine 190 or 191 is equal to sine 180 plus 11. So the funny thing now is you may be thinking to yourself, how do you end up writing this as sine 11? The fortunate thing is your cast diagram is there to help you. So according to your cast diagram, right, CAST, you already know that this is the quadrant 180 degrees plus an angle. So 180 degrees plus an angle, you end up in this quadrant where only 10 is a positive. So sine 180 plus 11 is going to come out as negative sine 11. And there you go. You have your question and now you have your answer. So nothing crazy, it's just a 1-mark question. So let's actually not even speak too much about it. Question number 5.1.2 says here cos 11. We should write cos 11 in terms of sine 11. So we said don't overthink anything. Just try and like, you know, break down whatever you can break down. And then once you're done, you know, just see what comes out. So the fortunate thing is, I mean, 22 is just double 11. You see, that's what we can look at first. This is just double 11. So we might as well write it like that. 2 times 11 here. Ooh, Mr. Benedict. Let me add you so. So this is just double 11, right? Meaning that where we see cos 22, we can just write it as cos 2 times 11. So that's not like going to be an issue. So let us just carry on from here. So I'll just wait for whoever we were adding to, you know, hop on board. And then as soon as they're, I think they're here. I think everyone is added. So let me just carry on. So carrying on from here, we already know that cos is just, you know, the double angle of cos has 3 variations. So we would specifically want the one that at least has a sign, because our questions here are asking us to work out sine 11. No, they're asking us to work out these values in terms of sine 11. So if you think of your double angles, right, let me just show which one we're going to use here. We want one that has cos, I mean that is sine. So we already know that cos to any angle is equal to 1 minus 2 sine squared that angle. So that's the analogy we're going to use here. Here, this is going to be equal to 1 minus 2 sine squared, and the angle here is the angle that goes there, you see. And then this is good enough as your answer. You will get 1 mark for that because you have written the cos 22 in terms of 11, which is what the question is saying. Without using a calculator, write the following expressions in terms of sine 11. So cos 22, we broke it up using our double angles, and then we wrote out what we can write out. So those are the easy ones, I guess. Let's see. Our first low-key real question. It says here, what does it say? It says, simplify this to a single trigonometric ratio. So anytime you need to simplify something to a single trigonometric ratio, I mean, it's just a matter of breaking it up, right? Using what you know. And when we say using what we know, I'm referring to things like the reduction formulae. I'm referring to things like double angles and compound angles. And then I'm referring to things like the square identity. So the square identity is basically from grade 11, where we know that sine squared an angle plus cos squared the same angle is equal to 1. So that's the square identity. So these are the three main things that you're going to use whenever you break down something into a single trigonometric expression. So you're going to see whatever we're going to do here, we're going to use one of these. If we add another one, that's still just fine. So the first thing here is we're seeing that we have cos x minus the 180. So if you can recall from Tuesday's session, we basically mentioned that when you see something like this, right, you can write it swapped around. And then when you've written it swapped around, you can just use your Cartesian plane, your cast diagram. So in your cast diagram, right, anything that's a negative, you're always going to be going clockwise. So this is telling us negative 180, right? So negative 180, you would go negative 180. And then after going negative 180, this is telling you to plus x. So the moment you plus x, you end up here. You see, so anytime you plus, you go anti-clockwise. Anytime you minus, you go clockwise. So here, 180 plus x lands you in this quadrant where 10 is a positive. So you already know that whatever this is, right? Because you're dealing with 180, cos is going to remain a cos. But then in this quadrant, cos is a negative. So you're going to put a negative there. And then, so I guess we have this sorted, right? This, I think we're going to expand it using our compound angles. So what I'm doing here is I'm basically almost like preparing our question before we just throw in stuff. So we already know that what we're going to write is this. We're going to write it as this. Whatever this is, we're going to write it as this. And this is something you want to be comfortable doing on your answer sheet. On your answer sheet, you're 100% welcome to like somewhat prepare your answer and then throw it into where it's supposed to go. Like so far, cos this is equal to just this part. The sine x plus 45, we are going to write it according to compound angles. So if you think of compound angles, right, we already know that the sine with a plus, it is also going to somewhat be a plus also. Let me just show what I mean here. So the sine x plus 45, right? What we already know is that just because we're adding two angles together, it automatically reminds us of compound angles, you see. So here we have an x and a 45. Our formula sheet, which is always something we can use, is already telling us that here we're going to have the x, here we're going to have the 45. Here we're going to have the x, here we're going to have the 45. And we can just use our formula sheet to like help us. So our formula sheet shows us that it's basically going to be sine cos and then cos sine. So let's do it. So let's see here, sine x cos 45 and then cos and then sine. You see, so if you check, I'm not even going to be, I didn't even bother myself like trying to like memorize anything because there's really no point and no reason to. So what we already know is whatever this is, we're going to write it as that. Whatever this is, we're going to write it as that. So I think now we can just throw everything into our question and then just carry on. So to start off here, we're going to write it as negative. Use a different color, use a purple because there's too much yellow. Let's see. So negative cos x, and then we have a plus over there, and then we have a square root of 2. So what we're about to do here is very important. This sine x plus 45, this is one thing technically. So you want to make sure that you preserve it as best as you can before you mess up. So meaning here you might want to have a bracket, and then this we said we're going to replace it with that. So this is just going to be sine x cos 45. I think here we could have even gone a step further and have simplified it some more, because it's always easy to like throw stuff into your working answer once it's like, you know, simple enough. So here we know that the cos 45 and the sine 45, we can change them using our special triangle. So the exact same way that I'm going through this question, right, it needs to sink in your head that your answer sheet needs to be something you can use as comfortable as you can. You know, you don't want to feel as though in an exam you're very restricted to like something very specific. No, your answer sheet, it's there for you to be communicating with the examiner. And it's also there for you to use as a way to like ease yourself into the question. So with this 45-45 triangle, we already know that cos 45 is adjacent of hypotenuse, and then sine 45 is, what did I do here? Oh no, this is supposed to be an x. Goodness, I don't know if anybody saw that, but we are seeing it now, so we might as well change it. So this is going to be cos x, and then sine 45 is opposite of hypotenuse, which is just 1 square root of 2 over there. Perfect. Now with what we've written out, we can already see that 1 square root of 2 is a common factor. So we're going to have here sine x plus cos x. Okay, cool. So what we already can see here is whatever sine x plus 45 is, when it is simplified, it's just going to be this thing here. So meaning when we now throw it into our working answer, you see here, this, we changed it to that because of what we wrote here. And then the sine x plus 45, we're just going to change it into that, you see. So here, let me just remove this thing here, because you see the square root of 2 is out here. And then whatever this is whatever this is over there. So let's just throw that in there. 1 over square root of 2, open bracket, sine x plus cos x, and then close bracket, close bracket. So also don't get intimidated by things like this. You see, you want to get comfortable with, you know, having questions that have different layers. The more comfortable you get with those kind of questions, the more relaxed you're going to be in an exam when a question is like dragging and it feels like it's not ending. But then at the end of the day, like when you're done, you're like, oh wait, that's the answer. You'll be so much more comfortable with your answer and so much more confident if you know you didn't just rush into it. So here already we know that there's nothing much here. So here we can multiply in the brackets first. This value times this, you can just put that in your calculator. It's gonna come out as 1. So the scary thing is I might as well just write the 1 so that it doesn't look as though nothing happened. So me writing the 1 here is just so that, you know, no one gets confused as to what happened to the value in front. It's just a 1. This times this in your calculator is just going to be a 1. Of which, I mean, here it seems as though I'm adding too many steps, but I think for the sake of explaining, I might also just have as many steps as I can without leaving anything out. And also on your side, whatever question you're going to answer, it doesn't matter what the marker location is, right? Never be afraid to write, you know, as many steps as you feel you need to. Don't feel the urge to like skip stuff and all that. No, you know. So here already we can see that, well, I mean, we don't have to put the brackets here actually. We can actually just leave this bracket out and leave that bracket out. And then fortunately, the negative cos, or rather, let me, I know, I think that's just being extra. The brackets, they really don't need to be there. So the negative cos x here and the positive cos x, that goes away. And then our final answer is just sine x. They say it here, given sine p and sine q equal to 7 over 5 and p plus q equal to 90. They say it without using the calculator. determine the value of sine 2p. So this question alone, because of the fact that what we're dealing with has p and q, and what we need to have at the end has p only, we may want to make sure that in our expression we prioritize p. You see, so here was this expression, and we should get the value of sine 2p. So one thing we may want to do first is we want to write q in terms of p, so that at least we're working with p all around. So here we know that q is equal to 90 minus p, right? Meaning that what we have here, we can replace it with sine p here plus sine, where q is, we can put the 90 minus p, right? This is equal to 7 over 5. Now with all this being done, we already know that where we see 90 minus, that can just turn into a cos. So this is going to be sine p plus cos p with a positive equal to 7 over 5. There we go. So in terms of us going from where we are now to where we want to be, the one thing we can always keep in mind is that, I mean, like wherever we want to end up here, right? This is equal to 2 sine p cos p. You see, because of double angles. So just by looking at what we have here, right, the one thing that we should be thinking to ourselves is we need to find a way that we can have the sine p being multiplied with the cos p. Now, without doing anything crazy, right? I mean, like one thing we would want to think to ourselves is, if you're going to end up with a sine next to a p, with a sine p next to a cos p, if you're going to end up with these two things pasted next to each other, you would need to, at some point in time, have like multiplied out something. And the only way to eventually multiply out something from this expression is if we get creative, you see. And one of the ways of getting creative here is by squaring both sides. So if you look at where question 5.3 is, question 5.3 is literally like, you see, the last question of question 5. So usually the last question of any question is usually the one where you need to like get a bit creative and all that, of which past papers will show you that this is one way of getting creative. One way of getting creative is here, squaring both sides. Squaring both sides, we may want to do that so that we eventually have a sine p being multiplied by a cos p. If I carry on, if anyone has any questions based on what we're looking at, feel free to just switch on your mic and then just stop me, and then we'll just carry on after your question has been answered. So from here, let's square both sides. Let's see what it's going to look like. So squaring both sides, we'll have sine p here plus cos p squared, and then here 7 over 5 squared. Now automatically we know that this has allowed us to have two brackets that look the same. So if you're still in the phase where you think that sine p plus cos p with the whole bracket squared, if you think that this means sine squared and the cos squared, yeah, you see, that's a problem, because that's not valid. A bracket squared will always be the bracket multiplied by itself, instead of saying the first thing here squared and the second thing here squared. We all know that that only applies if whatever you're dealing with is like pasted next to each other. If these two are pasted next to each other, then they would both be squared like that. But because there's a plus in the middle, it means that the entire bracket is what's being multiplied by itself. I don't know why I felt the urge to say that, but I have just said it. Moving on, so on the right hand side here, this is just 7 squared. You see, your exponential laws will tell you 7 squared, which is 49, 5 squared, which is 25. And then, so from here, let's FOIL out our stuff. Sine p times sine p is like sine squared p. This times that is giving us that sine p cos p that we kind of want. And then again, cos times this is going to give us a sine p cos p again, and then cos times cos is going to give us a cos squared p equal to the 49 over 25. So from here, it looks like we're almost home free, as we should be. So this plus this is going to be a 1 according to our square identity, you see. So this is what's going to be left. This and this becomes a 1. This and this becomes 2 sine p cos p. So here we have 2 sine p cos p plus a 1 equal to 49 over 25. Because remember, we're trying to break up whatever we have here until we have the 2 sine p cos p, which is the main reason why we ended up squaring both sides anyways. So here we know that here, if the 1 goes over, we're going to have 49 over 25 minus 1. And then on the left side here, we're going to have sine 2p. And then in our calculator, let's see what we're going to get there. 49 over 25 minus 1. This is giving us 24 over 25. So this is going to give us 24 over 25. 24 over 25. And then that's the sine 2p. Okay. So I think we have this trigonometry question behind us. If there are any questions, feel free to ask. If there are no questions, then that is perfect. It says, determine the general solution of this. So whenever you work with general solution questions, right, and you clearly have compound angles here. Compound angles. So you have compound angles here. So you don't want to take compound angles for granted, because I mean, like, whenever you have compound angles, you're better off just making use of them. So that's what we're going to do here. What we see on the left here, we're going to expand it using our formula sheet, because our formula sheet, you can see it shows us that if you're dealing with cos and you're subtracting, it's always just cos with a plus, sine. And then, so let's just do that here. So it's going to be cos x with cos 30. And then since there's a minus here, we are told it's going to be a plus. And then sine, let's see here. And then this is equal to, like, what you may call the 2 sine x. So even though they're asking for the general solution, remember the general solution, it's almost just like saying solve for x, you see. Let's say here how do you spell equivalent? I don't know. Equivalent to solve for x. Whether or not this is the spelling for equivalent, I don't know. But anyways, here this is equal to 2 sine x, right? And we can simplify this using our special triangle, because our triangle has, this is how I always remember this special triangle. I always think of where 30 goes, because if 30 goes here, I then think of sine 30. Sine 30 is opposite over hypotenuse, which is a half. And then automatically I know that, okay, fine, this has to be a 60, and this has to be a square root of 3. So cos 30 is something we can deal with. Cos 30 is adjacent over hypotenuse. So we're going to have here adjacent over hypotenuse. And then we have sine x over there. Sine 30 is opposite over hypotenuse, which is just a half. Perfect. And then this is equal to 2. We'll just re-add our fallen soldier. Wait, I think my mic, I don't know if audio is not working for me. Let's see. Leo has a question. Not sure if you can hear us. We tried talking. Oh, dang it. Okay. Let me try talking now. Let me see if I'm going to hear you, because I think I know what I was doing wrong. But just try talking now. I think I'll be able to hear you if you say something, because I think I heard someone as well. Leo, are you there? No? Yes? Like, I'm not being heard. No. I can hear you now. I can hear you. Yes, you were saying?
Oh, you can hear me now? Oh.
Yeah, I can hear you now.
Yeah, it was the previous question, but you've already gone past it, so I think it's fine now.
Okay, was the question you were going to ask answered?
No, it was that sin p plus 7, plus that sine p plus sine q is equal to 7 over 5 question.
Oh, okay. Well, I mean, if you want to ask a question on this, yeah, let's go. What's the question?
I was going to say, since sine is like how would you say it?
Since sine is a what?
Like we can, I was thinking we can take out sine and we can make it like sine bracket p plus q.
Oh yeah, yo, that's a classic trig. What you may call thought. That's not necessarily something we can do, because remember, you have to remember, with a trig ratio, it's not something you can distribute, you see, because sine p plus q is not the same as sine p plus sine q. It's not the same, you see, because remember, when you want to expand this, you can only use compound angles, you see, meaning it would only end up as something like this, where it's like sine, cos, and then cosine as well, you see. Yeah, so these are not equal. But if they were equal, I think our life would have been a bit easier, you see. But unfortunately not. So I think this question still qualifies as a kind of a question that we can really just move away from at the moment. So with what we were saying here,
Okay, is that a problem?
Cool. So with what we were saying here, right? Let me see what else I need to do here. So just give me 2 seconds here. I think I need to do something quickly. I just want to get my earphones so that at least when I'm going to be talking, the audio is much clearer, because I'm pretty sure you can tell that, wait a minute, in terms of the audio, something definitely happened. So let me just auto fix that quickly, and then we can carry on with this question. Anyways, I hope you can still hear me. If you cannot, just let me know. If you can, also just let me know, because I just changed something as well. But I think you can hear me, because I think if you couldn't, then I mean, you know, yeah, you would protest. So anyways, let us just carry on. So carrying on here, this is what we need to keep in mind. Let's see here. Here we have sine x. Okay, fine. So with what we have done here, I mean, we haven't done much. We just have to keep in mind that we're trying to get the general solution. And anytime you're trying to get the general solution, your goal is low-key to have one trig ratio, of which we kind of low-key are going to have that if we can take the sine to one side. So here we're going to have 2 sine x minus a half sine x. And then here we just have square root of 3 over 2 cos x, because it's easier to write the numbers in front instead of writing the numbers, you know, at the back or something. So anyways, the next portion here, right, we're going to, let's see, 2 minus a half is just 3 over 2 sine x over there. And then here, square root of 3 over 2 cos x. So the fortunate thing here now is, this is the part of your question where you need to remember that a fraction is just as good as a normal whole number when you do calculations. Because in terms of a calculation now, we want to end up with like a 10, right? Because we have like cos on one side, sine on the other side. The only way we can end up with a 10 is if we divide both sides by a cos. You see, because sine divided by cos is what gives us a 10. So in our next step here, the left side, which looks like this, we are technically going to divide the whole thing by, we can literally just, I mean, without being extra, let's just divide by cos only. You know, let's just divide by the cos x, I mean. So here we're going to divide by cos x. And then on this side, we have 3 over 2, right, with sine x over there. That whole thing we're also going to divide by cos x. So what's going to happen is the cos x here cancels the cos x. Remember, this is just a number. So what's going to be left here is this number divided by 1, which is just square root of 3 over 2. Here is just sine and the cos. Sine divided by cos gives you a 10. And then here, this number divided by 1 is just going to give you 3 over 2. And then you have 10x over here. So remember, you want to have the trig ratio on its own. So it means both sides now you can divide by 3 over 2 on this side, and then this side you can just divide by 3 over 2. And then remember, these calculations here of you dividing a fraction with another fraction, just put them in your calculator. You see, you don't even need to stress yourself, nothing. So here 10x is going to be equal to, in your calculator, it's going to come out as 3 square root of 3 over 3. And then that's 10x. Perfect. And then we are trying to get the general solution. So anytime you're trying to get the general solution, you always need to get a reference angle first. So getting a reference angle from what you may call, from what we have here, we can just get a calculator. I'm just trying to get the calculator here. I don't know why I put this calculator. Oh, I think I got it. Do I got it? No, calculator. Oh, there we go. I have the calculator now. So whenever you're going to deal with the general solution, right, always make sure that you get a reference angle first before you do anything funny. And then whenever you get your reference angle, always take note of the fact that you don't consider the sign that's here. If it's a plus or a minus, it doesn't matter. Always take the value as a plus all the time. So your reference angle here is going to be equal to shift 10 with this value over there. So your reference angle in your calculator, let's see, shift 10 with square root of 3 over 3. This is going to give you a 30. So this is like 30, right? So this is like 30 over there. Now, once you have a reference angle, now you can refer to what was written over there. You see, if it was a plus, all you need to do now is to ask yourself, where is 10 a positive? You see, so we know that 10 is a positive in 2 quadrants. It's positive in the first quadrant and the third quadrant. So in the first quadrant, you just take your reference angle as is, and you make it equal to whatever this is. You see, so here x is equal to 30. Here's an element of integers here immediately. So that's in quadrant number 1. Quadrant number 3, we already know this is the quadrant where you have 180 degrees plus the reference angle. So in that quadrant, I mean, we already know that you're gonna get the x is equal to 180 plus the reference angle, and then plus k 180. K is an element of integers, which is just 210 plus k 180. K is an element of integers. Okay, nothing crazy, nothing major. We shall carry on. If there are any questions, feel free to do the asking, but if there are no questions, then away, let us move on. With question 6.2, it's a trig graphs question. It says, in the diagram, the graphs of f of x is equal to this. Okay, let's just double check that. And let's just color code them. But I mean, we don't have to. We can just maybe use bright colors. So let me just put here f of x looks like this. Go now. Hi, Boman. Yes, there we go. So this is f of x. F of x is clearly a cost graph. So this cost graph here, we have a sine graph also. So what you want to recognize anytime you read a trig graphs question, you already want to be able to pinpoint very specific pieces of information. What I mean by that is, I mean, like here, your standard form of any trig graph, right, will always tell you things like, well, then, for example, the standard form of a trig graph, right, will look something like this: a cos, and then you have excuse me, like let's say bx minus p and then plus q. This is stuff like from the trigonometry revision playlist. So if you haven't gone through it, you definitely need to. If let's say this is a bit something that's like, wait, what is that? So just a quick rundown. We already know that a here is like amplitude, excuse the writing. B here is for frequency. You're now frequency. Why am I even rushing? Right? Me. Feel like, yeah, let me just slow down. Frequency. P here is the horizontal shift, which is a shift from left to right. And then Q here is the vertical shift, So from that being said, our graphs here are already telling us two things. Like here, the value in front of cos here is just a 1. So the amplitude is a 1, and we should expect to see that. So meaning from here until there, that should just be 1. From here until there, because if this is the turning point, this is just an estimate, this would need to be 1. So for the next one, the amplitude here is a 2, you see. So we can already see that according to our image, from the turning point until the x-axis, this is 2, because this graph has not been moved up or down. This one also has not been moved up or down, because there's nothing outside of the bracket there. So that's how we know that this automatically and this automatically, according to the image, that's the amplitude. So if this is 2, it also automatically means that, I mean, the distance here is also going to be 2. You see, it's just information that we know. Secondly, this cost graph, apart from the original state, this negative 30 is telling us that this graph was moved 30 degrees to the right. You see? So let's say here, moved 30 degrees right, because it's a minus. If it's a minus, it's a movement to the right. If it's a plus, it's a movement to the left. So whenever I say movement from here to there, blah, 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 we're always judging based on what the original standard form is. Because the standard form of a cos graph, right, is y is equal to cos x. And then this graph on a Cartesian plane, I mean, if you're looking at it normally, it would look something like this, right? Where this is like 90, this is like 270, up here is like +1, down here is like -1. So this image here, because the graph was moved 30 degrees to the right, it's no coincidence, because you see the turning point, instead of the turning point being at like 0, the turning point here, you can clearly see it's going to be at 30 degrees over there, because the original picture, the turning point was like there, you see. So this movement to the right is why we're seeing this turning point at 30 degrees specifically, because initially it was like somewhere here. But then because the graph was moved to the right, the image now has the turning point over there. So let me actually just color code this cost graph over here. So this cost graph here, it was moved 30 degrees to the right. With the sine graph, we can see that nothing happened to it. That's why it still just looks the way it looks, you see. It's still cutting the y-axis at 0 there. If you look at the original image of a sine graph, it looks something like this, you see. And at 180 degrees, it will be cutting the x-axis, which is also what it's doing here. At 0, it will be cutting the x-axis, which is also what it's doing here. And then this one, the only difference is that the amplitude is a 2. That's why this one goes all the way up to 2. So all this information, right, it's stuff that's like supposed to like rush into your brain the moment you like go through that question as you're reading it. So with all we've said, it says here now in the diagram, the graphs of f of x and g of x are drawn in the interval -180 to +180. So that being said, they told us that A and B, let's see where A and B is. A and B, there is A over here, there is B over there. A and B are the x-intercepts of f. And then it says the two graphs intersect at C. Okay, they intersect at C. Yeah, I see like my stuff is like all over the place here. So there is, let me actually remove all these other pieces of information here because we don't need that anymore. We're just putting that there for explanation purposes. But if we ever need them again, we shall recall them. But for now, A, we don't need them. We don't need them. So they meet at C, they meet at D, and then A and B are the x-intercepts of F. And then it says the minimum, it says that the two graphs intersect at C and D, which is the minimum and maximum turning points of F. So they have confirmed that, yes, definitely at this point, it is a maximum turning point. You see? And it has also been confirmed that definitely at this point, it is the minimum turning point. Perfect. So all that being said, on the coordinates of A. Writing down the coordinates of A is purely based on you knowing your theory, because your theory has told you that the original graph was moved 30 degrees to the right. So automatically, if your graph was moved 30 degrees to the right, you want to judge according to the original one. The original one would have an x-intercept at +90. But then this one is having an x-intercept somewhere different, obviously. So we need to find out what this x-intercept is, of which, according to the original image and according to this shift, this new x value is just going to be at positive 120. Reason being, the original graph cuts the x-axis at 90, but then this one has been moved 30 degrees to the right. So the 90 plus a movement of 30 to the right is going to give you an x-intercept of 120. So the coordinates here, we already know that x is a 120, and then the y value is clearly just a 0. Because remember, a tree graph is still just a function. You know, it still just has an x value, still just has a y value, and you get it the same. So if you have any questions on anything we're going to be doing, trust me, you can always just switch on the mic, and then we shall hear what you have to say. Well, the next question is asking for C. You're going to get C the exact same way you got A. Reason being, you want to be familiar with what the original image looks like, because knowing how working with the original image always opens doors for you. Because here, if you look at the original image, right, you already know that this turning point here was at 180. So automatically going to the left, right, this is 0. This is going to be negative 90. And then this turning point would have been at negative 180. You see, that's like something we all know based on the image. This is 90, this is 180. And then to the left side, this is negative 90, this is negative 180. And then this is the turning point, you see, the minimum turning point, of which this same turning point over here is this new turning point over there. So you can already see this turning point was initially at negative 180. But then because our graph here was moved 30 to the right, it's not at negative 180 anymore. It's 30 degrees to the right, of which 180, if you move 30 degrees to the right, your x value there is going to be 150. So that sorts out the x value of C. The y value of C, it's also going to go back to our theory. You see, our theory is telling us that the amplitude of this coarse graph is a 1. And because our graph was not moved up or down, it basically does tell us that from the turning point to the x-axis, the distance here is just going to be a 1, you see. So because this is like 1 unit going downwards, it's showing us that the y value of C is just going to be a negative 1, you see. That's all you need to keep in mind there. This is just 1 unit downwards, so it's going to be a negative 1. This is 30 degrees to the right of negative 180, so this is going to be negative 150. That is why they are making this question a 2-mark question, because obviously you're going to get a mark for this because you had to use your theory there. This, you had to use your theory there. So from just these 2 questions, I think it should dawn on you that, okay, wait a minute, the theory is like something that is actually a big deal. Because if the theory is off, then yeah, you know, you're gonna assume that these questions are difficult. So let us move. So it's a 2-mark question here, and let's see what the 2-mark question says. This 2-mark question says, determine the values of x in the interval negative 180 to 180 for which both graphs are increasing. So this kind of a question should not bother you at all. Let me actually try and, I don't know, so they're asking where are these graphs increasing? So let me actually maybe take a snippet of this question, because I mean, like, we might also just use like the empty version of that question instead of us, like, you know, drawing over that whole question again, because like, why you gotta do that, you know? So let me just try and get a clean image of the question that we are dealing with so that we can easily explain this question and the following one, because these questions that ask you about increasing and decreasing, if you have an image, they're the easiest questions to like answer. And we're just about to showcase that just now. Okay, so let me grab this here. Let me or do this. Let me do this. Hello, what is this here? Get an image there, get a clean one over here, and then survey. So with all that we have here, they're asking us where is this graph, where are these graphs both increasing? So I think the part where it says both is what's important, because there are cases where one of them is increasing while the other one is decreasing, and then vice versa. But then there is a specific portion where they are both increasing. And the way you answer this question is always look at the motion of how the y values are behaving if you're looking at the pictures from left going to right. Let me repeat. If you look at your graphs going from left to right, let's say you're riding a bicycle on this line. Here you're going to be going down, right, until this turning point. And then you're going to be going up. Anytime where you're going down, that's a portion where you're decreasing, you see. So in this graph, the green part is showing where the graph is decreasing. The purple part is showing where it's increasing. And then here again, the green part is showing where it's decreasing. We can do the same with the sine graph. The parts that are decreasing, we're going to use green. The parts that are increasing, we're going to use purple. So in terms of decreasing, it's all about you thinking to yourself, if this is like a ball, right? If it's gonna be going, it's gonna be rolling down this line. So that portion until here is decreasing, you see. But then from that specific point all the way to the next turning point, your graph here is increasing, you see, because remember this ball would go upwards all the way until up there. And then from here, we know that it would start going down, you see. So that's the part where the graph is decreasing, you see. So the purple is increasing, the green, the purple is increasing, the green is decreasing. So our question wants us to state the x values where they are both increasing. So stating the x values where they're both increasing, it's clearly going to be an easy task here, because you want to get a specific portion where they are both purple, of which that low key starts at this x value over here, and then it ends at this x value over there, you see, because between this x value here and this x value here, they are both increasing. To the left of this x value, you can see there's a mixture there, and then to the right of this x value, there's also a mixture over there. But then between this x value and this specific x value, that's the only portion where it's both increasing and the other one also increasing. So our task is to just know what x value this is, of which we already showed that this x value is just 30. Reason being, we know that the standard cost graph, it usually cuts the y-axis at 0 over there. But then this graph was moved 30 to the right. So that's why your turning point here is now at 30. So we know what this x value is. It's just the 30. This x value over here is not very difficult to determine, because it all goes back to the standard picture of a sine graph. And you want to because remember, the standard image of a sine graph looks something like this. It looks like this, and then it goes like that, you see. So this is like 360, this is like 180, and then on the left it would behave the same. This would be like negative 180, and then it would go on like that. So that's what a standard cost graph looks like. With our case, right, without worrying about the y values, all we know is on the left side, you see on the right side here, the turning point is at like 90. So obviously to the left, your turning point is also going to be at negative 90 over there, which is exactly what we're seeing here. Because if you look at it nicely, see between 0 and 180, you have that arc over here, which is what you would get on the original graph. You see in the middle here, you already know that you'd get 90. And then on the other side that, you would also get a 90 over there, of which if it's to the left, we already know that it's just going to be a negative 90. So that's why here we have a negative 90. So that's why our answers, where are both of these graphs increasing? Both graphs are increasing where x is bigger than negative 90. So x has to be bigger than negative 90, or x has to be smaller than positive 30. So the reason why we're not saying bigger than or equal or smaller than or equal, the reason why we're not saying that is because specifically at 90, right, one of them is not increasing at all, you know, because anytime you see that a graph is at a point where it's neither going up or neither going down, that part is always obviously a turning point. So at a turning point, a graph is neither increasing or decreasing. So that's why we're not including the negative 90 over there. We're just saying everything above negative 90. And then that's why here we're also not including the positive 30, because specifically at positive 30, there's a graph that's like neither going up or neither decreasing. That's how our answer has to be written like this. And then most people would want to write this as like one line. You can do it, but it's not necessary, you know. If you want to do it as one line, you can always just draw your x variable there, and then always make sure your signs point in the same direction. So we can make them point wherever direction we want. And then there's bigger than here, right, where x is. So if x is on the bigger than side, then negative 90 should go on the smaller than. Here, x is on the smaller than side, so 30 should go on the bigger than side. This is only if you want to write it like this, but you don't have to, you know. You can write it split up, or you can even write it as, I think it's called set builder notation. You can say x is an element of negative 90 up until 30. You know, these are all options. They are all the same thing, just written in different ways. So you can do this. Let me not put square brackets because it's gonna make it seem like it's part of the answer. But then I just wrote out these three to show that there are three ways. You just have to choose one way to write your answer. Let me actually write it down explicitly here. Choose one way to write. Oh, that's not right. Lol. To write your answer. Just choose one way. You don't have to do all three. So I think we're just going to finish up question 6, and then I think that's probably, maybe we'll do question, let's see, I think we'll just do question 6 so that we don't like pile on too much all in one go, because that is not necessary at all. So let me just double check if there are any questions. Nope, everything is good. So with what we're looking at now, right, this next question here, we're also going to need to use our image, you see, because for 2 more marks here, this is what we need to do. So here we have to be creative. You know, we have to be a bit creative, but not too much. Not too much. Where is this graph going to be above this graph? So without panicking, right, all that's happening here is that we have a scenario where f of x was moved 10 degrees to the left. You see, this was moved to the left, and then this graph. So before you even worry about the movement from left to right, you see, this is just a question that is asking, where are the y values of f above the y values of g? That's what these questions mean. They're asking where the y values of f above the y values of g. The fortunate thing is they were both moved 10 to the left. So before worrying about that, then the main question you should always be able to recognize is that when you see stuff like this, they're just asking where the y values of f above the y values of g. So we can use 2 colors as well to just distinguish which one is up, which one is below. So let me see here. Oh goodness, what is going on? Ah, he's gone. Oh no. Oh no, I hope whatever we wrote down is still there, because if it's not, I was about to have a heart attack, like, dang it. So anyways, so with all that we're doing here, right, we just need to recognize they're asking where the y values of f above the y values of g. So with all that being said, let's just look at it nicely. So if you're going to scan from left to right, I mean, you can already see that here, this part here, your y values of, we're talking about, let's talk about the graph of f first. So looking at the graph of f, right, we can see that the yellow part, this is where the graph of f is above the graph of g. After that, you can see that the graph of f is below the graph of g. You see, I'll repeat. If you're looking at your image from left going to right, from negative 180 going to the right, you can see that f is above the graph of g. But then from this x value here, this is, as we worked out, let's see what it was again. We worked it out to be negative 150. So this is like negative 150. From negative 150 all the way until this x value over here, which is a 30. From the 150 all the way to the 30, the graph of f is below the graph of g. But then just after 30, we can see that the graph of, oh wait, I think I'm mixing it up. Oh no, dang it. Wait, am I? Yeah, no, wait, let me repeat. Let me just remove this yellow for now. So we're looking for where the y values of f are above the y values of g. So f is this graph over there. Oh yeah, I was about to mix it up. So from C going to D, this is the part where f is on top. You see, from negative 150 to positive 30, that's the portion where the graph of f has y values that are bigger than the y values of g. And then from 30 going onwards, you can already see that the tables have turned here. F is now below the graph of g. So the question is literally just asking us, where is the graph of f above the graph of g? So originally, without any movements, we can see that the graph of f is above the graph of g from negative 150 up until 30. But then the issue now is, if these two graphs are both moved 10 degrees, 10 degrees left. If they both move 10 degrees left, then we automatically know that this 150 would become a negative 160. And then this 30 would become a positive 20. You see, because if they're both moved to the left 10 degrees, then it means that the part that's going to be above the graph of G would be from negative 160 up until negative 20. So your answer there, you would need to say that X is the element of negative 160 up until positive 20. You see, we're not including the negative 160 and the positive 20 because specifically at these points they're equal to each other. None is above the other. So this is obviously one way you can write your answer. And as we said, you could have said here X is bigger than negative 160 or X is smaller than 20. And then another way you could have written out your answer, you could have just said, you could have put X in the middle, right? And then just put inequality signs facing the same direction. And then you can think to yourself, okay, X here is, if X is on the bigger than side, negative 160 has to be on the other side. So you'd need to put negative 160 here, and then here you'd automatically put a 20. Because here it's saying X is on the smaller than side. Then there's a 20 on the other side. So here X is on the smaller than side, and then there's a 20 on the other side. So that's the big idea with what we were doing with this question. So again, these kinds of questions, the more of them you're going to do, the better for yourself. So you maybe don't want to be too judgy on yourself, to think that maybe they're too far-fetched. No, they're not. You see, the more you're going to bump into these kinds of questions, the more you will learn to like work with your pictures and everything. So let me see. I think, yeah, this last question is the last one that we're going to do. So this question here is obviously, I mean, like a 5-mark question, yo. You can imagine this next question here is not going to be playing games at all. because I mean 5 marks, that is no joke. 5 marks is not a joke. So we have to think strategically with this kind of a question. So firstly, with this kind of a question, I might as well even rewrite it out first. Y is equal to sine, no. Y is equal to 2 and then 2 sine x plus 30. So with all this being said, right, we have to be careful. When I say we have to be careful, oh no, that's not a 30, it's a 3. So with all this being said, right, we have to be careful, and we also have to be careful to write the question properly. Otherwise, it's chai. But anyways, let's see here. So with what we have written out, right, they're asking us to determine the range of this equation, and it's a 5-mark question. So again, this question we are gonna go through it, right? But then, in my honest opinion, it falls under these kinds of questions here. I think because it's the last one we're doing, I might as well do it. But then it genuinely falls under the kinds of questions like these, right? You can already see 5-mark. I mean, that's not a coincidence. So these kinds of questions, right? The best thing you can do for yourself is, if it's in an actual exam, don't do these questions before you're done with your whole paper. You see, always do them after. But then anyways, for this specific session, since we are ending things off, we can dive into it and see what we need to do. So with this question, right, you have to think smart. When I say you have to think smart, what I mean is always keep in mind that this kind of an equation, I mean, when it's all said and done, right, we kind of don't know what you may call, what kind of an image is going to be drawn from this thing here. Like, we kind of have no idea. But then what you can do is always work in terms of boundaries, because you see your range here. Your range is just asking for the boundaries, or boundaries with the B, bruh. This is just asking for the boundaries from top to bottom. You see, that's what the range is asking for. The range is basically asking you how far up will your y values go, and how far down will your y values go, regardless of what image this is going to be. So what we know is how far our graph goes and how low our graph goes. It is obviously going to be determined by what comes out here. Let me try and write it out. Oh goodness, let's see here. I'll repeat. Depending on how far this graph goes, and depending on how low it goes, it is all going to be determined by how far this goes. And right, we can see that this is going to be a sine graph. So I mean, like, one way or the other, whatever this is going to determine how high or how low this goes. The reason why we're highlighting this part is because this is the part that can change. The 2 can't do anything. The 2 is just stuck. But then depending on how this changes, it's going to affect our y values. So your focus here is specifically going to be here first. You are going to focus on how far will this graph go and how low will this graph go. Because the moment you can figure that out, you can then start worrying about the whole equation, you see. So let's highlight this 2 sine x plus 3. Now, with what we mentioned right in the beginning when we started this here, frequency, horizontal shift, vertical shift, blah, blah, blah. We mentioned how important it is. Because now when you're going to see stuff like this, it's going to be easy for you to get the range of this. Because if you can figure out the range of this, you can eventually figure out the range of the whole thing. So the range of this kind of an image, the easiest thing you can do for yourself is to try and draw what kind of an image this would look like. So the first thing is, we're seeing that this would be a sine graph. So let's just draw a Cartesian plane. We're seeing, we'll take it in stages. This is a sine graph that has an amplitude of 2, I'll say it in words even. This is a sine graph that has an amplitude amplitude of 2, and it has been moved 3 units to the 3 units up. It has been moved 3 units to the top, but I think it's easier to say it has been moved 3 units up. 3 units up, you see. That's what the 2 and the 3 there are basically representing, you see. So here you can see this 2 here is the 2 over there. And then we know that the shift 3 units up is this because of how the standard form is, is laid out. But anyways, that being said, we can easily now see what the image looks like. So in terms of the image, right, you don't want to panic. Like, just start off with what the standard original image looks like. So a normal sine graph, right, it has an equation that is just saying y is equal to sine x. You see, that's what a sine graph is. Y is equal to sine x would draw a picture like this. So you always want to judge from the original picture what another image would look like. So from the original picture, you already know that this is 0, this is 180, and this is 360. And then up here is like +1, down here is like -1. So the first thing is, if you look at the amplitude of the new graph, an amplitude of 2 means that your graph in 1. If the amplitude is a 2, it means that the graph would be going from +2 to -2 down there. So that's what would change first if you have a 2 in front over there. So if you have a 2 in front there, your graph now goes to 2, and your graph now goes to -2. That's what the 2 does. The +3 here, we now know that the +3 moves our graph 3 units upwards. So this image here gets moved 3 units upwards. So instead of it being at 0 here, it's going to go 1, 2, 3 units up. So it's going to be like somewhere over there, you see, of which this specific spot over here, this is going to be a 3, because remember the graph was moved 3 units upwards. So even though this graph was moved 3 units upwards, you have to take into consideration that the amplitude is still a 2, you see, because this is going to be, let me just move this over here. Let me just plus the 3 over here. So here from 3, right, your graph is still going to go 2 units upwards, meaning your graph is going to be going all the way to 5. So from 3, it goes to 5, it goes back down to 3, which is going to take it down to like -1, and then it goes all the way again, and then it carries on and it does its thing, going on and on and on up until, infinity or whatever. So this image here should give you an idea of what happens to a standard graph when it gets moved up or down, or the amplitude changes, because we can already see here it has been moved 3 units upwards, right? And we saw that the amplitude was changed to 2. So from 3, the graph goes 2 upwards. So we can see that the highest value that this graph goes to is a 5. So from 5, it goes down 2 units. It's going to be back at 3, and then the lowest value here is going to be a +1. You see, so the graph goes between +1. Oh, I don't know, I put a negative there. That was a mistake. So the graph goes between +1 and +5. That's what is the range of this image here. So let me actually write it here a bit neater now, because we have just done whatever we've done here. So this graph, it starts at 3 somewhere, it goes 2 upwards, it goes 2 downwards, and then it goes 2 down again, and then it goes back up until there. So this here would be like 360. Here this would be a 0. Up here this would be a 5, and then down here this would be a +1, and then in the middle here it's still just going to be 180, because the graph was not moved to the left or to the right. The graph was just moved upwards 2 units. That's why from this point here until that point, this is just 2 units. You see, from this point Until there, this is just 2 units because of the amplitude over there. So with all that we've said here, the range for this part, or the range for this part here, let's just make this a bit clearer. Let's take our question, copy this thing here, paste it down over here. So with all that we have mentioned, right, we already know that the range of 2 sine x plus 3 is basically going to be +1 until +5. That's the range of this piece of information here. Let's actually just see. So the range here, we have determined that it is between 1 and +5. So this 1 and +5 here, this is telling us that up here, right, 2 to the power of something and 2 to the power of something is going to give us the range of the whole thing. Let me repeat. We have seen that this exponent, the highest it can go is a 5, and the lowest it can go is a 1. You see, let me actually write it in words here. You see, our exponent, which is this thing here, remember this is our exponent. You see, so let me say here, change color, let's make it a yellow. You see, so our exponent here, right, its range is between 1 and 5. So technically our exponent can go up to 5. Our exponent, let's say our exponent's lowest value is 1. You see, our exponent can go in a way that like matches. We can say here our highest value of our exponent is 5. Our lowest value of our exponent is 1. You see, so we already know that from this question, this here can never go above 5. And then that same thing here can never go below 1. You see, so just us knowing that the highest thing here is a 5 and the lowest thing here is a 1, it already gives us the range of our bigger picture, because what we already now know is that y is equal to 2 to the power of 1. This is going to be the lowest that our image can go to. Furthermore, y is equal to 2 to the power of 5 is going to be the highest that our graph will be able to go, based on what this can be. Because this here, the highest is just a 5. The lowest is just a 1. So automatically, the lowest of the exponent is going to give us the lowest of our bigger picture, which is just a 2. And then the highest of our exponent is automatically going to give us the highest of our bigger picture, which is just a 32, you see. So that's why here the range of our bigger picture here, the range is just going to be y is an element of +2 until +32 over there, you see. So you can see why this question low-key falls under, you know, the kinds of questions that if you bump into them, if you're not done with the full paper, just go through the full paper first and then come back to these questions, you see. So the moral of the story here is, whatever this question was, the range of our image was all going to be determined by whatever the exponent is going to be, because remember, the exponent is the one that can change. This is stuck. So based on how this can change, we had to find out, okay, how high can this go? And we saw that it can go as high as 5. And then we ask ourselves, how low can 1? So the moment we knew that it can go as high as 5 and it can go as low as 1, we were able to then say, okay, fine, this exponent, the highest value is a 5, so that can give us the boundary for our range. The lowest value is a 1, so that can also give us a boundary for the range. And then we now know, okay, fine, regardless of what this is up here, it will always just be the highest value 5 and the lowest value 1. So that gave us the range of our bigger picture over there. Well, it's 3D triangles, right? The one thing you'll always hear me say is that it doesn't matter if you are dealing with a 3D sketch, right? It really doesn't matter, because one way or the other, you're always going to be working with 2D shapes within that whole image. So for example, what we're seeing here is they said in the diagram below, CGFB, where is this thing? CGFB is what? CGFB, where is C? CGFB. They said we have CGFB and CGHD. CGHD. That's also another rectangle over there. And then it says here a fixed wall. So this is a wall, and then this is a wall. Now from them saying that, they also said here there are fixed walls in the shape of a rectangle. Fixed walls that are rectangular in shape. So I mean, like, some of these things that they'll just say casually, I mean, like, don't take them for granted, because I mean, like, it automatically telling us that this line is equal to that one, and then that one is equal to that one. So it means automatically it's equal to that one as well. And then whatever this line is up here, it's equal to that line down there. So in terms of them telling us that it's a rectangular shape, we can just keep in mind those kinds of things. You see, if this is x up here, down here it's obviously x. If it's x plus 2 up there, down here it's obviously x plus 2. So these dimensions here, I think they might help for the triangle at the bottom. So the other thing with 3D shapes is you always want to not think too plainly. You know, you don't want to think that these are in the same plane. You know, these angles won't add up to 100, and they won't add up to 360 because they're not around this single point here. You have a triangle up here, it's in its own plane. You have a triangle on the right here, it's in its own plane. And then you have one here, it's also in its own plane. And then you have the rectangle down here. This rectangle and this triangle, they are obviously in the same plane. You see, because this is a straight line going up, and then a line there, and then there. So this is like a trapezium in the same plane. And then here you also have a trapezium in the same plane. But then the idea is this triangle and this triangle, they're not in the same plane. Same as this triangle and this triangle, they're not in the same plane. So that's what you want to keep in mind. Let's see here. So moving on from all we've said here, the next thing that they said in our statement is that they clearly told us here that they said fixed walls that are rectangular in shape and vertical to the horizontal plane. So when they say vertical to the horizontal plane, they mean that these are like upright. They are standing upright, these two rectangles. And then you have a triangle at the bottom here, which is in the horizontal plane. So the horizontal plane is like the ground or the floor, you see. And then the vertical plane is obviously like what's going upwards, like a wall that's like perpendicular to like the ground or something, you see. And then it says here, yeah, you have this in the horizontal plane, which is FGH. We just mentioned that. And then it says steel poles erected along FB. So you have FB here going upwards, HD going upwards. They extend to A and E respectively. So it's also what we mentioned at the beginning. This is like one long line going upwards and one long line going upwards as well. And then they say your triangle ACE. ACE forms the roof of an entertainment center. So this is a roof there, and then it says they've given us these dimensions. So with these dimensions given, as mentioned already, we don't want to think that these are in the same plane. These are all in different planes here, same as these two angles. So these angles won't add up to 360 at all, you see. So anyways, with all that being said, we might as well just what you may call, with all this being said, we might as well just dive into the question, because I think I tend to spend a lot of time just blabbing around with some of these things. But anyways, the very first question for 2 marks here, they're saying we should calculate the length of AC in terms of theta and x. So the good news is, right, whenever you're going to deal with what you may call whenever you're going to deal with 3D triangles or trigonometry in general, always keep in mind that if you need to get something in terms of something and something else, always look at those things as though they were like values given or something. So if you need to get AC in terms of x or theta, I mean, like if you look at where AC is this line over here. You see, it's a line inside our right angled triangle. So we obviously, I mean, like, it doesn't look like we're going to have a hard time answering that question, because we have a right angled triangle and we need to get a length AC. So the fortunate thing with this question is that with all 3D and 2D triangle questions, always keep in mind that you're going to make use of the following things. You're going to either make use of the sine rule, you're going to make use of the cosine rule, you're going to make use of the area rule if they ever speak of area, you're going to make use of Pythagoras if you're going to have what you may call if you're going to have a right angle triangle, and you're going to make use of normal trigonometry. Hence why I'm putting here SOHCAHTOA, you know, opposite over hypotenuse, what. So this is if you have right angled triangles, you see. Then you want to keep in mind these two things here. So with what we have a right angled triangle. Obviously, you can think to yourself, okay, with this right angled triangle, if I'm going to get AC, you always need to keep in mind that whatever you do in trigonometry, always have your formula sheet with you. Or rather, anytime you're going to do math, always have your formula sheet with you as close as you have your calculator next to you. So if let's say like right now we're like talking, right, and you know your formula sheet is like somewhere far or nowhere close and you don't have it readily available, then that's a small problem, because your formula sheet is like one of those things when you're dealing with trigonometry, just have it close. Because if you look at your formula sheet, it's always going to keep you reminded of like what you have. So far with our question, right, you'd be thinking AC is just a side and we have an angle and another side here. So I mean, like, without overthinking this one, I mean, let me not waste anybody's time here. We have an angle up there, right? It's theta, and we have a side given here, and we're looking for a side up there. So I mean, like, we're clearly just going to use opposite over hypotenuse, which is sine. So sine, the angle there is just opposite, which is x, over hypotenuse, which is AC. Now they want us to isolate AC. They want us to have AC as the subject of the formula. So that's what we're just going to do over here. So let's see here. We are going to have, if you're going to make AC the subject of the formula, the first thing you can do is make this a fraction so that you can just cross multiply first. Meaning you'll have AC dot sine theta equal to x. And then if you're going to isolate AC here, you're going to have AC equal to x over sine theta. So this one, I don't think there was an issue. I think I'm actually spending way too much time on it. So let me just move on to the next question. It says here, for 2 more marks, we need CE in terms of x. So CE is this line over here. We need it in terms of x. So I mean, like, we can clearly see we're not going to have any issues here. It's literally just back and place. So CE, same idea. We have an angle and a side here. So this is just going to be adjacent over hypotenuse with the cos 60 there. So here we're going to have cos 60 equal to adjacent, which is this value there. And then our hypotenuse is the CE. So what you can take note of is, I mean, like, regardless of the fact that this is a 3D shape, we're literally only using one triangle at a time, depending on what we need, you see. So here, if we're going to do exactly the same thing. If you cross multiply, we're going to have this times cos 60, and then we have x plus 2. Having CE on its own means that we have x plus 2 here, the whole thing over cos 60, of which the cos 60, I mean, like, we can write it as a value. Cos 60, according to our special triangle, it is, let's see what cos 60 is. Cos 60 is, let's see, there's 30 here, there's 60 there. So this is going to be opposite over hypotenuse and then square root of 3 here. So cos 60 is adjacent over hypotenuse, which is a half. So at the bottom, you have a half, meaning here you're going to have x plus 2 over a half. Now, anytime you see that you have, I mean, if you leave it like this, you should be fine. You know, like you don't wanna think that you have done something wrong or anything. But then for cases like this, right, always try and end up with like something that looks normal. Okay, this does look normal, but if you have something over a fraction, always just try and remember that you technically just have the top, right, divided by the bottom. You see, you may want to see it like this, so that you just keep in mind that, okay, this you can put it over 1, and then this here you can change it to a multiplication sign, and then just flip over the other side. Because if you do it like this, you at least end up with just 2 with x plus 2 here, which is your value for CE. And this is like much easier to leave as an answer, because if you ever need to use CE in the following questions, you'll always at least be using something that is already, you know, a bit simple and not something that's like difficult or something crazy to work with. So what I've just done here, it's not something that you should think of as something that is too far from your reach. Nope. All we did was the bottom, there's a fraction. So this division line, we just changed it to a division symbol. And then all we did was this, we can make it a fraction as well. So a fraction divided by another fraction, we just flip and multiply. You see, that's all we did there. So CE is equal to this value over here. So before I move on, I will take a second to just double check if anybody has any kinds of questions. If nobody has questions, then we shall carry on and we shall add whoever we need to add. But we are going to move on. Question number what? 7.2 here. 7.2 says, show that the area of the roof ACE is given by this. Okay, so we need the area of the roof. So let me also just maybe grab this, and so that we don't have to keep coming up here and all that shandies, because like, why would we want to do that? You know, why would we want to keep coming back? So they're talking about the roof and us getting the area. So the one thing I can say up front is, because they have spoken about a roof, because they've spoken about area, that's our first hint that, you know what, we're going to use the area rule. Like, hello, most definitely we're going to use the area rule, you know, without a doubt. Okay, we might not even need the area rule. Maybe we would use other formulas, but I mean, like the way this question is set up, we're probably going to use the area rule. So it said we should show that the area is given by this. So what you want to take note of from all these questions that we've been doing is that anytime we were working with these shapes, you see, as long as we had, let's say, a figure for a specific side, we could use it to help us. Here we had a specific expression for a side, so we could use it for whatever we're being asked. So here now we should keep the same analogy, in the sense that if you think of AC, we ended up with just x over sine theta. So that is an actual value for our triangle. We should look at it as something that we can use for our triangle, x over sine theta. Now for the green here, what do we know? For the green, we know that we have 2 and x plus 2. So this is going to be 2 and then x plus 2, like that. So with all this being said, right, we want to look at this as a triangle where we have a side here, another side here, and an angle in the middle. So I mean, like, just keeping that in mind, we can easily use our area rule for this question, because they said show that the area of the roof. The moment they speak of area, I mean, like, as we said, this is our go-to list. In this list, one thing has area. Or we could have thought of like maybe half base times perpendicular height. But I mean, like, the way this sketch is set up, you know, you're not going to use half base times perpendicular height there. So these 4 marks are clearly just given, because our area rule, according to our formula sheet, which we should always have so that we don't ever have to worry about thinking too hard, this should just tell you that our area rule will always tell us that we can always get the area if we have a shape where the side here is given and the side here is also given and the angle in the middle there is given, which is exactly what we have in our sketch here. You see, in this triangle here, A, CE. The question is already given us the answer because our area rule is going to tell us a half multiplied by one side, which is side AC, multiplied by another side, which is CE, multiplied by sine the angle, which is angle 2 theta here. This is our area. Or rather, since I was putting in just, angles, let me put ACE here, angle ACE. There we go. So in whatever we're doing, you have to keep in mind that on your side, you don't necessarily want to be like writing down what we're doing and that's the way you're following along. That's like a proper recipe for disaster. Because anytime you are maybe thinking that you writing down what we're doing is like you learning, yeah, that's not how it works, you see. Because you writing down notes of what we're doing, it's not as though it's like getting in your brain if you do that. It's almost like a distraction. So the best thing you can be doing for yourself right now is you could just be analyzing what we're doing and why we're doing it, so that you also maybe come up with like questions that you may want to ask. So here, carrying on, there's AC over here, it's just x over sine theta. And then here, sine CE is just x. No. Error. So because this is a fraction and this is a fraction, you may want to write this as a fraction as well. 2 and then x plus 2, close bracket. Yeah, it seems like I have a lot of brackets, but brackets save lives. So you can never have too many brackets. And also don't be intimidated by the fact that it's just like a fraction, a fraction, a fraction, a fraction. No. The reason for doing this is so that we can just keep things simple and neat. Because look, everything at the bottom, we already know that, okay, everything down here in yellow, this is what goes together. You see, all of this down here is being multiplied together. And then the top part, which is what we're putting in blue here, everything at the top here is being multiplied together, you see. That's the beauty of brackets. And that's the beauty of keeping things fractions if everything else is a fraction. So here automatically at the top, we know that it's going to be 1 times this whole thing here times the sine theta. The sine 2 theta. So at the top, we're going to have x and then 2 times x plus 2. And then we're going to have the sine theta. Before I even carry on, let me just recap on what we did for the top. For the top, you see it's just 1 times x. And then that whole thing is being multiplied by the 2 with the x plus 2 here. So you see this 2 with the x plus 2, because we know this is one thing. That's why we have put brackets around it. And then the sine 2 theta, it's still just the end over there. At the bottom, we know that we just had 2 times the sine theta times 1, which is just 2 sine theta. You see, this is our area. So just to wrap up, like here at the top, the x, we don't have to do anything, as we can see. So we can just leave the x on its own. Here it's 2 times x, which is just going to be 2x, and then 2 times 2, which is just going to be a 4. So the one thing you can keep in mind from what we're doing is that brackets matter. Because the moment here you're trying to just do too many things at the same time, you're going to find yourself in problems. So never be afraid to have a lot of lines. Like step 1 here, step 2, step 3. No. You can have as many lines as you need to have, as long as you know that you're not like feeling pressured to just, have shortcuts everywhere. That's not the point. So here at the top again, x here times the 2x is going to give you 2x squared. And then x here times the 4 is going to give you a 4x. You see, now this whole thing here, we know that whatever it is, you have to be careful. You see, this is where again brackets have to keep you reminded of like what is actually going on. Because if you look at it from the top here, I'll take things slow from here. Here we had 1 times the x, right, which is just the 1. And then whatever answer we got here, we knew that it had to be multiplied by this whole thing here, of which this is where these brackets come from. You see, because they sort of like represent these brackets here. But then we know that for the top, it was this x multiplied by this whole thing here. So we kept it in brackets. And then that whole answer, we know that it would need to be multiplied by the sine 2 theta. The bottom was not an issue. The reason I'm mentioning what I'm mentioning is because the moment we multiply these two together, right, this x with whatever this bracket is, we can see that we're technically multiplying x multiplied by this bracket. So the x has to be distributed, which is what this is giving us. Now remember, this multiplied by this is giving us one thing, of which that one thing is what we're multiplying the sine 2 theta by. So we just have to be careful of things like that. And here I think I should create myself some space before I like mess up real good. So let me just make this a bit smaller. Do that. And then from here, this is going to be what goes on the top here. And then let me zoom in here some more so that everybody can see nicely. So at the bottom here, we are just going to have the 2 sine theta over there. So let me put this here, 2 sine theta. Because normally if you don't have brackets, right, that's when you end up making just silly mistakes. So from what we have so far, you may not want to distribute this into the brackets because it doesn't seem very necessary. Because here now we can just be thinking to ourselves, okay, fine, our answer here, is it close? We're almost there because like there's a cos here, I mean like here there's sine 2 theta. So I mean like we can already be thinking of what you may call of special what? No, double angles. So here, this looks like we may have to eventually like, you know, take out a common factor again, but yeah, I mean like this, the way it looks and the way we have 2x here with the x plus 2, that can be a hint for us to say, let's take out 2x as a common factor here. I mean like it's a dumb thing to do, but okay, let's leave it like this for now. For now, let's just leave it and deal with the double angle over there. So dealing with our double angle over there, what you're going to see is this sine 2 theta can just come out as 2 sine theta cos theta. And then fortunately, the bottom, we are just going to have the 2 sine theta. You see, let me maybe make this a different color so that it doesn't, you know, get too weird. Yeah, so here now we can already see that, okay, everything at the top is factorized nicely. So the 2 sine theta here can cancel the 2 sine theta at the bottom there. And then we're going to have 2x squared plus 4x there. And then we have cos theta there. And then we said here, just looking at what we're supposed to end up with, it looks as though we can just take out 2x as a common factor. And then here you're going to have x left. And then here you're going to have 2 left. And then here you have the cos theta. And then that is your area. You see, that is your area. And then they'll give you 4 marks. So for this particular question, if there's anything that we wrote down that looked a bit not so friendly, or you know how these questions can be. If there's anything here that we wrote down that is not very, you know, lacquer, then you can just let us know, because that is that. Sure, I think we can move on. I think we can move on from this question because yeah, there's nothing else to say. Let's see here. Let's see. So with the next question, let's see, what is the next question? The next question is for, I don't know how many marks here. Let's see. Yeah, so with this next question, it could easily just be like 2 marks or even 3 maybe. But it says here, if theta is this and BC is this, calculate AE. So let's just see what AE is according to this. Yeah, so in here, let's see what they've given us here. They have given us theta, they've given us BC. Where is BC? BC is this length over here. So they've technically given us X, you know, X is equal to 12 because that's what BC is. So with X being given, they're asking us for AE is AE is up there. So that's quite interesting, because fortunately, remember, here we had we had what you call these dimensions over here. So it looks like for this question, them giving us BC as 12 is them giving us X. That's the heck here. So this is just 12 and sine with the 55 there. And then this is just 2 times X plus 2, right? So this is just 2 with X plus 2. Now this triangle here, we have the what do we have here? We have here this line, this going down here, this over here. This is like C, this is like A, this is like E. And then from here now, I mean, like, we can just try and simplify what we can, because I mean, like, what's the point? This is 2 times 55, so this is going to be like 110. And then our other two sides, if we put those values into our calculator, we're going to get something to use. But let's just leave it the way it is. This is like 12 plus 2, which is 14 times 2, that's like 28. This one, I think it's best we just leave it the way it is, because I think this is going to come out as like something with decimals and all that. So we have an angle here and two sides. So it is not a coincidence that they're asking for AE, because we can just use the cosine rule. Because the cosine rule also needs us to have something like this, where we have a side, and an angle. So the cosine rule, we have it on the formula sheet over here. And the idea with the cosine rule is that this side just has to go with this angle over there, you see. So if we're looking at what this formula looks like, let's just grab it here, because we said as long as you have your formula sheet next to you, you should be fine. So let's see here. Let me save this thing here so that I can just paste it over here. And then let's see what we got. Now we can just follow our formula. Let's just follow the formula. So following the formula, we are going to do the following. This is so dumb. Oh God, that's such a I can't stop. I know I sound like an idiot, and if I was just recording this video, I would have just gone so wild. But because this is like a Zoom session, I have to contain myself and not sound like an idiot. But anyways, heading on, we have, what do we have here? We have we're looking for this side over here, right? And this is the given angle. So according to our formula, this side goes with this angle. So meaning our angle here is what's gonna go there, and then our side here is what's gonna go over there. So here, if you wanna write down the formula first, it's AE squared is equal to AC squared plus CE squared. And then you're gonna have minus 2AC over there, and then CE over there. And then you have cos, what is the angle here? The angle here is angle C, right? And then from there, you are going to just work out AC. I mean AE rather. This is like AE squared. AC here is like this value, right? 12 sine 55. The whole thing squared. And then CE is like 28. There's like 28 squared there. And then AC here is just 12 over sine 55. Sine 55. And then the CE here is just 28 as well. So this is like 28. And then cos the angle in the middle here. This is like 110. So everything on the left, I mean, like, don't even bother yourself. Just put it all in the calculator. You might as well even put it under the square root, because I mean, like, this square here. Oh yeah, this square here, I mean, like, to get rid of it, you would just square root both sides. So yeah, whatever answer you're gonna get here, I think it's even easier if you just do everything all at once, you see. So let's remove this square here and let's just square root the right side. You might as well just put everything in the calculator like that. It's gonna save you stress. It's gonna save you so many other things. So just make sure you put it in properly. So this is square root symbol. And then obviously you're gonna wanna put open and close bracket. Inside the bracket, fraction button, and you're gonna put 12 over sine 55, and then squared that, and then plus 28 squared minus 2 with 12 over sine 55, and then you're gonna have there a bracket with 28 next to it, and then cos 110. Okay, in the calculator, all this is coming out as like 35.6, no, 35.77, 35.77, 35.77, like that. So there you go, there you go, there you go. This is what we have. This is what we have to deal with. Let's see here. Question number 8. So with question number 8, we have the following. They told us that we have a diagram. It says here, in the diagram, let me just try and sort this out properly. So it says here, in the diagram, O is the center of the circle. Yes. That's what we have. We have the center of the circle, right, which is O. Perfect. So anytime they mention specifically this, that something is the center of a circle, that's like a big bonus, because normally, I mean, like, you don't usually have a center. But unlike, remember, whatever we're gonna do, DRCPT, Dr. Cape Town, this is like super important. Like, if you're not yet sure what this is by now, then I'm sorry. But yeah, you just wanna familiarize yourself with it. It's on the channel. You can just search in the Euclidean Geometry playlist at, what is it called again? Strategies to approach Euclidean Geometry riders. But anyways, for 8 marks, right? Or just in case, let me not be a mean guy. If you go on the channel, the main channel, like the BYB one, you are going to find the following. This thing must just load, man. Like, nah. Why is this thing not loading? Sure. If there's anything more frustrating than something loading slow, tell me. But I don't think there is. I don't think there's anything more frustrating than slow internet, buffering, nothing. Forget it. But anyways, if you go in the Euclidean Geometry playlist, right, I think video number, I don't know if it's, what video number is this one? Video number 11, strategy to approach Euclidean Geometry riders. That's where Dr. Cape Town comes in, because it helps you to remember, like, what you call diameters, radiuses, cyclic quads, parallel lines, tangents, just a bunch of stuff that help you to remember theorems. So here now, in the diagram, O is the center. So automatically O being the center, it means that we have a diameter over here. And anytime we have a diameter, we should think of the formula of the theorem that tells us that this is 90 degrees. And then anytime we have a diameter, we should think of the fact that we have a radius and another radius. And anytime we have a diameter, we should think of the fact that we have a center of a circle. And anytime we have a center of a circle, we should look for angles at that center. So this is an angle at the center, but then this angle is not double any other specific angle, because we don't have this arc subtending any other angle inside our sketch. But then that's just something to remember. This is the radius, this is the radius, this is also the radius. So we already know that these are equal to each other. So automatically this angle is equal to that one, should we ever need to know that. Next, they told us that ON bisects chord LP. So ON bisects this. So they told us that these are equal to each other. Let me just use a different color. Let me just re-add Yefrohiso. Oopsie. Yona admit. Oops, let me go back here. So with everything that we've just mentioned now, right? Let me just color code these here, because they told us that these are equal. Now the one thing to remember is never feel in a hurry. I feel like sometimes in math things don't stick because we just want it to get done now. Like even reading a description, it's always like, let's go to the question. No. That's like the fastest way to do things wrong. So anyways, with all this that they're telling us, these are equal to each other. So automatically, always take in the information without rushing. Automatically, we know that this is 90 because of the theorem that tells us that a line from the center of a circle, if it bisects a chord in half, then it bisects it at an angle of 90 degrees. This is where, again, this always comes in, because the moment we spotted that we have a center here, we were able to see that, okay, fine, formulas that remind us of things coming from the center, blah, 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 blah. All that Chinese. So here now they told us that ON bisects LP at N, T, and S are points on the circle on the other side of LM. So we have LM here, and then we have LP over here. And then they said here on the other side of LM with respect to P. They're just giving us a bunch of information about our sketch here. And then they said chords PM, there's PM over here, it is equal to ST. Well, let's see, chords PM, SM, MP, MT and ST are drawn. So these two, they drew them and they're equal to each other. They told us because here, they've given us that. And then they told us that you have a chord ST here, you have a chord MT over there. That's just interesting information, I guess. Then the last thing here, they said PM is equal to MS and angle MTS is 31. MTS is equal to 31. So you have 31 over there, like that. Like that. So this is like 31. 31. Okay, I feel like we've been given such a lot of information, but from what we said, right, this is obviously going to be 62 because it's an angle at the center of a circle. It is double the angle at the circumference if they're subtended by the same arc or chord, you see. So that's one thing to keep in mind here, that this here is a chord subtending this angle. It's at the center, right? So the angle at the center is double the angle at the circumference. And without rushing also, we can already see that if this is 31, this angle is also going to be 31, because angles that are subtended by chords of equal length will be equal to each other, you see. The angles don't necessarily have to be subtended by the exact same chord. No, the chords just have to be equal, and the angles just have to be at the circumference, you see, meaning they just have to be touching the circle. So this here and this there, it is helping us to see that the angle here is also 31. So we haven't even started with the question, but we have so much information now, because all that information, best believe we're going to make use of it. So, I mean, like this one is a sketch that has dimensions given. So it's normally going to be one of the easier ones, and it should always be. So the first thing here, they're telling us that we should, for 2 marks, determine with reasons the size of each of the following. They're asking for MOS. I mean, like we already said, it's equal to 62, you know. The reason we're saying it's equal to 62, we can easily say angle at center of circle. You see, this is equal to 62 degrees. The reason is angle at center of circle. You see, if you want to add, or if you want to have written something before that, you could have just said MOS is double angle T for the same reason. Angle at center of circle. But then I think to have something that is like easily repeatable, you know, you can just always start with this thing here, #1. Start with this. MOS is double T. Give a reason so that this can be a conclusion. You can then say, therefore, MOS is equal to 62. You won't need to like write the reason again, because it will be a conclusion from what you would have written up here, you see. So this is why this is just going to be 2 marks. If you had just written what we did in the beginning to say MOS is 2 and you give a reason, that's still also worth 2 marks. I'm just writing it like this so that you can maybe just have like a way that is more generic and a way that's more normal, you know. So with this being said, let's move on to this 2 mark question. They want L, angle L. I mean, just from analyzing our sketch, we already worked out what L is. L, we can say it's equal to angle T. The reason is angles subtended by chords of equal lengths. You see? Now then you can say therefore L is equal to 31. That's why this is just a 2-mark question, because there's really nothing major there, nothing crazy. You really don't want to like best your brains trying to like think and all that, because this is really not necessary. You know, you don't have to do that. So let us just move on from here, because there's nothing else to do with this kind of question. So moving on from here, they're asking us for 4 marks to prove that, what are they asking us for 4 marks? For 4 marks, they're asking us to prove that ON is half of MS. Let's see where ON is. And I think I might have to take a screenshot of this so that we don't have to keep scrolling up, because that is just so unnecessary. But I do feel like this question is leaning more towards the easier side of things. I don't want to lie. It is not a difficult question, this one. But I think when we will eventually work on the proportionality stuff, which is probably like in the next session, we shall talk about more difficult stuff. But here they're saying we should prove that ON, where is ON now? ON is a line. They are asking us to prove that it is double SM. So, I mean, like, without even overthinking anything, right? Your best bet is to deal more with PM. Because look, here they're talking about ON. Let me just put this in red. Here they're talking about ON being double SM. So you may want to focus more on ON and PM. You know, just because, I mean, like when they're talking about this being half of ON, it just looks so off. I mean, like just thinking about it myself, it's like, wait, what? Oh, no, it makes sense, because if ON is half of SM, it means that SM is just 2 times whatever ON is. Because look, here if you multiply both sides, if you look at it nicely, here it's like ON is equal to MS over 2. So this is saying ON, if you multiply it by 2, you'll have SM. Okay, that makes sense, because this does look bigger anyways. And you see I'm working with PM and not the SM here, because I mean, like with this question, you just want to see why they're talking about SM in the first place, or MS. Them asking you to prove that this is half of this. I mean, your best bet is to work with PM, because if you work with PM, you will at least be working with this triangle here. Of which, if you're at least working with this triangle here, you can think of things like, you know, the proportionality theorem and work out something, and then eventually just replace the PM with MS. So with all this being said, yeah, this is quite, it's not going to be a difficult question, this one, because you're going to literally just make use of a theorem. You have a triangle here, which is PML. There's a line in the middle here. You already know that from the given description, this is equal to this. And you already know that this is 90 and this is 90, which we firstly have to tell them first. So the moment we're going to tell them that these are both 90, automatically would have proven that we're dealing with parallel lines here. And the moment we would have proven we're dealing with parallel lines here, we are able to say that ON is half of PM. The reason there will be a simple proportionality theorem. You see, it's literally going to be you making use of a proportionality theorem for you to prove your question. Because if you check in like the second Euclidean geometry playlist, there's a theorem here, which is the midpoint theorem. And the midpoint theorem literally just states that if you, I want to look at what you call, I wanted the thumbnail, man. Thumbnail. Just get this thing. There we go. So if you look at what we have here, right? Let me just skip over to a portion after I've written whatever I was writing here. If you look at what this theorem says, right? This theorem literally says that a line, make this bigger, a line parallel to one side of a triangle that intersects the other two sides divides those two sides proportionally. That's what the midpoint theorem says. If you have, oh no, this is not the midpoint theorem. Is it the midpoint theorem? No, mate. Hold on. Come on. Snap. Let me go back somewhere. Let me see here. Move some more. Where I think I drew two images. Midpoint theorem. Oh yeah, okay. So from here, right, with this first set of images, you can see that if you have lines that are parallel to each other and you have, let's say, this here being equal to this over there, right? You want to keep in mind that your theorem literally states that if you have a set of, let me write it in words here also. If you have a picture just like what we have here, if you have, let's say, a triangle, right? And one line inside that triangle is parallel to the third side of your triangle. If you have an image like this, right, where your parallel line inside your triangle is cutting one side of your triangle in half, then automatically this one here will always be half of whatever this one is over here. That's simply put the theorem. So before even diving too much into the theorem, let's firstly prove that ON is parallel to PM. Let's prove that first. So to prove that, we're going to state the following. We're going to say ON is perpendicular to LP. The reason for that is just line from center of circle. That's the first reason why we're saying that this is 90. Now we need to tell them that P is 90. Angle P is also equal to 90 degrees. The reason there is angle subtended by the diameter of a circle. Perfect. So with those two statements being said, we have shown that this is 90 and this is 90. So as a conclusion, we need to tell them that ON is parallel to PM. So here we can say, therefore, ON is parallel to PM. You see. So the moment we have told them that ON is parallel to PM, we're practically done with what we need. Because I mean, like, the fact that LN is equal to NP, that's given. So we might as well state it. So we've proven that these lines are parallel, check. The next thing is we need to tell them that we know that these two lines are equal to each other because that's a given, check. So since these are parallel and these two lines are equal to each other, and these are also equal to each other, let me just state that as the last thing because those are red eye. LO is equal to OM. This is red eye. You see, so this is like proper the midpoint theorem, because the midpoint theorem just says that if the line inside your triangle is parallel to one side of your triangle and that line cuts the two sides of the triangle in half, then this line here will always be half the one over there. You don't even need words to say anything. All you will be able to do from here is, because you have proven the midpoint theorem, because you have shown that this is parallel to this, and you have shown that these are equal and these are equal, automatically you can then say this statement up here. ON is going to be equal to half of PM. Your reason there is midpoint theorem. You see, because the midpoint theorem states that as long as this is happening, the line here will be half of that one. So if this was like 30, this would be like 15. So here, because of what we have just written, the next thing is we just need to show them that PM is equal to MS. And that's just something they gave us, you see, given. So then here as a conclusion, you can then say ON is equal to half of MS. And the one thing to take away is that from the beginning, we did not even worry too much about the MS because the MS is just a rogue line. It's just somewhere there random. So you then proving that this is half of this. I mean, like, you have to remember, anything you need to prove, never think that you need to do some special gymnastics or something crazy. No. Always try to think simple. And the way you're going to be able to think simple is if your head is always like in this kind of a space, you see, where you'd have like gone through multiple past papers and you low-key like know the trends now to say that if they're going to speak of a line here and then they're going to speak of one that's a bit far off, it's just weird. So you want to think to yourself, instead of you working with these two lines, work with at least something that can be aligned in a way that allows you to use, you know, a pre-existing theorem or a pre-existing law. Because if you can use a law that is already like in existence, you will always be in a better space. And I think someone here sent a message. Sir, I think you can't hear me. I was asking a question right now. Was it on the Zoom session? I'm like, if you're asking a question and your mic is off, then I will not hear you. So yeah, I'm just putting it out there. But anyways, let's see here. Let me write here your mic. No, via the voice call. The voice call? Hold on. Let me see. Let me ask again. If you can hear me, just ask again. If you're saying you're on the voice call. Because also just check if your mic is like not muted. Because if your mic is muted, then that's a problem. Are you saying something? Yeah, I can hear you talking, but yeah, it's like you're so far, like I can barely hear, and the volume is like on 100. Oh yeah, now I can hear you. It's just from. Oh wait. Oh yeah, say something now.
Hello, sir.
Oh yeah, there we go. What's up?
Okay. So I wanted to ask, it was that part of where you said the angle O is equal to 2 times 31 degrees.
You mean the 62 part?
Yes, sir. Sir, I don't really fully understand it because I thought you were going to do like angles in the same segment and make angle O equals to 31 as well.
Not necessarily, because you see with the portion of O that I'm referring to is just this part only, you know, because remember this part here, you have an angle going to MS, right? Because I mean, like, if you look at where MS is subtending two angles. It's subtending this angle at the center, and it is subtending this angle at the circumference, of which our theorem states that if you have an angle at the circumference, it will always be double the angle at, if you have an angle at the center, it will always be double the one at the circumference if they're subtended by the same arc or chord. You see? Yeah.
Understood, sir. Yes. Thank you, sir.
Away. Anyways, so from this whole thing here, I think we might as well call it a day from here, to be honest, because I think this one was just way too much info. But then with this kind of a question, I mean, like, it's just literally the midpoint theorem. You know, it's literally just the midpoint theorem. It's just the midpoint theorem, of which yes, there we go. This is where I wanted to pause. It says here, a line segment joining two midpoints. You see a line segment here joining two midpoints of two lines of a triangle is parallel to the third line, and it is half the length of the third line. That's the midpoint theorem, meaning if this is x, this will be 2x. That's exactly what we did over here. We just proved that this, we didn't even have to prove it actually. We just had to say, okay, this is equal, given. This is equal, given. These are parallel. Okay, that's the only thing we had to prove actually. But we actually didn't have to prove it, because I mean, like, the whole midpoint theorem would have allowed us to make use of what we would have said. But then us having to proven that this is parallel, I mean, like, by all means, Fine, we did it. We proved these are parallel, we proved these are equal because it was given, and this is just red eye. All that is automatically what led us to say that this ON is half of PM because of the midpoint theorem. And then from there, we were able to say that PM is the same as MS, it's given. So wherever PM was, we just threw MS over there. And then we were done with the question. With Euclidean geometry, the proportion, whether you're dealing with the proportionality theorem or whatever it is that you'll be dealing with, you just need to be comfortable working with ratios. And this question, why does it look so familiar? Yeah, I feel like I did this question recently. Like, it's so weird. I feel like I literally did this question, like, I don't know when, either yesterday or the day before. It's just the weirdest feeling. But anyways, let's see. It says here in ABC, right? In the diagram, K is a point on AB. Oh yeah, I did do this question, like literally, but it's fine. You'll see. So it says here K is a point on AB such that the ratio between AK and KB is 3:2. So anytime you're given a ratio on like a line, always write it out as the numbers with variables next to them to show that you're not working with lengths of the lines, you're working with ratios. So here they told us the ratio AK to KB is 3:2. So you might as well put X's over there to show that you're dealing with ratios and you're not necessarily dealing with the actual lengths of the lines. So with that being said, the next thing here, they told us that N and M are points on AC. So you have N and M, which are points on AC over there, such that KN is parallel to BM over there. So these are parallel to each other, perfect. And then lastly here they said BM intersects KC at L. And then they said here the ratio between AM, which is this line here, and MC is 10:23. So again, if it's a ratio, make sure that you put a variable next to the value to show that it's not like the actual length of the line. It's just like the ratio between the two portions of your line. So the ratio here is 10:23. So you can just put there 10y and 23y. So let me put here 23y. Okay, moving on. With our given information, right, I feel like the first question is obviously not too bad. It says, determine with reasons the ratio of the following. I feel like the next time I schedule a meeting, I should change the settings to like auto join or something, because yo, goodness. It says, determine with reasons the ratio AN over AM. So if you're gonna determine the ratio AN over AM, that one is a bit simple, because anytime you need to get a ratio right, try and focus specifically on the specific portion of the sketch that is relevant. You don't have to use everything all the time. So for AN and AM, you clearly just need to focus on this portion of the image here. There's B here, there's K here, there's N here, there's M over there, and then there's A over here. Now looking at that, here we already have 3x and 2x. On the other side, you need to be careful now. The other side, we also have a portion of a ratio. You see, they told us that this whole line is representing 10y. So the whole line is representing 10y. So what you need to do is, if you're gonna get the ratio AN to AM, you actually don't need to worry too much about the whole 10y there. The reason being, we have enough information up here. And this is what I mean. In terms of the other portion of our line here, this other side of our proportionality theorem, or whatever we call it, we can already see that we have quite enough information to write out an expression. So automatically, we already know that AN over AM, Ed, I have to say that again. AN over AM, if you write it out, AN over AM. If you think of the motion that we using, if you think of the motion that we're using to write that out, we say here AN over AM, right? AN over AM is technically going to be equal to 3x over the whole thing, which is just technically going to be like 5x. Let me repeat that, you see. So if you look at what happened down here, we said AN over AM. So on the other side of our sketch, we know that would be AK over AB. You see, so we might as well even like write that out first before we end up writing this out, so that you're able to like communicate with the examiner. But then what we just showcased now is basically like the end result of what we're doing. So here AN over AM is the same as AK over AB. The reason for you writing all this out would be the proportionality theorem. And the one thing that I do recommend as we go through these questions is don't feel the urge to be like taking notes. You see, the best you could be doing is to just observe what's happening, so that you have like specific questions to ask if something I say is a bit weird. So having to have written this, you can then say therefore AN over AM is technically going to be the AK there, which you have a value for, it's 3x, over AB. The entire AB is just 3x plus the 2x there. So that's just 5x.
Sorry.
Yeah, what's up?
Can I ask? Oh,
Yeah.
no, I see. I was about to ask, do we keep the same variable for the other two sides? But I see you cancelled the x. The
Away,
x, sorry.
away. Nice, nice. So yeah, exactly. So what just happened here is exactly what you can do whenever you have a question. You can just switch on your mic and then start talking, you know, and then these ears will pick it up and I will stop. So this one was pretty simple, right? The next one though, for 3 marks, is saying we need the ratio between CL and LK. Let me just add Leo, and then we shall carry on. So with what we're asked now, right, in this follow-up question, we're asked for the ratio CL and LK. So whenever you're asked a question, right, always try and focus specifically on the portion of the image that may be relevant for what they're asking. Don't worry about considering everything all the time. So here, CL over LK, right? If you look at it nicely, it is specifically a portion that is going to deal with this part of the image, because we have here K, and then we have here L, and then we have here C, and then we have here N and M, right? So that we have, and then we also have these parallel lines here. Yeah. This is parallel to that. Yeah. And now if you look at the question again, I don't know why I gave myself so little space. Like, goodness. Oh yeah, what's up?
So I have a question on the first question, 8.2.1. You said AM is, you said before here you said that AM is equals to 10y. Now why are you now saying AM is 5 now?
Okay, yeah. So what we're trying to keep in mind is, if we had information on this side of the image. So if you look at our sketch, right, remember what we have so far is just ratios. These are not like dimensions for the lines. So the 3:2 here is giving us the ratio between AK and KB. So because of our proportionality theorem, we already know that as long as you have a ratio for like this side of your sketch, that same ratio applies for this side of the sketch, you see. So in as much as we know that this is like 10y, it's not relevant for our question here, because the 10y, all we know is it will just be split up using the ratio 3:2 if you wanted to write this side in terms of the y's here. But I think the follow-up question here, we are going to make use of this side of our image, and you'll see how we're going to incorporate the 10y and the 23y there.
Okay.
Cool.
Yeah.
Sure. Fantastic. And I feel like I left out something in this question. It doesn't feel like it is complete, because I remember going through this. When did I go through this question? Yeah, I went through it sometime on Saturday also. But we'll see. So with the question we're dealing with now, we said that they want us to get the ratio CL over LK. So if you are just thinking of your proportionality theorem, right, you already know that them talking about CL over LK, you know, if you write out that ratio, let's write it out. CL over LK is technically going to be equal to CM over MN. You see, because what you do up here, you just want to repeat the same down here because of your proportionality theorem. Hence why this is the reason for writing all this, proportionality theorem. So the reason for us writing all this is because if we incorporate the bottom section here, at least this bottom section has something we can use. You see, the bottom section here, if you look at what we were given in the beginning, the entire CM here is basically being represented by 23y. Now the issue is the entire AM is being represented by 10y. So our issue is that even though with our original sketch here, we know that we're supposed to get CL over LK, right? Now we know that CL over LK is the same as CM over MN. But our issue is we have something to represent CM, but we don't have something to represent MN. So what we need to do is we need to get something to represent MN so that we can throw that over there. Because if you're looking at what we wrote down now, right, in terms of us getting an answer, for CM, we will have something to put there. But then for NM, we don't have anything to put there. So we have to find something to put at MN. Otherwise, you see what we have so far is incomplete, because at least this, we're looking for this over this, right, which is just this over this figure here. So this we have, fine, we'll be able to put 23y over there, but then we don't have anything to put here. So we have to find something we can throw in here for us to eventually get our 3-mark answer. And this is how we find what to put here. So remember we spoke about how this entire line is being represented by 10y. So the idea is, if you're focusing on this image now, right, let's remove these arrows for now. If you're focusing specifically on this image here, what you know is, according to the proportionality theorem, the ratio between AK and KB is just 3:2. It also means that the ratio between AN and NM is also 3:2, because that's how the proportionality theorem works. But then the big issue now is on the bottom side of the sketch here. What we know is, for us to be able to work this out mathematically, I'll just add this person quickly, admit, for us to be able to work this out mathematically correct, what we need to do is this entire line here, we know that it is being represented by 10y. All we need to do is we need to split up this 10y using the ratio 3:2. I'll repeat. This entire 10y here, we just need to split it up using the ratio 3:2, because the ratio 3:2 up there, the same applies down here because of the proportionality theorem. So it's just like sharing a number using a ratio. You see, and this is how you share a number using a ratio. So technically, what we need to do here is we need to share 10y using the ratio 3:2. You see, now if you're going to share a number using a ratio, this is how you do it. You add up the two values of your ratio, which is going to give you a 5. And then all you do is, for this value on the left here, you're going to say 3/5 times the number you're sharing. For this value on the right, you're going to say 2/5 times the value you're sharing, you see. So your answers here will give you what goes for this portion and what goes for this portion. So in your calculator, you already know that this is going to be like 30/5, which is just going to give you a 6. Here, this is going to be 20/5, which is just going to give you a 4, you see. And if you look at the 4 and the 6, the 4 and the 6 added together give you a 10, you see. So you sharing a 10 using the ratio 3 to 2, it's giving you 6 and 4 there. So because here we're dealing with 10y, I mean, it just means that if you had a y here and a y there, these would just come out as like 6y and like 4y, you see, because the issue here is just the number side of things. So that now we know the ratio is 3 to 2, but then the whole thing here is a 10. So it means that this part, it's being represented by 6y. This part is being represented by 4y because the whole thing is 10y. However, it's being split up using the ratio 3 to 2. So because we now have something to put where an is, something to put where nm is, and something to put where mc is, it makes our question easy now. Because if you're looking at what we are supposed to prove, we have something for nm now, you see, of which we didn't have it in the beginning. So with what we wrote, we know that this is going to give us our first, let's just say our first mark, you know, this statement here. We've written out that the CL over LK that they're asking us to prove, it is equal to MC, or rather CM over MN because of the proportionality theorem. After writing this out, all we need now is to put figures into our expression, and then we'll be done. So here we said CL over LK, it is equal to the CM here, which is being represented by 23y, over the MN here. And we now know what MN can be written as. MN can just be written as 4y, you see, of which now if you simplify some more, your CL over LK is going to be 23 over 4 there, because the y here counts as the y there. Now, us keeping the y's and all that stuff, it's for us to stay reminded that what we're actually dealing with is just ratios and not like actual lengths. And the other thing to take away from this question is, if you're working on one side of a question, right, like one side of a line, depending on what ratios you were given in the beginning, right, you need to be careful to not make the mistake of leaving out the y's and all that, because if you do stuff like that, you eventually get confused. So us leaving the y here and the y there, it is what helped us to figure out what to put over here and what to put over there. It was all a matter of focusing on a specific portion of our sketch, because if you think of it, this portion of our sketch, it helped us with the first question. We got our answer. Now, for this second question, we had to focus on specifically this portion of our sketch. And we said that up here, we don't have anything, but then whatever is up here, it is equal to whatever is like down there as a ratio. So down here, which is this line here, we had stuff in terms of y. So we had the 23y there, and then this whole thing was a 10y. And we said the 10y here, we just need to split it up using the ratio 3 to 2 for us to get something there and something there. Because the moment we did that, we were able to throw in something for mn, which is what we needed in the first place. And then we have here our final answer.
Sir.
Yebo.
So, sir, you know, I approached the problem in a different way. On calculating CL over K over LK. So what I did, I added 3x plus 2x, which I know it's equals to 10y.
Oh yeah. Technically speaking, because the 3 and the go on.
So then I solve for x, which is equals to 2y. I divided both sides by 5, and then I got 2y, which is equals to x.
Okay. No, I think I get it. I think I get you. I think I get you. Because I think what you're saying is, in terms of like the difference factor between what's up here and what's down here, you worked out and saw that the difference is just a 2. Because you see here, there's a 3. This side, you'd need to have a 6, which is 3 times 2. Here, there's a 4. This side, here there's a 2. This side, you have a 4, meaning that you'd need to just multiply by 2. So, yeah, with whatever you're saying, I get it 100%. So if it works out to eventually giving you the 23 over 4 here, then it's still 100% fine.
Okay.
Perfect. So Moving on to question number 9. Question number 9, it's out of 6. You're not well, at least it just means all 6 marks at the same time, you see. So we don't have to like stress too much. So with question 6 there, no, question 9 rather, let's see what it says. In the diagram, tangents are drawn from point M. Where is point M? Okay, so you have point M over there, and you have a tangent there, you have a tangent over there. So they have told us that Km is equal to MB. But then, as long as this is a tangent from one point and a tangent from the same point also, it means that these are equal because tangents from the same point will be equal. And it's also going to be equal to that third line over there, because this one they told us, these two they told us, this one we wrote it out because of, you know, our laws. And then here it said, in the diagram, tangents are drawn from point M outside the circle to touch the circle at B. So touching the circle at B and N. And then it says the straight line from B, where is B? Straight line from B passes through the center. So keywords like passing through the center is stuff that you should never.
Can I ask why?
Yeah.
Can I ask why it's equal to K? Oh, you just removed the diagram. Oh, Km. How
okay,
does
yeah.
it become equal to?
Oh yeah. So if I zoom in here, you can see that the Km part is given. You see, this part they gave it to us. Yeah, these two were given, and then what we said was, yeah, from what they told us, these will be equal as well because tangents from the same point. But yeah,
Thank you.
I think you're doing good. You see, if you have questions, like don't be scared. Like I'm literally all the way wherever. I'm probably on the moon right now, so no one is going to hurt you if you ask questions. Okay, that's not necessary. But anyways, so what am I saying here? I said here, you have B. They said here B, the straight line from B passing through the center. Words like this, don't take them for granted, because anything that passes through the center, I mean, like you're gonna have a diameter, and sometimes if you had a triangle, that was gonna help you. But then here there's no triangle, so it's like, meh, it's fine. And then it says here, passing through the center, it meets MN. Wait here, B passes through the center of the circle, meets MN, produced in A. Okay, this is just going there. So they just have weird ways of like narrating the diagram. And then they say here, NM is produced to K, such that BM, there's BM over here, is equal to MK. That is given. And then they said here BK and BN, they just threw them over there. And then you have the angle here, which they have labeled as X. Now for 6 whole marks, we literally need to determine with reasons, the size of N1 in terms of X. So us eventually determining N1 in terms of X for 6 marks. I mean, I don't mean to be too forward or anything, but anytime you're supposed to get something in terms of X and they offer you like a lot of marks, like don't panic. It just means you're probably maybe going to just do a lot of writing, but then it doesn't mean the question is difficult. Because I think with Euclidean geometry, sometimes they just offer way too many marks for something straightforward. So the idea here would be, in your sketch, try to get as many angles as you can in terms of X. For example, here, firstly, this is where X is. Like, try and like populate this whole sketch with stuff in terms of X, not just randomly, but then, you know, it just has to have some form of meaning. For example, if this is X, right, you also know that B1 is also equal to X. So you might as well state it and give a reason. You see, that's where your 6 marks are going to be coming from. Statements with relevant reasons. So here we can say that K is equal to B1 and they are both equal to X. The reason is angles opposite equal sides. And then with that being said, we need another angle that is equal to X. So 10 chord theorem. Okay, that's kind of really awkward. So I'm really wondering why this question is out of 6, because it's like, wait, what? Oh, no. I was about to make a huge mistake. I was about to say 10 chord theorem, but then this point is not in the circle. So yeah, that was not going to work. So I think that was also a bit of a red flag because it was like, nah, man, that's too simple. So this is x, and we're trying to get other figures in here some way, somehow. So one way or the other, let's see. What we know is this whole angle here is going to be equal to 90, but then I don't think that's useful in some way. What else do we know? We can get m1 in terms of x, and then obviously depending on what I'm going to be saying, if you have any suggestions that you want us to exploit or dive into, like, don't hesitate, don't be shy, don't be scared. None is here to judge you, you know. You can just say, what's up?
I actually have a solution.
Pardon?
No, I wanted to ask a question.
Yeah, sure. This is Leon, eh?
Yeah, it is.
Away, what's up?
Can we not say that M2 is equal to x to k to angle k?
Away. Nice. Yeah, let's go. Yeah, M2 is equal to K plus B1 because exterior angle of a triangle. Nice. Perfect. So automatically that's going to give us more information in here, because if these two angles are equal, we're able to get the value of N1 because of properties of an isosceles triangle. So the first thing we need to tell them, though, is we know that these are equal. You see, so the danger with Euclidean geometry is, if you know something, always make sure you put it on your answer sheet. Don't just keep it in your head. So in as much as we put this equal to the other side, we need to tell them we know they are equal. So let's do that first. NB is equal to MN. The reason is tangents from the same point. Tangents from the same point. So tangents from the same point are equal, right? So now we know that we have told them that these are equal. So automatically we have also told them that B2 is equal to N1, or we might as well just tell them. So don't be shy to like write out stuff that are relevant on your answer sheet. So B2 here equal to N1. The reason there is obviously angles opposite equal sides, you see. So hence why the 6 marks. Just write out statements that are relevant with reasons as well. So now that we have said all that we have said, it looks like this question is practically wide open now, because now we can easily say something like, because of these two statements, now we can say N1 is equal to 180 degrees minus 2x divided by 2. Our reason for that will just be interior angles of a triangle, because what we know is all the angles here should add up to like 180 anyways. But then what we have already told them is that these are equal, and we have already told them that they're equal because these sides are equal, you see. So you will be comfortable to write out stuff like this as long as you know that you've fully supplemented why you're ending up with this statement. So from here we can just solve for N1, right? Of which N1 here is just going to be 180 divided by 2, and the 2x divided by 2 also. I mean, another way is you could have taken out a 2 as a common factor, and then you already know that the bottom there, the 2 cancels the 2, and then you have N1 equal to 90 minus x. Perfecto. So yeah, I think that whole the portion where this is 2x, this is literally where the question was opened, because yeah, it's also something very subtle where it's not always easy to spot stuff like this. So thank you very much. So nothing crazy with this 6 mark question. It looks like they were just giving us 6 marks for writing out quite a few statements and quite a few relevant reasons. So with the next question though, out of 5, this is a classic question, and anytime you'll hear me say something is a classic question, I'll be trying to say that it's so common, they ask it so often, and the way to answer it is just the same all the time. Because here, let me maybe grab this image so that I don't keep having to like come up here all the time. So let us do this. Let us hope this thing is so, and let us do that. And then survey. So with what they're asking here, right? Let's see what we can do. For 5 marks, they're asking a very straightforward common question. Now they said we should prove that BA is the line over there. we are supposed to prove that BA is a tangent to the circle passing through KBN. You see, so if you look at KBN is this triangle over there. Now this triangle over here, they said it is a triangle inside a circle. Obviously the circle is not there, but what they're trying to say is we should prove that BA would be a tangent to a circle that would be passing through these 3 points. So to just illustrate, if we have a circle passing through these 3 points like that, this circle here, we need to just basically show that if this image is possible, we just need to show that the 10-chord theorem is also something that is taking place over here. So from the top, all questions that will ask you things like you should prove that a line is a tangent to a circle passing through certain points. All you need to do is to prove that you have the 10-chord theorem playing out in your sketch. So in our sketch here, all we need to already do here is we just need to find a way of showing that the angle here is equal to the angle up there. You see, because as long as you show that the angle here is equal to the angle there, then you would have shown that this is definitely a tangent to a circle that passes through all those points over there. You see, so it's just like the 10-chord theorem in reverse. You have to prove something to be equal where this is at a tangent and this is somewhere in there. And then you would have proven that you can definitely draw a circle over here, and this would be the tangent to that circle. So let me just write out the B here because it's covered, write up the A here, write out the K. So us showing that these are equal, the fortunate thing is we already know that K is X. So we need to find a way of writing this as X as well. And I think from our original sketch, writing this as X, it doesn't look like it's going to be a mission. Fortunately, because we were told that MB is a tangent. MB is a tangent and BA is a diameter. So any tangent and any diameter or radius will always meet at an angle of 90 degrees, you see. So automatically we can write down MB is perpendicular to BA. The reason is just tangent perpendicular radius. Because this is just the radius, but then it's the diameter. They told us in the description here, they told us that you have a line passing through the center. That's why this is underlined, because any information like that will always be useful. So us knowing that this whole angle is 90, like it's making our lives so much easier. I'm not even sure which color to use here so that this thing pops. Let's maybe use a purple, purple. So this is 90. So if this is 90, right, we also worked out that the green parts here, we worked it out to be 90 minus X. So let's put that information over there because it's clearly going to be useful to us. 90 minus X. And the one thing with Euclidean geometry is you just need to be able to cope with the chaos. You know, when you see angles flying around and dimensions flying around, yeah, don't panic. You know, just take it all in and be calm. So here, let's put our 90 minus X over there because we worked out the N1 to be 90 minus X, but these are equal to each other. So this tiny part here is 90 minus X. So, I mean, like, with what we have just said now, it looks like our question is almost practically done because we say that the whole thing is 90, right? And we want to tell them that B2 is equal to 90 minus X. Let's just tell them B2 is equal to N1. This is something we've proven already. So now we can then say B2 is 90 minus X. So as long as we told them that the whole thing there is a 90-degree angle, and we have told them that B2 is 90 minus X, we can easily use that to get B3. Because technically speaking, B2 plus B3, this is equal to 90 degrees. I mean, like we proved it. It's proven. You see, because when we said that MB is perpendicular to BA, we were saying that this angle is 90 degrees. It's something we have already proven. So from this statement, we can just now throw in the values that we know so that we can have a value for B3 specifically. So carrying on from here, B2, we know it's just 90 minus x. Yeah. Let's go.
Could you kindly repeat the part now from MB is perpendicular to BA, please?
Yeah, definitely. And I'm glad you also asked, because even as I'm saying it now, I'm just like, you know what, Nim? This whole MB and AB part, it's straightforward, but at the same time, it's not very out there. So I'll use a clear image. If you look at our dude, it is. So if you look at your sketch, right, the whole angle here, this line, right, is perpendicular to AB because of the theorem that says a tangent is perpendicular to a radius. Do you see that?
Yeah.
So that's what we were able to say. We were able to say that B3 plus B2 is equal to 90 because of a tangent is perpendicular to a radius. You see that part, right?
Yes.
Perfect. So what we were also able to say, which we have already proven, is that the angle here, the B2 specifically, is equal to 90 minus x. The reason why B2 is equal to 90 minus x is because B2 is equal to N1, because we proved that they're equal to each other way up here. You see, N1 is 90 minus x, so automatically it means that B2 is also 90 minus x, of which B2 is this part over there. You see it, right?
B2. Oh, yes.
Yeah. So as long as we have a value for B2, right, which we can write as 90 minus x, and we have a value for B2 plus B3. Remember, B2 plus B3 is the whole thing that's equal to 90. Do you see that?
Yes.
Yeah. So all we're doing now is, we know that in this equation down here, we can just throw the value of B. Yeah.
You said B2 minus x. Why are you subtracting x?
No, B2 is 90 minus x, because that's the expression we got from N1. You see, N1 is 90 minus x. You see it, right? Yeah.
Yes.
But then N1 is equal to B2 over there. You see that also, right?
Okay. Yeah.
So that's how we know that this is 90 minus x. So what we're saying now is, in this equation that we have written down here, we're just going to throw B2 over there and solve for B3. Because remember, that's all we want. We want to show that B3 over here is equal to that angle up there. Yeah. And to do that, it's coming out from this equation. So that's why B2 is here. We have thrown in there 90 minus x, right? And then B3 is here. And then the 90 is here. So isolating B3, you're going to have the 90. When this goes over to the other side, this is going to be like minus 90 and then plus x. And then you're going to have B3 here as x. You see that, right?
Yes.
Perfect. Of which, that's what we wanted from the beginning. From the beginning, all we wanted to do was to show that the angle here is equal to x. You see, because as long as we can show that the angle here is equal to x, we would have shown that it is equal to the angle up there. And as long as this angle down here is equal to the angle up there, we are showing that we have a 10-chord theorem there that is like playing out. And as long as the 10-chord theorem is like playing out here, it means we would have proven our 5-mark question. Because our 5-mark question wanted us to prove that BA is a tangent to a circle that would pass through those 3 points. So from all that we have done here, you will literally just be able to write out what they have asked us as a conclusion. So here you'll be able to say, therefore, B3 is equal to K, and then here, therefore, BA is a, let me just delete this part here. BA is a tangent, also need to delete this. BA is a tangent to circle KBN, and here you can just say 10-chord theorem. 10-chord theorem. Because all you would have done here is you would have shown that the 10-chord theorem is something that is being upheld by our sketch. And as long as that's happening, it means that this is a tangent to the circle that would pass through those 3 points. So I did say that this is a classic question. And the reason why they like asking it is because I don't know. It's just one of those things where almost one in every, I don't know, like almost, I know it sounds a bit exaggerated, but I would say a good 80 to 70% of all the papers always ask this question. And the idea behind this question is always the same. Always spot which angle would be equal to the angle inside your triangle. And then always try and show that they're equal to each other using whatever laws or methods you can. Of which the one thing that has helped us here is definitely our theorems, of which you'll always hear me say, you can just always use this acronym to help you remember theorems, DRCPT, you see, because diameters help you remember theorems, radiuses help you remember theorems, cyclic quads, parallel lines, and tangents. So that is that for this 5-mark question over all there. So let me move on to the next question here out of
So
6.
for that question,
Yep.
the one we just did right now.
Mm-hmm.
So you said your final reason is 10-chord theorem, right?
Mm-hmm.
So now, does it count? Because isn't it converse? The converse, does it matter if you write the converse or you just keep it as 10-chord theorem?
Oh yeah. Well, I think, well, the good news here is at this point in time, right, after you've done all this, this is where that portion of work really is a bit obsolete. Because whether you wrote converse or whether you just wrote the 10-chord theorem directly, it's all the same at the end of the day. You see, because remember what we have done now is we have proven that this is equal to that. And the moment we've proven that, we have technically proven that there is a 10-chord theorem here that is like being upheld, because the angle at the tangent is being equal to the angle inside the triangle. So after having to have done all this, we can clearly just say 10-chord theorem there. If you wrote converse of 10-chord theorem, that also is 100% fine, because you will technically just be saying that you reverse engineered the 10-chord theorem for you to get your answer. Does that make sense?
Thank you, sir. Yes.
Wait, just Levi is fine, like legit. I promise. Just go with Levi. It's 100% fine. You know, it's literally 100% fine, like legit. I don't wanna lie. But anyways, with this 6-mark question, it's a proof, and it's genuinely speaking one of the most annoying proofs out there. The reason why this proof is so annoying is because firstly it's straightforward, but then at the same time it's like, but then what's the point? It almost feels like it makes no sense. But that's, I think, maybe the one thing that throws people off with this theorem, like how simple it is to carry out this proof. Because you see here, this is saying in the diagram, A, B, C, and A, E, D are drawn such that A is equal to D, B is equal to E, and then lastly, C is equal to F. You see, like that. So with all that being said, they are now saying, they said here, use the diagram. Let me put this thing on silent. Yammer. They said here, use the diagram in the answer book to prove the theorem that states that if two triangles are equiangular, then the corresponding sides are in proportion. That is, AB over DE is equal to AC over DF. So, I mean, with this kind of a proof, right, it's in my opinion one of the dumb ones. And I say one of the dumb ones because it's like, yeah, it's just a lot of writing that's just, it's let me not judge, maybe let me just not be that guy, let me not be extra. So in terms of proving this theorem, right, all you need to do is you literally need to take this image and you need to redraw it in here using different variables. This is what I mean. The first thing you're literally gonna do here is you're going to make a construction. Here you're going to say make construction, or rather, no, that's like a bit vague. What you want to do is, let me just put it this way so that I make it as simple as possible. The first thing you want to do is you want to say here construct, let's name it line, there's A, B, C here, D, E, F. Let's name it GF. No, A, B, C, D, E, F, GH. So here you want to say construct GH, wait for this thing. You're gonna say here construct GH. So this is GH parallel to BC, and then you're gonna say here such that AG is equal to DE and such that AH is equal to DF, like that. So let me put this here equal to that here. That's the first statement you're going to write out, of which this statement here is going to, it's literally like unlocking the whole question to show why this theorem or this proof is quite straightforward. So once you've made your construction and once you've clearly stated that AG is equal to DE and you've clearly stated that AH is equal to DF, you're almost home free here, because your next few steps, all you want to do now is you literally want to now show that this small triangle here is similar to the big one. That's the first thing you want to do. You make your construction. The second thing is your new triangle here, you want to show that it is similar to the big one. And this is how you do it. So firstly, you are literally, you remember your construction, you stated that these parallel to each other. You see, so as long as you've stated that these are parallel and you've stated that this is equal to that, this is equal to that, you will now be able to say the following. So from all you've stated here, you want to also, for the next thing you want to just do is, before you prove that the small triangle here is similar to the big one, all you want to do is to show that this small triangle is congruent to that one. You want to show that because of your construction, this image that you have drawn is exactly the same as this image. You literally just have to state it based on what you have written out. So here you're going to write out that showing that these two triangles are like 100% the same, right? You're going to literally just put the AG is equal to DE because of your construction. And then you're going to say the DE, or rather DF, which is this one, DF is equal to AH, or let me not make it mixed up. Let me just start systematically. So AH there, which is this line, is equal to the DF there, also because of your construction. So because you have shown that two sides are equal, for you to prove congruency, it has to be at least either 3 sides or 2 sides and an angle. So here these are 2 sides already, so it's like one side that you've proven to be equal, one side that you've proven to be equal. So the last thing is you can just use an angle. Angle A is equal to angle D. The reason is given. So from these statements, you can literally then say, therefore, AGH is congruent to triangle AEF. You see, the reason there is side angle. You have shown that a side is equal, another pair of sides are equal, and then you have shown that an angle is equal. So this is why I'm saying this proof is really one of the weird ones, because your construction, after making your construction, the next thing you're doing is something else that feels a bit too dumb, where you're just saying that this whole triangle is exactly the same as this whole triangle. Now, the moment you have done that, you now have the liberty of writing out this. Here you can put your tiny x here to show that these are equal, and then here you can put your tiny dot here to show that these are equal. And then did somebody ask something? I think I heard someone.
I want to ask something.
Away. Let's go.
So you said AGH is equal to AEF instead of, or is it supposed to be DEF? Like I'm a bit.
Oh, okay. No, it's D. It's D. I don't know. I wrote A there.
Okay.
Definitely a D. Thank you so much. Thank you so much. Yeah, no, that was definitely a D. I think when I wrote the A, I wanted to write the triangle symbol, but then it doesn't matter now, because thank you for spotting that. So if I write anything that's a bit off, just let me know. So here we stated that AGH is exactly the same as DEF because of two sides were equal and an angle. So the moment we have done that, we have the liberty of clearly showing that this angle is equal to this angle and showing that this angle is equal to that angle. So with all that being done, we are almost home free now, because literally us proving congruency is what has allowed us to know that this is equal to this, this is equal to this. So all we need to do now is to show that the small triangle here is similar to the big triangle over there, so that we can write out our proportionality expressions and all that.
Sir,
Yep.
Could you kindly repeat the part about angles which are equal to what, to which angles?
Oh, okay. You mean the B, the A and the D?
You said.
Oh no, you mean, oh okay, oh yeah, yeah. Okay, okay. Yeah, so remember what we did now was, according to our construction and with what we have just written out here in white, we have shown that this small triangle is exactly the same as this small triangle. Do you see that?
Yes, yes.
And then do you see that the angle E here is now equal to is the same as the angle G there? You see that, right?
Yes.
And then the angle F there, pardon?
The reason?
The reason is they are congruent. Remember, these two triangles are congruent to each other. Congruent means everything is the same. All angles and all the sides are the same. So the moment you prove congruency, you would have proven that everything of the two triangles is exactly identical. That's why we're able to say E is equal to this, F is equal to that. And because of that, it automatically shows us that this is equal to that, and this is equal to that.
Okay.
Yeah.
Okay.
Perfect. So from all that being away, yeah,
So
definitely.
Once we have constructed a triangle, you see the H, AGH. Do we not neglect, but neglect the ABC, the triangle, once we've constructed a new one?
Not necessarily. Not necessarily, because once we've, remember, us making this construction here is because we're trying to incorporate the proportionality theorem for us to end up with this expression here. Because for us to end up with an expression like this, we need an image that looks something like this, so that we are eventually able to say stuff like this over that is equal to this over that, and then we'll be able to say things like proportionality theorem after we've proven similarity. You get?
Okay, yeah, I get.
No, you just go deeper if you need to ask some more.
Like what I'm saying is, right, the initial question was that we must prove that the triangles are.
Yeah, we should prove that AB over DE is equal to AC, right, over DF. So I think I get your question now. So with what we have done here, it looks as though we have not touched anything about the big triangle, but then we're literally just about to now incorporate the big triangle into whatever we're doing. Because do you see that with our sketch now, we have something that looks like this, of which, as long as we have something that looks like this, we are one step closer to ending up with an expression that looks like that. You see? Yeah. So for like a good 60% of the question, the big triangle is almost like something we don't worry about, because the main task, or the initial task, where the bulk of the marks come from, is you just trying to take this triangle and throwing it in there. And the way to do it is, we made a construction, and then we showed that our construction is allowing us to have parallel lines here, this being equal to that, this being equal to that. It's like the dumbest thing ever. But then, I mean, hey, I did not invent this. So once we have done that, we're now able to just show that the small triangle here is similar to the big one, you see. So to do that, I mean, we can just write out the following. Let me also maybe create some space here, because I don't think I have enough space if I carry on doing what I'm doing. So with all that we have said, what we know is we're just trying to prove that the small triangle now is similar to the big one. So what we can say is, in triangle, let's name it triangle ABC, and triangle AGH, what we know is that A is equal to A, that's a common angle. And then what we know is that the AGH there is equal to ABC. AGH is equal to the angle B over there. The reason for that, let's put here, the reason for that, we can literally just say construction. It is the dumbest thing ever, but it is what it is, construction. You see, and the crazy thing with us saying construction here is you could have also easily said something like proven, because we have proven that these two triangles are identical. So us saying that this angle is equal to this angle, it's because this angle is equal to that angle. You know, that's something that they gave us. So because this tiny triangle is now identical to this tiny triangle, us saying that this is equal to this, I mean, like we could write quite a few reasons there, which will all be pointing to our construction and everything that we did. So two angles being equal, the third one, which is going to be the H here and the C over there, we can easily just say they're equal to each other because of interior angles of a triangle. So here, AHG, this is equal to ACB, or let's just name it angle C. The reason there, we can just say interior angles of a triangle. Interior angles of a triangle. So for the small triangle and the big one there, we have just proven that they are similar. You see, so here now we can then say, therefore, a triangle ABC is similar to triangle AGH. You see, and the reason is just angle, angle, angle. This is now allowing us to literally almost end the question now, because as long as we've written this out, we can now say stuff like AB over AH, AB over AH, I mean AG rather, is equal to BC over GH, BC over GH, which is also equal to AC over AG, AC over AH rather, AC over AH. The reason for writing all this is now just proportionality theorem, you see, which is what you were gunning for the whole time. The whole time you wanted to have a sketch like this so that you can use it to write out a proportionality expression. Because from what we have written out here, now we can easily go back to our original question and we can end the question now. Because you see here, from our original question, right, we can already see that we have AB over there, there's AB over there. We have AC over there, there's AC over there. However, for the bottom lines here we have BE, we have DE and DF, of which, let me just get a color you saw that we were using. Let me also write this nicely, because this doesn't look like a G. So what I'm saying is, from what we have here, right, if we take this and we take this, we will eventually end up with what we have at the top there, because AG, if you look where AG is equal to DE. We have stated that very clearly. And then if you look at the DF here, we also know that the DF is equal to the AH. So all that is stuff that we have already proven nicely. We've given them reasons, blah, blah, blah. So from this statement, we can then just conclude and say, therefore, from all these three, we can just take the AB over the AG equal to the AC over the AH. So from here, we know that we can just say, but AG is equal to AG is equal to DE. That's been proven. And we also know that AH is equal to DF. That's been proven. DF. So here you can say, therefore, AB over DE is equal to AC over the DF there. You see, which is what they wanted us to prove in the beginning. And we were able to prove that by literally just taking this tiny sketch, throwing it in there, showing that this tiny sketch is congruent to that one based on our construction. And then the tiny sketch there, we showed that it is similar to the big one, so that we can end up with a proportionality sketch, so that we can write out our proportionality expression, of which these expressions here allowed us to get this. And then the moment we have this, we're home free, because whatever is at the bottom here, we know that this we're able to replace it. So with the question that we have here, I mean, as with all Euclidean geometry questions, the description is like a proper big deal. You see, so it says here in the diagram, O is the center of the circle. So automatically, the moment they tell us something about the center of a circle, then we would want to keep in mind that as long as we have a center of a circle, we should look out for a diameter. And we do have a diameter here. It is line DE. And the way this shape is laid out, it doesn't look like we're going to have a problem with this sketch. So as long as we have a diameter, it means that this angle subtended by the diameter is 90. We might as well put that there. And then it says here, it is O is the center of the circle and CG is a tangent to the circle. So automatically, the moment we know that something is a tangent to the circle, we need to keep in mind theorems that deal with tangents. Like for example, here we have a point, right, where our tangent is touching two triangles actually. So in this shape here, we have to be careful. I think we're going to see two sets of the 10 chord theorem, because if you look at G1 here, right, G1, the tangent here is line GC, right? The chord is GB. So the 10 chord theorem always says that the angle between the tangent and this chord, right, will always be equal to the angle that is subtended by that chord. You see, so this is the chord and this is the angle that this angle is going to be equal to. So that's the 10 chord theorem, like the one side of it. And then, I mean, like wherever there's one side of the 10 chord theorem, there'll always be another side. So if you look nicely, right, if you look at, let me actually draw this triangle as purple so that everyone can see what is going on here. So in this purple triangle there, we have the 10 chord theorem, right? There's a purple angle and a purple angle. However, there's another one on the other side. So this blue, if you look at the 10 chord theorem, right, at this point here, you have another angle, like a big one. This angle, you can see here, its chord is the line AG. So if this is the line AG, this angle here is going to be equal to this one over there. But then I'm not going to waste time like maybe showing all the angles that are equal and all that, because we're going to spend forever, and most of them we might not even end up needing them. But what I'm maybe trying to highlight now is just be on the lookout for this kind of information. Like for example, with our other shape here, the other one that also has an angle of 90, what we know is this angle here is the angle at the tangent, and then we have a chord over there. So this chord is the chord that is subtending this angle. So it means that this angle over there is equal to this one over there, you see. So we have quite a lot going on in this sketch. I mean, the last thing that we can mention before carrying on with the description is the fact that AOB is also a diameter. So automatically you know that G3 and G2 is also equal to 90. You see, so let's just remove this for now so that we don't have like too many lines flying around and all that. We will just need to keep in mind that we have so much information with this sketch. And anytime we have so much information like this, it's a recipe for one of two things, either a disaster or just, the ultimate bliss. But anyways, it says that the straight line from C passing through O cuts the circle at A and B. And then it says your diameter DOE is perpendicular to CA. I mean, CA is a straight line, but then AB is a diameter as well. And then it says GE and CA, GE and CA, those are just random lines, they intersect at F. And then it says chords DG, BG, and AG, they are just lines that are drawn. So the idea with your description is never read your description as though you're just reading subtitles from a movie. You want to read it and then observe the sketch. Read some more, observe the sketch, read some more, check where that scenario is happening, and then you're good to go. So for 3 marks, right, the first thing is that they're asking us to prove that we have a cyclic quad somewhere. So they're asking us to prove that D, oh, good Lord, Mary Quessa, Mary, like asking to be married, or that's her name. Sorry, I'm not See that guy. So D here, we have D, G, F, and O, right? So this shape here, they are asking us to prove that it is a cyclic quadrilateral. So anytime they'll ask you to prove that something is a cyclic quadrilateral, it means that the 4 points of that shape are not touching the circle. If the 4 points were already touching the circle, we would not need to prove that we have a cyclic quad. Now, just from all the information that we have, though, it's like a lot of information that we had, we know that angle G3 and G4 is a 90-degree angle because it is an angle subtended by the diameter of a circle. We know that this is 90. So in terms of proving a cyclic quad, we know that there's only one of three ways. You're either going to show that opposite angles add up to 180. That's the one way of doing it. The second way of doing it is you're going to show that an exterior angle is equal to an opposite interior one, an exterior angle equal to an opposite interior one. The third way of proving a cyclic quad is you need to look for lines where you have like some form of a zigzag effect, right? And then within that zigzag effect, you would need to prove that this is equal to this, or this one is equal to this one. So those are three ways of proving a cyclic quadrilateral. So in our case, we fortunately are going to use this first way of proving a cyclic quadrilateral, because this first way of proving a cyclic quadrilateral, we already know that it is the viable option for 3 marks. So here we just have to tell them that DGF, we know that this is equal to 90 degrees. The reason there is angle in semicircle. You see, might as well say that. And I don't know why I'm not writing this down here where we are given the space to do so. So that's the first thing we're writing down. We have written that this is 90. Now this is also 90. I mean, like, that's a given, you know. This is angle DOF, because we are going to show that opposite angles add up to 180. So DOF is equal to 90. That one is a given, you see. Therefore, what we can see here, or what we have shown, is that DOF plus DGF is equal to 90 plus 90, meaning that DOF plus DGF is equal to 180 degrees, you see. So here we would have proven that we're dealing with a cyclic quad, because we've proven that opposite angles are adding up to 180. So this question was amongst, I'd say, one of the simpler ones. So here you can then just say, therefore, DGFO is a cyclic quad because opposite angles are supplementary. Supplementary, we know it just means that they add up to 180. Supplementary. I should not spell out words because I will most likely spell them wrong. So anyways, that's that with this cyclic quad question. If there are any questions before moving on, then you can ask. I see there's someone asked something in the chat thing. So what is going on? Sorry, sir. Can you please save it? I forgot to have classes today. Can you please save it? I'm not sure what you mean by can you please save it. I think you mean I should record it, but anyways, that is already happening because all the sessions are recorded anyways. But then just in case, right, I'll just put my number here in case someone wants to, like, maybe the link to this after this or whatever. 1872 Kablamo, so that at least, oh, direct message. Oh man, I wanted to send it to everybody. Let me see, everyone, just in case. And I'm getting distracted now. 9671872. I hope I don't regret this either. Yeah, okay. It says here, for 5 marks, right, we need GC. We need to show that GC is equal to CF. So proving that two lines are equal to each other. Is somebody asking a question? Nope, nobody's asking a question. So I might as well mute the mics. Mute. Anyway, so they're asking us to prove that GC is equal to CF. So let's see where GC is firstly. So GC is there's G and C. Okay, so this is GC, and what's the other one? CF. Okay, so I mean, if you're going to prove that these two lines are equal to each other, always try and think of properties of lines that are equal to each other. Or also look at how, if you're looking at where GC is and you're looking at where CF is, I mean, those are two lines inside a specific triangle, you see, because if you look at GF here, and if you look at CF here, and if you look at GC there, we have a triangle over there. Now, our task is quite simple. We just have to prove that this line over here is equal to this CF over here. Now, the easiest way to prove that two lines are equal is to prove that the angles opposite the sides that are equal are also equal to each other. Let me repeat. All we have to do is to prove that this is an isosceles triangle. Now, the one way to do it is to prove that angle G1 and G2, which is this white angle here, we have to prove that this angle here is equal to that angle down there. That's our task. Before we carry on, I'm scrolling. I literally scrolled down here because I wanted to double check what is the marker location. The reason behind double checking the marker location is so that you have an idea of like how much you should think, how much you should write. Now, I might as well maybe like take an image of this and then just crop it and like work down there, because yeah, I don't think scrolling back up is going to be helpful. So any 5-mark question in Euclidean geometry, the best thing you can do for yourself is to not panic, because most of the 5-mark questions in Euclidean geometry, they are 5 marks because they just have, you know, a mark for statement, a mark for reason, a mark for statement, a mark for reason. So it's easy to like rank up 5 marks just from a Euclidean geometry question. And we'll use this as an example. The one thing I can also say up front is if you're going to prove that two angles are equal to each other, don't focus too much on these specific angles. Focus more on angles that are equal to these individually. For example, you want to find something equal to this angle here, and you then want to find something equal to that, and then you take it from there. So the other thing you never want to forget is anything that you would have proven or anything that they would have asked in like a previous question, don't take it for granted. So what I mean is the first thing you'd want to do here is let's get angles that are equal to F1. Let's get angles that are equal to this portion of G there. So to do that, let's maybe start with F. You just literally want to look for stuff that are equal to F1. You see, so let's find here. F1, firstly, F1 is going to be equal to D. The reason F1 is equal to D is because the shape in red here, we've proven that it's a cyclic quadrilateral. So as long as we've proven that this is a cyclic quadrilateral, we can easily say that F1 is equal to angle D. The reason there will be exterior angle of a cyclic quadrilateral. Exterior angle of a cyclic quadrilateral. Now that we have done that, you want to just keep on going, right? You literally just want to ask yourself, okay, fine. We're not even going to be long with this one. Here, if you look at G, and if you look at where angle D is, we have there the 10-chord theorem. I might as well even draw it again because this is a bit of a mess. So if you see here, we have our circle, right? Now, in our circle, we have the line GC. GC is a straight line like that. Oh, now let me make that a bit better. We have the line GC here, right? It is a tangent to our circle. They told us we have the line GC, it's a tangent. There's G over here, JC over there. I'm pretty sure as I'm talking now, you probably already see it. Because you see here, right, we have a tangent, which is the line GC. And then we have a chord. The chord here is GE. GE is our chord, right? And then this chord is subtending angle D. Angle D is up there. There's this D over here, and then this line goes straight down like that. You see? Now, our 10-chord theorem is telling us that the angle over here, which in our image is just G1 plus G2. You see this angle here, the whole thing. That whole angle there, right, is equal to this value of D. You see? Because angle D is subtended by this chord here, you see, of which this chord is the chord that is meeting our tangent there. You see, that's what the 10-chord theorem says. The 10-chord theorem literally just says that the angle between a tangent and a chord will always be equal to the angle that is like opposite this chord. You see, that's the 10 chord theorem. So that's how we're able to now write out that G1 plus G2, or rather we can just call it FGC. FGC, we're just going to say it is also equal to D. So let's write that down. FGC, FG, which is FGC over there. We're saying it's also equal to D, but then the reason for this one is just 10 chord theorem. You see? So for a 5-mark question, so far you can best believe you probably have like a good 4 marks. Statement, reason. Statement, reason. So the idea now is you've shown that both angles here, the F1 here and the G over there, you've shown that they are both equal to D. So as long as you've shown that they are both equal to the same angle, you've shown that they're equal to each other. So as a conclusion, you're just going to write out here F1 is equal to FGC. You see, it's a conclusion because you have shown that they are both equal to D. This is where your 3rd mark, no, this is not, okay, your 5th mark is more joined. Because the moment you've said this, now you can say therefore, therefore GC is equal to CF. Your reason there will be sides opposite equal angles. You see, because these are equal angles that are opposite to each other. You see, so as long as you've shown that these opposite angles are equal, you will also have opposite sides that are equal to each other, and that will get you your 5 marks. So you can already see your 5 marks did not come from you writing a lot of things. Your 5 marks came from you being strategic with whatever you wrote. Because even if you did it the other way around, you could have firstly started by saying the angle here is equal to that because of the 10 chord theorem. And then you could have said the angle here is equal to that because exterior angle of a cyclic chord, and then still end up with the same conclusion there. It's literally just like that. So I think this one was just a fortunate 5-mark question. Nothing crazy, nothing major. Let me see here. No questions. Fine. So yeah, anything that we're going to be saying, if there are any questions, if anything is not like 100% clear, you can just switch on your mic and you can just ask. You will not be interrupting in any way. It's just the best way. Okay, you will be, but not like in a bad way. But you kind of need to do that so that we don't like go on and we're doing something and you're not like, understanding and stuff. But anyways, for 3 marks, it says, it is further given that CO is 11 units. Where is CO? CO is over here. So the other thing is, if you look at your sketch, right, it gets messy quite easily. But then try not to get overwhelmed, you see. That's why also maybe in your sketch, try to put things that are relevant. That's why you saw in the beginning, the moment we started like saying things like, 10 chord theorem, blah, blah, blah. I mean, we didn't put too much information because it can get crazy very fast. So with what we have here, they told us that OC is 11 units. So that's the whole line over there, including a portion of the radius. And then it says DE is 14. Where is DE? DE is 14. So what we already know is that DE, I mean, without forgetting, DE is our diameter, right? The whole line is 14. And we know that as long as a line is a diameter, it means that the radius is equal to the radius, you see. Now, the other interesting portion of our question here is they told us that OC is 11. So if OC is 11, we know that OB is a 7 because OB is the same as the OE over there, and it is the same as the OD over there because the radius is half the diameter. So this is 7. Automatically, we know that this is going to be like a 4 if we ever need that information as we need it here. Well, I don't think it's a coincidence because, I mean, they're not going to give us this random information to ask an irrelevant question. So getting the length of BC here, we can already see our focus is not going to be on BC. Your focus should always be on the information given. You see, whatever question they ask, try to focus more on the information given. In this previous question, I mean, that's a different story. But then here, we're just going to write this out in words, right? We're gonna need to say that OE is equal to OD, and then it is also equal to OB, which is red eye. So E is equal to OD, and it is equal to OB, because those are just the radius lengths of our circle. So this is just radii. So because you've shown that you're dealing with, the radiuses of a circle, you already know that. Therefore, let's just pick one of these two. Therefore, OE is equal to 14 divided by 2, which is like 7 units, you see. It's just you trying to communicate with the examiner. Remember, with your math questions and Euclidean and all that, the whole point is to communicate with the examiner. You don't need to think that you need to do things in a fancy way or things that are like very spontaneous and very special. No. Whatever you do, just make it as basic as possible, just so that your examiner can understand what's going on. Because remember, here you have just shown that this is a 7. So now you can also then say, therefore, OB is equal to a 7. You're just trying to communicate with the examiner. You have told the examiner that everything here is the radius of a circle. And then you have told the examiner here that you know the radius is a 7. Furthermore, you have told the examiner also that OB is also then going to be equal to 7 because it's also a radius of your circle. So all that information, both you and your examiner now know, you both know that information. So obviously here you can then say, therefore, BC, you just need a calculation now. BC is going to be equal to OC minus OB. And you have to think to yourself, you don't need a reason for writing this statement out. It's a statement purely being written specifically directly from the sketch. If you want to be funky and put the reason here as given, that's still 100% fine. Because according to your sketch, the length of BC, you're going to get it by taking OC and you're subtracting OB over there. So even if you wrote given or not, that's not an issue. It's just more of a conclusion based on all the information that is just, overwhelming anyways. So BC here is going to be 11 minus, oh, no, I meant OB, sorry. I wrote BC again. So oopsie, remove that, OB. So I have to say that again. The length of BC is equal to the entire OC minus OB over there. So yeah, that was going to be interesting. So anyways, 11 minus 7 there is just going to give us a 4, and that's 3 marks. Nothing crazy, nothing major. So with this next question, we definitely have to be a bit more creative, right? So they're asking for the length of CG. Now, the idea is, if you look at where CG is, right? CG is in quite a weird position. But then the thing is, we have just worked out BC, you see. So they've given us the length of BC here, or we have worked it out rather. Now they're asking for GC. Now, looking at our entire image, it's just a mess. It's like a proper mess. We have 7 over here, we have 4 over there, and they're asking us for GC. So the idea is, with questions like these, if you look nicely, right, we really haven't been asked much about, the proportionality theorem and all that. So the hint here is most probably going to be some proportionality theorem in a way. Now the idea is, if you look at GC, right, and if you look at the BC that we've just gotten, GC and BC, they are in the triangle BGC. You see, so this triangle here, let's try and see which triangle could be similar to this triangle. And then let's also try to think to ourselves, we have a length here, right? In which other triangle do we have figures? Now the only other triangle we can think of is this big one over there, you see, because for this big triangle here, right, which is ACG, triangle ACG, we practically have, this entire length here, because it's 4 plus the 7 plus another 7, because remember, with a circle, all the dimensions of the radius are the same. So this is 7 plus 7, which is 14, plus the 4, which is 18. So here we have a full length, and then in this tiny triangle, we have a single length over there. But then, so if you look at it nicely, for the big triangle and this tiny one, they have a common angle C already. And they also have G1 equal to A1, equal to A there. So automatically, the small triangle here is similar to the big one there, because remember, with triangles being similar, you just need 2 angles that are equal to each other. So for this particular sketch, we are finding out that let me just do this here quickly. Come on, man. Well, we know that this angle is a common angle for the small one and the big triangle. And we've also proven that G1 is equal to A. So, I mean, like, let's just use that to prove similarity first, and then we'll eventually be able to work out a length of GC using our proportionality theorems and stuff like that. So let's see how we're going to label this. Let's label it triangle BGC. Let's put here in triangle BGC and triangle, we'll have to label this one GCA. So let's put here GCA, because remember, you want to make sure that your angles match. So what we already know is that here the common angle is C, you see. So, oh no, oopsie. Let's see, BGC, let's see, BGC, okay, BGC. So this one will have to call it GAC. Yeah, GAC. We have to call this other triangle GAC. So here we have GAC. Perfect. Now, with all this information known, right, we already know that the C here is equal to this C. That's a common angle. Common angle. Like we can see it in the sketch here. C is a common angle. And then here we can say G1 is equal to A. That's already proven. G1 is equal to A. That is proven. And then for the last angle there, right, we will just say interior angles of a triangle. So here we can just say AGC is equal to B1. So here AGC is equal to B1. The reason there is interior angles of a triangle, because remember, when you're going to prove similarity, you just need two concrete reasons. The third one, you can always just say interior angles of a triangle. So from here, we can just say, therefore, triangle BGC is similar to triangle GAC. And then from here, we are able to write out, BG over GA. BG over GA is equal to GC over AC, which is also equal to BC over GC. Okay. Now the good news here is, remember, we're looking for the length of CG. CG, GC is exactly the same thing. So if you look at the expressions we have, right, this here and this here looks like what we need to use, because here there's the CG that we're looking for, right? Let's see what else we are given. Let's see where is BC and AC. BC and AC, I mean, BC, we have a dimension given. AC, we know the whole thing is 18. So we're literally good to go. So from here, you can just write your reason here as proportionality theorem. And then carrying on from here, you can just use these two, right? So here have GC. AC, we will know it's like 18. BC, we worked it out to be a 4. And then this is also GC. If you cross multiply here, let's actually now just write it as CG squared. And then this one is going to be what? 18 times 4. Whew, Uncle Calculator, please help us, because we will need to know the answer. Let me just check it out here. What is 18 times 4? 18 times 4 is equal to 72. So we have 72 here, and obviously if you square it both sides, here you're gonna have 72 there, here you're gonna have GC. Perfect. Anyways, let's move on. Here they want the size of E. So them wanting the size of E here, it's going to be a bit easier for us. But you also just have to be creative, because here they want the size of E, right? They want the size of E. So them wanting the size of E, like, don't forget that we have just worked out GC. Now the fortunate thing is GC is exactly the same as like FC. So them looking for E, I mean, like, you could think to yourself, I mean, like, we have a right angle triangle here, the big one, and we only have the length here, which is 14, but that's not going to help us. Fortunately, angle E is in this triangle also. So in this triangle, fortunately, we have a 7 here. OF, we can work it out, because remember, FC is equal to GC. So FC is also equal to that number we just worked out. Let's just tell them we know that. FC is equal to CG. That's a given. So I mean, like FC is also equal to square root of 72, you see. So let's see. We know that FC is square root of 72. So we have FC there. The whole of FC, we have it. So we can get OF because technically how are we gonna get OB now? We need OF. Let's see. Okay, wait. We have FC, right? So if you remove a 4, you're gonna have FB. And the moment you have FB, you can remove it from OB to get OF. But then why do all that? Just take OC. We can just take OC here, right? And then remove FC to get OF. Yeah, let's do it. We say here OF is going to be equal to OC, which is the whole thing, minus FC. So it's OC minus FC. So OC, remember, it is just 7 plus 4, which is like what? 11, right? So it's 11 here minus square root of 72. Yeah, let's just leave it this. Let's just leave this the way it is. This is what OF is. OF is this length. So if you look at what our sketch looked like, we had this thing here. We had OF here, which we now have a length for. We have a 7 here. Now we need E. So it looks like we can just use normal trigonometry here. This is going to be opposite over adjacent. So that's a 10. So 10E is opposite over adjacent. This is going to be E there, or E. So here 10E is going to be this length here. You can just put this into your calculator. Whenever, all this you can just put in your calculator at once. So OE is what? 7, right? So since you need E, I mean, like, you're just going to do shift 10 with that, with this whole thing here, of which you can put it in your calculator all at once. You see? So this is 7 over there. There you go. There you go. Therefore, E is equal to what now? Yo, calculator, please help us. Calculator, please do your thing, because this is where our brain thinking what comes to an end, eh? So let's see what we're gonna get here. Yeah, we kind of have to be careful. In the calculator, we are getting 19.76. Nice. Okay, so this paper, it was quite interesting. Now, I mean, like, everything we've done, right? You have to remember that you are always able to find it on the what is this? You're always able to find it on, like, in terms of like deeper descriptions and like deeper explanations of like the different topics. You can always hop onto the course platform, because there's a course for each and every topic in your entire syllabus. You see, now your best bet is the all access pass. You see, the all access pass, I mean, like, if you've gotten this far, I'll give you a discount code that you can use. You see, the discount code here is like BYB50. It's gonna give you 50% off. You see, 50% off on the all access pass, though. All access pass. All access pass. You see. So once off, the all access pass is like $299 as of this recording. So once off, it's just gonna be 1499.5. And you include, it also includes the study guide. That's for the once off offer. You see. But then if it's a monthly subscription, then I mean, the original monthly subscription is like $799. But then if you apply this discounted checkout, it's obviously going to be half of that. You see. But then this one does not include the study guide. The only option that includes the study guide is the once off option. You see. So let's say here once off. Let me write here once off. Come on, bro. I write once off. Once off. You see. If you want to get the study guide on its own, let's say here alone. The study guide alone is $449, you see, of which shipping is free nationwide. But anyways, that is all from my side. If you need anything, you can always just hit me up on IG. My IG handle is LE_EVY. So LE_EVY. You see, this is the IG handle. But anyways, don't forget to like, Don't forget to subscribe to the channel, because obviously these are the kinds of questions that, or these are the kinds of videos that we make on this channel. It's like full past papers from start to finish for math without leaving anything out. But yeah, man, that's that from my side. I will catch you in the next video.